Welcome back, guys. This is question 3.1 of chapter number 3, which is related to the random variables and probability distribution. Okay, so in this first part of our question, what we are going to do, let us see. So classify the following random variables as discrete or continuous. Okay, so as you may have known that there are basically two types of the random variables. The first type is the discrete random variables as listed here, and the second type is continuous random variables. So we have to identify that which of the following are the discrete and continuous one. Okay, so let us first see the first part here, and that is X, the number of automobile accidents per year in Virginia. Okay, so here we can very clearly see that in order to see the number of accidents in Virginia per year, so if we have this line and here we have to see these are the months, okay, and these are the accidents on y-axis. So we can very clearly see that either those would be 0, 1, 2, 3, 4, 5 or so on. Okay, so these all of these has been taking a discrete values. Okay, these are basically showing us the number of accidents which are basically either this is, let me have here the 1, here this is, let me have here this is 2. Okay, this is again in the second month we have here 2 accidents and so on. Okay, so this is what this is all about, the discrete values, and accidents can have a whole number. I mean, these can be 1, 2, 3 up to infinity, okay, or 1000 and so on, and it cannot be 1.5, 0.5 and so on. So this is basically the discrete random variable. Okay, this can be represented by this discrete valued graphs, and therefore this X is what? This is the discrete. Okay, so I have been writing them here with this DIS. Similarly, in second part, Y, the length of time to play 18 holes of golf. Okay, so the length of time here can range from any value to infinity. Okay, so it can either be 1.77 seconds. Okay, it can also be 20 seconds. Okay, it can be 1.7859 seconds or 200.259 seconds. I mean, the time can range from 0 to any value, so this all values would be continuous. Okay, you cannot discriminate between these two values. Okay, so therefore these will be so close with each other that you cannot distinguish between them, so those will follow a curve like this one. So therefore the second one, or Y here, will be what? This would be the continuous random variable. Okay, so I hope you have understood my point, that wherever you can distinguish between the values, here you will see that this is a discrete, and wherever you cannot distinguish between the consecutive values, this will be the continuous, okay, or the continuous random variable. The third one here is the amount of milk produced yearly by a particular cow. Here we can also see that we cannot distinguish between the values because it can either be 1.7 kgs or liters. Okay, it can be 10.85 liters. Okay, it can also be 21.5897 up to infinity. Okay, so these are all the values which the amount of milk can be composed of. So therefore this value is again what? This is again the continuous random variable. Okay, so you have understood the essence behind this question. So similarly, and the number of eggs laid each month by hand, so therefore it cannot, we can also see here that the number of eggs cannot contain 1.5, 1.6 or all the numbers which are composed of this decimal value. So these would be 1, 10, 2, 5. So therefore this is again the discrete random variable. Okay, the number of building permits issued each month in a certain city. So the number of permits will also be composed of the discrete values. It cannot be 1.5, 1.7, 2.7, 2.8, 3.8 and all the values which composed of the decimal points, but it will be a value composed of the whole number. So therefore this is again the discrete value, okay, as we have mentioned before. Similarly, Q, the weight of grain produced per acre, okay, again the number or the weight of a grain produced per acre can range from 1.7, 0.0, 0.111, 0.789 and it can contain any value. You can see that the weight can be composed of any value. These will range from 0 up to infinity, and here all the values cannot be distinguishable. So therefore this is again a continuous random variable, okay. So you have seen here the answers. This is the answer of the first, this is the second one, this is for M, this is for N, this is for P, okay, and this is for the Q1, okay. So that's it for today, in which we have seen the difference between the continuous and discrete random variables, how to see that whether a certain random variable is continuous or discrete, okay. So that's it for today, and I will see you with some more interesting stuff like this one in our upcoming video. So see you soon. Welcome back, guys. This is question 3.2 of chapter 3. And the statement of it is, an overseas shipment of 5 foreign automobiles contain 2 that have slight paint blemishes, okay. So if an agency receives 3 of these automobiles at random, okay, so basically the agency has been receiving 3 automobiles which are selected in random, okay, and of these automobiles list the elements of the sample space using the letters B and N for blemished and non-blemished, okay. So B for the blemished, okay, and N for the non-blemished. So respectively, then to each sample point assign a value x of the random variable x representing the number of automobiles with paint blemishes purchased by the agency, okay. So now here we have a random variable x, which is what? Which is a random variable and which describes the number of blemished automobiles, okay. So now here we have to find the number x which represents x, okay. So here we have to write them as well, okay. So let me write them here as well. So here first we will write here the sample space or the combinations, total combinations we will have, and here let me write the value of x. So what is x? The number of blemished, okay. So now here the first element here would be what? Let me have all 3 non-blemished, so I will have here N, okay, as we have 3 automobiles. So therefore if in random we can have here 3 automobiles which are non-blemished, so here the value of x would be 0, okay, because no B is available here. Similarly N and B, because here as we have only one B, so we can write here 1 because the number of blemished here are 1, okay. Similarly N, B, and okay, here again 1 and B, okay. So what is this? Now we can see that here we have 2 blemished cars. Similarly here, now starting it like B and we have 1 B and B, we have 2 B's, and at the end what would we have? Let me check that how many combinations we have. So 1 2 3 4 5 6, okay. So let me have here as well 1, again B, and here again 2, and the last one here would be B, and the value of x would be 3. Okay, so this is the solution of the question like this one, in which we have seen the number of the blemished cars as the random variable. Okay, and on the basis of it we have described the solution of our question. Okay, so this is basically the illustration of how to find out the random variables and how to miss out what is not available, and that is what the essence of the random variables. Okay. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Question 3.3 of chapter number 3, which is related to the random variables and probability distributions, and the statement of it is, let W be a random variable giving the number of heads minus the number of tails in 3 tosses of a coin. Okay, so let me write here the given data. Okay, and in this given data we have a random variable W, which is the number of heads. So let me represent the number of heads with H, and okay, minus the number of tails. So let me write it with this tau n. So this is a random variable which basically shows the number of heads minus number of tails in 3 coin tosses. Okay, so how many coin tosses we have? We have 3 coin tosses. Okay, so this is the given data up till now. So list the elements of the sample space as for the 3 tosses of the coin, and to each sample point assign the value W of W. Okay, so what is W or omega? This is the value which corresponds with the values of this W. Okay, so this can be this W can have either 0 value, it can either have 1 value, okay, and it can also have 2 value as well, or any other values. We will see that. So this is what this W is. Basically these are the values which corresponds with the event which is here. Okay, so let me write all these values here in all 3 tosses. Okay, so let me write here in solution the tosses or the sample space. Okay, here we have to write the number of heads, here tails, and here W. Okay, so let me proceed with this. So let me have this table here. Okay, so the first toss here, which is, let me have here all the heads. So it would be heads in all 3 tosses. So here we can see that we have 3 heads, 0 tail. Okay, and W, we can see that this W corresponds with heads minus tails. So here we will have here 3. Okay, similarly heads, tail. So now here we have 2 heads, 1 tail. So therefore 2 minus 1, which is W, and this would be 1. Okay, similarly heads, tail, heads, again 2 heads, 1 tail, and here I will have 1 as well, and at the end heads, tail. So here I have 1 heads, 2 tails. So therefore the value W would be minus 1, because 1 minus 2 is minus 1. Similarly now tail, heads. Okay, so now we can see that we have 2 heads, 1 tail. So here I will have 1. Similarly tail, heads, tail. Okay, so now we have here 1 heads, 2 tails. So 1 minus 2 would be minus 1. Okay, similarly tail, heads. Okay, now we have 1 heads, 2 tails, and the value of W would be 1 minus 2. So this would be minus 1, and the last one here would be tail. So 0 heads, okay, 3 tails. So 0 minus 3 would be minus 3. So let me see that how many combinations we have. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the sample space we have, and how many items would we have here. So let me again see the same box concept here. So we have 3 tosses, and in each toss we have 2 choices. We can either have heads or tail, heads or tail, heads or tails. So it is here again. So 2 multiplied by 2 multiplied by 2 is 2 raised to power 3, which is 8, and that's why I have at the end counted the number of combinations here to check that whether all the combinations corresponds with the actual number of combinations, or did I miss any of the combination here. Okay, so that's why I have cross checked them. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.4 of chapter 3, and the statement it has is: a coin is flipped until 3 heads in succession occur. List only those elements of the sample space that require 6 or less tosses. Is this a discrete sample space? Explain. Okay. So basically we have here two parts of this question. In first part we have to show all the elements in which the 3 heads in succession occur, but there is a fundamental constraint that those tosses doesn't exceed 6 tosses. Okay, so therefore now let me solve it, and writing them all the solution, let me first have here all the tosses in which first 3 would become the heads. So it would be head, heads and head. Okay, so this is the first possibility. There is also a second possibility that first we will get tail, then heads, and then heads, then heads. So this is again 4, which is less than 6. Okay, again there is a possibility that we would get first tails, then heads, heads and heads. Okay, so these are basically 5, in which we can see that here we have 3 tosses, which results in 3 successive heads. Okay, similarly we can also have here heads, tail, heads, heads and head. Okay, so there is another possibility. After it we can also have here tail, 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 and then after we can get heads, heads and heads. Okay, so therefore we have got here 6 tosses. Okay, similarly now we can have here heads, tail, tail, heads, heads, heads. Okay, similarly heads, heads and then tail. Okay, and then heads, heads and head. Okay, so these are now 6, and we have seen that we have reached to the limit where tosses can have. Okay, so these are the 6 tosses which are the maximum limits, and after it we will exceed the number of tosses. Okay, so these are all the possibilities or the sample space which we have here, and we can very easily see that these are all the discrete elements. Okay, we can see here that these discrete elements either can result in 3 tosses, here we have 4 tosses, here we have 5 tosses, similarly 6. So we can see that these are composed of the discrete values, and we cannot represent anything here with the numbers which are consist of the decimal point or anything just like this, or the fractions. Okay, so therefore this is basically the discrete event, or all the elements here are discrete in number. So we have here the discrete sample space, and that is for today, in which we have seen the solution of question 3.4, and I hope you have understood the essence of the questions like this one. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.5 of chapter 3, and the statement it has is determine the value of C. Okay, so we have to find the value of C so that each of the following functions can serve as a probability distribution of the discrete random variable x. Okay, so here we have part A and part B. Okay, and we have to solve them for certain values of x which are given here. Okay, these are the values or x-axis. So if you have a function here, let me have here the function f of x here. Okay, this is the probability distribution function, and here we will have x such that all the values of x would be here. Okay, so this will be 0, 1, 2, 3. Okay, so this is what, let me have this corresponds with the part A of this question. Okay, so before solving the questions like this one, let me tell you one thing here, one supposition and one thing which you must have here. Okay, so suppose we have here different probability density function. Okay, here, so if we have here one, let me use this color here. So if I have this one here, this here, this one here. Okay, so in order to have this, if this is A, the value of it is A here, the value of A, this is B here, and its value here is, let me have C. You must keep in your mind that the summation of A plus B plus B, all of this will give me this one. Okay, why? Because all of these are basically the probabilities. A, B, C, these three are the probabilities. That's why this is called a probability distribution, or PDF, or in some other ways this is also called probability mass function as well. This is probability mass function for the discrete random variables. Okay, and for the continuous one, this is called a probability density function, or PDF. So these are the terminologies we would have here, and in order to solve this thing here, I am going to give another example to you guys here. So let me have a coin, okay, which is tossed 2 times. Okay, so we have a coin which is tossed 2 times. Okay, so what are the possibilities in this coin? So either I will have here heads heads, or heads tail, or tail heads, or tail tail. Okay, so we have different possibilities here which are basically given here. Okay, so let me have here x, which is a random variable, and this x is, let me call it the number of heads. Okay, so in the number of heads, we can very clearly see here that the number of heads here are 2, the number of heads here are 1, here the number of heads is again 1, and here the number of heads is 0. Okay, we can clearly see here that in order to find the probabilities here, these are basically the numbers. Okay, so let me find the probabilities here as well. So how to find out the probabilities? So in order to find out this probability, first of all, I have to write the sample space. In sample space, I will have here heads heads, heads tail, tail heads, or tail tail. Okay, similarly, in terms of the probability distributions and random variables, the value of x will range from 0, 1, and 2. Okay, so here we can very clearly see that what is the probability of 0. So we can see that the 0 probability basically corresponds with this element where I have got 2 tails. So therefore the probability of the tail is how much? We can see that here the number of the elements in which only one tail occurs is here, and that is what the number of heads is 0, and this is the number of elements here in which this condition is satisfied. This is 1 divided by the total number of elements in the sample space, so this is 1 by 4. Okay, similarly, let me write here the probability of the heads equal to 1. How many numbers we have here, or how many items do we have here which satisfies the condition which is mentioned here? We have here 2. Okay, so this one and this one, and we can very clearly see that here we have the total number of elements in the sample space are 4. So therefore writing 2 divided by 4, I will have here 1 by 2. Okay, and similarly the probability of the heads equal to 2, again the number of elements which satisfy the condition in which heads is equal to 2, it is only 1, and then the total number of elements. So here I will get what? I will get 1 over 4. Okay, so in writing them all here, let me use this one for the problem which we are dealing now. Okay, let me remove it now, and then this is what? This is a random variable x, which is basically the number of heads, okay, and this is, let me have here, this is f of x, which shows the number of heads. So I can have here the 0 number of heads, okay, or I can also have 1 head or 2 heads, okay. So let me draw them here. So for the probability distribution function here, how to draw it for the heads equal to 0, let me write the value here, and that value is basically here, and let me write it here, and this is here, okay. This is 1/4. For the heads equal to 1, we have this function, and let me have here this 1/2, and writing it here, this would be here. And similarly for heads equal to 2, this is 2, and on the x-axis we have this 2, and let me write its value here, and this is 1/4. Let me draw it here as well, okay. So these are all the values which we had. Now this is 1/2, this is 1/4, this is 1/4. So in probability distribution, adding all these values, just we added them here, a plus b plus c. When I will add 1/4 plus 1/2 plus 1/4, which are the values, corresponds with the values 0 head, 1 head, and 2 head, and these are the values of the probability distribution function here. What I will get here, I will get here 1, okay. So that is basically the essence of the questions like this one. In this question, I have told you the essence of the questions in this one, in which the cumulative probabilities in the probability distribution functions will ultimately give me what? Will ultimately give me 1, and this rule can be summarized with PDF underscore I from I equal to 1 up to infinity. Let me have, so it will give me 1, and that is the rule which we are going to follow in this question, okay. So in this short discussion, I have told you how to tackle or target the questions like this one. If you have any question, you can ask me in the comment box. In our upcoming video, we will solve question 3.5 and afterwards. Thank you so much, and I will see you soon. Welcome back, guys. This is question 3.5, which we have discussed in our previous video, and I have explained that what will be the essence of the concepts which will be used here, okay. So I have to determine the value of c so that each of the following functions can serve as a probability distribution of the discrete random variable x, okay. So let me first solve part A of this question, and here the value of fx is what? This is c x square plus 4, okay, for all the values which are given here, okay. So what is basically this? So here let me connect this one with the previously illustrated concepts, okay. So here I have f of x, and this is, let me have the values of x here, and all the values ranges from 0, 1, 2, 3, okay. So what are these values? These are all the values which have been mentioned here, okay, and this is what? This is f of x. So if I will draw something here, let me have some random distribution here, here, and here. For all the values of this x, I have to see that all these values, this, and this is a, b, c, d, okay. So a plus b plus c plus d, this should give me 1, because this, in this way, this will be the probability distribution, okay. So in order to do so, let me have here the formula, which is f of x equal to cx square plus 4, okay, and all the values here ranges from 0 to 3. So therefore I have to write here what? I have to write here x equal to 0 up to x equal 3, and here this would be c x square plus 4, okay. Or let me expand it. What I will get here? I will get here c let me start it from 0, so it will be 0 square plus 4, okay, then plus c, and then I have to write x. After 0 I have to write here 1, so here it will be 1 square plus 4 plus c, here now 2 square plus 4, okay, and the last one here would be 3 square plus 4, okay, and this should be equal to 1. In order to satisfy that, it will be the probability distribution, and the same concept is illustrated here, what we have explained here. So let me expand it further. So by writing it here, I will get 4c here 1 plus 5, this will be 5c, okay, here 2 to 4, 4 plus 4 8, here 8c plus, here it would be 9 plus 4 is 13, so here 13c would be equal to 1, okay. So now add them all together, so it will be 9 plus 18 is 8 is 17 plus 13 is 30, so here I will get 30c, which is equal to 1, which will ultimately give me the value which is c equal to 1 by 30, and that is basically the solution of part A of my question. Okay? So this is the solution of part A. Let me expand it to the part B here. So let me first remove all these things. So in part B, the equation is just like here. Okay? This starts from 0 and ends up to 2. So let me solve it. In solving it, what I have to do here, it will be f of x is equal to c 2x, okay, and 3 minus x. So as it is starting from 0 and ending up to 2, and these values corresponds with this x, so therefore I have to write here x starts from 0 and ends at 2. Okay, so the same probability distribution, if I want to make it a probability distribution, what I have to do, I have to make this summation equal to 1. So this summation should be equal to 1, because now I am summing all these things, and previously I have told you that in probability distribution all the probabilities or the curves should end up in addition of 1. Okay, so let me expand it, and in expanding it, let me first take this c out. Okay, this c is now common in between all of them, so let me try it, and let me start it from 0, so it will be 2 0, okay, 3 minus 0 is 3, so it will be here. Okay, now similarly plus 2, now for 1 I will have here 1, and here 3 and choices are 3 minus 1, so 3 minus 1 is 2, okay, and plus, now here I have two choices, 2 and here 3 minus 2 is 1. Okay, so this and this must be equal to 1. Okay, so now let me solve it, and what I will get here, this 2 0 is how much, that is 2 factorial divided by 0 factorial, and similarly 2 minus 0, which is 2 factorial, because this is the formula for the combinations. Similarly, multiplying it with this one, so this would be 3 factorial divided by this 3 factorial, and then 3 minus 3 factorial, so it would be 0 factorial, and similarly here 2 factorial divided by this 1 factorial. Okay, and now 2 minus 1 is 1 factorial. I have been doing it because I know the formula for the A, choice B, and this is what this should be, A factorial divided by the B factorial whole divided by A minus B whole factorial. Okay, so I have been using this formula. Similarly here I have to use 3 factorial divided by the 2 factorial, and then 3 minus 2 is 1 factorial plus this 2 factorial divided by 2 factorial, multiplying it with the 0 factorial, because 2 minus 2 is 0, and here multiplying it with the 3 factorial divided by 1 factorial. 3 minus 1 is 2 factorial, okay, and this must give me 1 here. Okay, so now let me carry it out. So this will be cancelled out with this one, this will be here with this one, okay, this will be here with this one here, okay, and from it what I will get, let me do it here. So see, and here 0 factorial is 1, so here this all will give me 1 plus this is the 3 factorial. 3 factorial is 3 into 2, that is 6. 6 divided by 1 is 6, okay. Similarly here this is 3 factorial divided by 2 factorial, so 3 factorial is 6. 6 divided by 2 is again 3 multiplied by this 1, so here I will get 3 and this must be equal to 1, and ultimately it will give me 3 plus 1 plus 6, that is 10c, which is equal to 1, and ultimately the value of c will be 1 by 10, and that is the solution of part B of my question 3.5. okay, so I hope you have understood the essence of the probability distributions, that whatever the limit is, all the individual curves should give me what, or all the individual probabilities when summed together will give me 1. okay, so the same concept has been illustrated here, that when these are summed together it will give me 1, and that is what I have explained here. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 3.6 of chapter 3, which is related to the random variables and probability distributions. And the statement it has is, the shelf life in days for bottles of a certain prescribed medicine is a random variable having the density function which is given here. okay, so this density function is basically equal to this value for all the values greater than 0 and 0 elsewhere. okay, so what do I have to find out here? Find the probability that a bottle of this medicine will have a shelf life of A at least 200 days and B anywhere from 80 to 120 days. okay, so in this question what we have to do here, we have this equation for all the values greater than 0, and what I have to do, I have to find the probability, and in order to find the probability of it, let me write this solution, and generically finding out the probabilities between two limits, as we can see here that it ranges from 0 to infinity. So what I can do here, I can just let me have this probability for let me have here x. okay. For it, what I can do, I can integrate it from 0 to infinity. okay, and here writing all these values, so this is 20,000 whole divided by x plus 100 whole cube. okay, so integrating it over all the limit, as we can see here that this is from 0 to infinity, so it will be equal to 1 here, because this is all the values of the ranges which are described here. But if you want to do it for any two ranges, let me describe them here as well. If you want to find the probability for the value of x which is greater or equal to A and less than or equal to B, so in this limit you have to write it from A to B, and this would be 20,000 divided by x plus 100 whole cube, and this should be what? This should be the formula which I am going to use here. okay, so this will be the formula which I'm going to use here. So therefore in part A the values are given here, and in this type of values what I have here, the value of A is, as we can see that this must be at least 200 days. So at least 200 days is 200, A is 200 and B is infinity, which can ranges from 200 to infinity. So let me write these values here. So when I will write these values here, so here it would be 200 and here infinity, so it would be 20,000 whole divided by x plus 100 whole cube and dx. Okay. So let me integrate it, and integrating it, this part, what I have to do, this is the constant part, so let me take it out, 20,000, and now integrating the values which are 200 to infinity, making this denominator the numerator. So with what I will get, x plus 100 and minus 3 dx. Okay, so now doing it, what will happen here in integration, I know the rule of integration, that if I have a value of x of n dx, so here in integrating it I will get here n plus 1 divided by n plus 1. So applying the same rule here with this with these ranges, what I will get here, I will get 20,000, okay, multiplying it with the x plus 100, and minus 3 plus 1 would be x plus 100, and minus 3, this would become minus 2, dividing it over this minus 2, and the ranges here are 200 to infinity. Okay, so now when I will solve it, then I will get here different values, and here let me first cancel it out, it will be 1, and here ultimately what values would I get, so let me write them here. I will get here minus 10,000 whole divided by x plus 100 whole square, and it ranges from 200 to infinity. Okay, so now let me write these values, and in writing these values I have to first put the higher limit. So when I will put this higher limit here, which is infinity, so anything divided by infinity would be 0, so here I will get minus 0. Okay, because 10,000 divided by infinity plus 100 would be infinity as well, so 10,000 divided by infinity is 0. Similarly here, subtracting it from the other limit, so there I will get, now putting the value of 200, so here minus 10,000 divided by this 200 plus 100, this would be 300, okay, whole square. Okay, so it will be just like here. Okay. So now solving it, what I will get here, ultimately I will get 1 by 9, which is what, which is the solution of part A of my question. Okay, we will very easily see that here, this is what, this is this calculation, minus minus will be plus, so plus will be this 0 will be subtracted from this one, so ultimately I will get this positive value. Okay, so that is basically the solution of part A. Similarly for part B, what do I have to do in part B? The only thing here I have to do here is that I have to change these limits. Okay, so in these limits, the lower limit would be 80 and the higher limit would be 120. So now let me change it. So the lower limit here would be 80, higher limit will be 120. Okay, so the final equation I will be having here would be this one, but the only thing here which will be changed here will be these two things. So let me change them here as well. So it will be from 80 to 120, and here what is this? This will be the solution after solving it for the terms which I have done here for part A. You will get the answer which is related to this one. So this is the conceptual overview of finding the probabilities from the random variables or the density functions. If you have any question, you can ask me in the comment box. So see you soon. Welcome back guys, I hope all of you will be fine. So this is question 3.7, and the statement of it is the total number of hours measured in units of 100 hours that a family runs a vacuum cleaner over a period of 1 year is a continuous random variable x that has the density function. Okay, so once you are given that is random variable given is basically a continuous one, so you should keep in your mind that here you will have to use the integration. Okay, so that is the essence of the questions like this one. Okay, so if you have a question like this one, this is the probability density function, and this is fx, ranges from x in the range of x greater than 0 and less than 1. Similarly, 2 minus x for the x ranges from x is greater or equal to 1 and less than 2 and 0 elsewhere. So how to write it? Let me write it first. Okay, so here it will be f of x, and in terms of the integration, as all of these are basically the 100 r's, so therefore what I have to write here, I have to write from 0 to 1, it will be what? It will be x dx, okay, plus from 1 to 2 it will be 2 minus x, okay, from 1 to 2 it will be 2 minus x and dx, okay, and elsewhere it is 0, so therefore no need to write here x. So what do we have to find out? Find the probability that over a period of 1 year a family runs their vacuum cleaner a less than 120 hours. Okay, so I have to solve it here, and here I have to write that the hours are less than 120. Okay, so as we can see here that all of these are in the units of 100, so therefore what I have to do, I have to divide these 120 hours over 100. So at the end what I will get, I will get here 1.2. okay, so less than 120 means from 0 to 120. okay, therefore here the range also lies between 0 to 1.2. okay, so now therefore integrating it over this period, so f such that x is less than 1.2 now, because this is in the range of the 100 hours, so therefore it would be from 0 to 1.2. okay, and in this range we can very clearly see that in this range we have all these ranges. This range also lies here because this is from 0 to 1, this lies here, and also this range from 1 to 1.2 because this is now from 1 to 2, so therefore I have to write it all. okay, so here it would be f of x here, or expanding it, what I will get here, I have to write it 0 to 1 x dx plus similarly from 1 to what? 1.2, because now I am not going beyond this 1.2 because all these r's are between 0 to 1, and here it will be 2 minus x dx. So now let me solve it, and integrating it, what I will get here, x square divided by 2 and here 0 1 plus here similarly these two are here, so here I will get 2x for this one. Now I am integrating them separately. 2 and x are separate, where 2 is the constant, x is the variable, so therefore integrating it with by using the rules of integration, here I will get it, and it will be from 1 to 1.2, and now minus x square divided by 2, and here it will be from 1 to 1.2. okay, so now these are all the ranges. Let me solve them here, and I can very clearly see that it will be 1 by 2, x square by 2 would be 1 square minus 0 square. okay, similarly here I will have 2x, so here 2 will be outside, and here I will have 1.2 minus 1 because this is now x, and similarly the last one here would be, this would be 1.2, and here x square, which is 1.2 square minus 1 square. okay, so now let me simplify it. It will be 1 by 2 plus this will be 2 multiplied by 1.2 minus 1 is, this would be 0.2, 0.2 multiplied by 2 is 0.4. okay, so and here this will be 1.2 square minus 1 square, so 1.2 square would be how much? Let me calculate it first. okay, so here it will be minus and here this would be 1 by 2 is 0.5. Here 1.2 whole square would be, let me write it here, it will be 1 by 2, and 1.2 whole square would be 1.44, similarly minus 1. Okay, now let me convert them here to decimals. So 0.5 plus 0.4. okay, and from it I have to subtract this 0.5 multiplied by 0.44. okay, so getting it, what I will get, let me find it out, this would be 0.22. okay, so it would be 0.22. okay, so now we have these values. Let me calculate them here, and what I will get, so it would be 0.68. okay, so that is the answer of part A which we have here. okay, so that is the solution of part A, in which we have found out the probability that the vacuum cleaner runs less than 120 hours. okay, so now let me proceed to part B. So in part B, we have to find the probability that the vacuum cleaner will run between 50 and 100 hours. So 50 to 100 hours. okay, again we have the scale in which we have 100 hours, so therefore dividing it over 100 here as well. So what I will get here, I will get from 0.5 to 1. okay, so this is the range of our equation now. So now we can see that this range basically lies in this area where this is only x. So therefore, in order to find it out, what I have to write, I have to find x such that it ranges in between 0.5 to 1. okay, so therefore it will be, the integration will be from 0 to 0.5 to 1, and this range is here, which is x, so it would be x dx. okay, now integrating it, what I will get, it will be x square divided by 2, and the integration of it would be in the range of 0.5 to 1. okay, so now let me find it out. This would be 1 by 2, and here it would be 1 square minus 0.5 square. okay, so let me solve it, and this would be 0.5 and this would be 1, and it would be 0.5 square is 0.25. okay, so ultimately it will be 0.5 multiplied by 0.75, which will give me the answer 0.375. okay, so what is this? This is the solution of part B of my question, which is basically given by this expression and also written here. So that's it for today, in which we have seen the solution of question 3.7. if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.8, and the statement of it is, find the probability distribution of the random variable W in exercise 3.3, which I have also given here, assuming that the coin is biased so that a head is twice as likely to occur as a tail. okay, so let me first write the given data which has been mentioned here. So given data is the probability of heads is twice likely than that of tails, so therefore I have to make 3 slices of the total probability, and the 3 out of these 3 slices or the 3 parts, 2 will be given to the heads and only 1 would be to the tail. okay, so that would be 1 by 3, such that 2 by 3 plus 1 by 3 will be equal to 1. okay, which is basically the primary rule of the probability. So first of all, I have written it here, and this is the given data. Apart from it, let me recall the question 3.3, in which the W is a random variable giving the number of heads minus the number of tails in 3 tosses of a coin. okay, so we have 3 tosses of a coin, so let me write here the event first. Let me use another color here,
and this is here. So let me use here the event. Okay. In this event, the number of heads, the number of tails, and the W. Okay, what is W? This would be heads minus tail. Okay, so now after it, let me slice them here. Okay. Will be like this one, and after it I have solved it previously, but let me solve it again. So list the elements of the sample space as for the three tosses of the coin, and to each sample point assign a value omega of W. Okay, so what is the first event? First event, let me have here is heads, heads, heads. So number of heads here are 3, number of tails is 0, and h minus t, which is W, is 3. Okay, similarly, heads, heads, tail, we have 2 heads, 1 tail. Okay, so 2 minus 1 is 1. Similarly, heads, tail, heads, here we have again 2 heads, 1 tail, so 2 minus 1 is 1 again. Similarly, heads, tail, tail, so now I have 1 heads, okay, 2 tails, so 1 minus 2 is minus 1, which is this W. Okay, similarly now tail, heads, heads. Okay, so now we have 2 heads, 1 tail, so 2 minus 1 is 1 again. So let me make it more. Okay. So tail, heads, tail, so again I have 1 head, 2 tails, so 1 minus 2 is minus 1. Okay, and now tail, tail, heads, so again 1 heads, 2 tails, so 1 minus 2 is minus 1. Okay, and the last one here is we have tail, 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 so here we have 0 heads and 3 tails, so 0 minus 3 is minus 3. Okay, so these are the events, and with respect to those events, these are the events, and respect to those events we have the value of W, which is given here. So now in order to do so, the sample space for this is the number of heads minus number of tails. So it would be what? It would be minus 3, minus 1, 1, and 3. Okay, so these are all the values which we have for the W in the event where a coin is tossed 3 times. Okay, so this is what the values of all these things. So now in order to find the probability of these events, what do we have to do? We have to find the probability of W equal to minus 3. Okay, so in this event, what would happen in this event? What are the events which has been occurred here? So this is this one. Okay, this is the event where I have to find out the probability of tail, tail, tail. Okay, so this is what, this is the event which we have, and this is what, how many items do we have here of minus 3? There is only one item here, and similarly we can, as the 3 events are basically independent of each other, so therefore I can write here probability of T multiplied by the probability of T multiplied by the probability of T as well. Okay, so I know the probability of T which is given here, so let me write it here. So I have to write here 1 by 3 multiplied by 1 by 3 multiplied by 1 by 3, so it would be 1 over 27. Okay, so this is for W equal to minus 3. Okay, so this is for the first event. Now let me write it for the second one, which is probability of the W equal to minus 1. Okay, so what are those events in which W is equal to minus 1? These events are basically this one, and this one. Okay, so let me write their values. So this one, and this one, so let me write them here. So I have to find the probability of the heads tail, tail. Okay, similarly the probability of tail, heads, tail. Okay, and the last one here is probability of tail, tail, heads. Okay, so you can see that in all of these three events we have two tails while one heads. Okay, so let me move down somehow. So we can see here that here we have these events, and we can also write them here. Either I will have the event of heads, tail, tail, or I will have the event this one, which will give me -1, and wherever in probability I will get this or, I have to add them. Okay, so similarly probability of tail, heads, tail, I have to make them here as well. Okay, and or I can have here probability of tail, tail, heads. Okay, so this will be the third event. I know their values, so let me write them. Probability of heads multiplied by the probability of tail multiplied by the probability of tail here as well. Similarly, plus probability of the tail, probability of heads, and probability of tail. Okay, or the probability of the tail, probability of tail, and probability of heads. We have these events, and I can basically identify them here as well. This one is for this one is for this one, and this one is for this one. So let me put their values, because the probability of heads, we have previously seen that the probability of heads is how much, that is here 2/3, and the probability of tails is 1/3. So let me write them here as well. So writing them here, probability of heads will be 2/3 multiplied by 1/3 multiplied by 1/3, plus probability of tail is 1/3 multiplied by probability of heads, which is 2/3, and multiplied by 1/3, and this one probability of tail is 1/3 multiplied by probability of tail, which is 1/3, and the last one is probability of head, which is 2/3. So let me calculate them. This would be 27. So 2/27 plus 2/27 plus 2/27. So ultimately what we will get 6/27, which is also 2/9. Okay, so the probability of W equal to -1 is how much? That is 2/9. Okay, so now let's move on, and the probability of W equal to 1. Now let me find the probability of the W equal to 1, which is the event here, this one. Okay, so what are the events which have given me the probability W equal to 1? So this is this one, and this one as well. So let me write them here. So let me write them here, or start them here. So the probability of W equal to 1, so it would be the probability of the events which are head, heads, tail, heads, heads, tail, or heads, tail, heads, heads, tail, heads, and the third one is tail, heads, heads, tail, heads, heads. Okay, so we can see here that in all of these events we have what? We have two heads and one tail. Okay, so now writing them in the similar manner as we have done it for the W equal to -1. So what would we get here? We will have heads, heads, tail, or probability of heads, tail, heads, okay, or the probability of tail, heads, heads, okay. So these are the events which we have. Now separating them out, let me start it here and let me move down somehow. Okay, so it would be the probability of heads multiplied by the probability of tail, okay, or the probability of heads, probability of tail, and probability of heads, okay, and the last one is probability of tail, probability of heads, and the probability of heads as well. So let me mention them here as well. So this one here, okay, these three are for this one. For this one we have these three, okay, and for it I have this one. So again let me put the values of the probabilities. So the probability of heads is 2 by 3, similarly 2 by 3 multiplied by 1 by 3 for the probability of tail, similarly probability of heads 2 by 3, this is 1 by 3, and here 2 by 3, okay. Here we have 1 by 3 multiplied by 2 by 3 multiplied by 2 by 3 here as well. So let me calculate them, and here we would get 27. So 4 by 27 plus 4 by 27 plus 4 by 27. So ultimately I will get here 12 by 27, which is how much? We will have here 4 by 9. Yes, so 3 4 12 3 9 27. So this is for what? This is for the probability that heads is W is 1, okay. So the last one here is to find the probability that W is 3, okay, and this is the only one where we had 3 heads, okay. So heads, 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 and you can also see that in this table we have seen that this is the only one where the probability of it is 3, okay. So now in order to do so I am going to solve it. So solving it by using the same procedure, as we have only one event here, so it would be the probability of heads, as the 3 events are independent of each other, so I am multiplying them together, probability of heads and the probability of heads, okay. So as their probabilities are already given, so it would be 2 by 3 multiplied by 2 by 3 multiplied by 2 by 3. So we will have here 8 divided by 27, okay. So this is what, this is the given probability for heads equal to 3, okay. So on the basis of it we have calculated some probabilities, so let me write them here, okay. So let me write them here, and here let me use here the values of W and the corresponding values of the W, okay. So we have the values of W, we start from -3, then -1, then 1, and then 3, okay. We have also calculated their probabilities as well, so let me write them here. The probability of -3, how much is this? Let me see. Probability of -3, and this one was 1 by 27, okay. So 1 by 27, the probability of -1, how much is this? So this was 6 by 20. Let me write 6 by 27. So ultimately I will show you that the addition of all of them is equal to 1. So let me write 6 by 27. So 6 divided by 27, probability of W equal to 1. So it would be 12 divided by 27. Okay, and the probability of W equal to 3, that is 8 divided by 27. Okay, so now adding them all together, 1 by 27, 6 by 27, 12 by 27 and 8 by 27, you will see that all of them basically gives me what? They gives me 1. So this is the basic condition for the probability distribution which we have. Okay, so that's it for today, in which we have seen the solution of question 3.8, which was related to question 3.3, which we have previously seen. So if you have any question, you can ask me in the comment box. Till then, take care of yourself and I will see you soon. Welcome back, guys. This is question 3.9. The statement of it is: the proportion of people who respond to a certain mail order solicitation is a continuous random variable x that has the density function fx, which is 2x plus 2 divided by 5 for the range of x greater than 0 and less than 1, and it is 0 elsewhere. Okay, so there are two parts of it which is asking us to find something. So in first of it, show that probability of x greater than 0 and less than 1 is equal to 1. Okay, so let me first solve it. So let me first solve a solution, and this is the solution of part A, and we have to find the probability of it in the range which is given. So therefore the probability of x greater than 0 and less than 1, okay, we have to integrate the function f of x in the range of 0 to 1, and here we have to write 2x plus 2 whole divided by 5 dx. Okay, so let me solve it, and in solving it I will see that here these two are constant, so 2 by 5 will be here, and this x plus 2 has the power of 1, so therefore this would be x plus 2 whole square and whole divided by 2. Okay, this is the integration formula, that if we have some power and integrating it, the power will be added by 1 and similar powers will be in the denominator of it. Similarly, in the ranges of it, we have here from 0 to 1. Okay, so now this is what we have. In order to find the other things we have here, so this would be 2 will be cancelled out with it, so it will be 1 by 5, and in writing ranges, let me first start with the highest range, so it would be 1 plus 2 whole square minus 0 plus 2 whole square. Okay, so it would be 1 plus 3, which is 1 by 5, and 1 plus 3, which is 9, minus this is 2 to 4. Okay, so here we will have this one, and 1 by 5, 9 minus 1 is 5, so these two will cancel out, and at the end we will get 1, which is the required result we wanted to find out. Okay, so hence it is proved that probability that it ranges from 0 to 1 is equal to 1. Okay, so now similarly moving towards part B here, what is the statement? So find the probability that more than 1 by 4 but fewer than 1 by 2. So which means that this is the lower limit while this one is the higher limit of the people contacted will respond to this type of solicitation. So here I have to find out the probability of x greater than 1 by 4 but less than 1 by 2. Okay, so I have to integrate this one from 1 by 4 to 1 by 2, and it would be this f of x which was previously here, and this f of x is how much? This is basically we have here. Okay, so we have already found it out, just we have to change the limits. So here it would be 2 by 5, and here x plus 2 whole square divided by 2, this was cancelled out, and similarly now finding the 1 by 5, sorry, the limits here were 1 by 4 to 1 by 2. Okay, now solving it in such a way that limits have been put here, so it would be 1 by 2 plus 2 whole square minus 1 by 4, which is the value of x, lower value, plus 2 whole square. Okay, so you can find it out, and ultimately you will see the answer of it, which is 19 by 80. Okay, so which is what? Which is the answer of part B. So I think that's enough for today, in which we have seen the solution of two parts of question 3.9. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. So this is question 3.10. Find a formula for the probability distribution of the random variable x representing the outcome when a single die is rolled once. Okay, so in a single die, what are basically the contents of the sample space? So let me first write the sample space, and a single die, what I can get? I can either get 1, 2, 3, 4, 5 or 6. Okay, so any one of them I can get. So in writing probabilities of each, so let me write the probability that I get 1. How much would it be? It would be the number of elements here and the total number of items in the sample space. So the number of element here equally divided, and these are 1, and the total number of items we have here are 6. Okay, so it would be 6. Similarly for 2, we will have, how many 2's do we have here? Only 1, because it can only occur once. So therefore the number of items here in the event when we will get 2 is basically 1 divided by the total number of items here. So the total number of items are again 6, so it would be 1 by 6. Similarly, the probability that we would get 3, it would again be 1 by 6. Okay, similarly for probability that we would get 4, it would again be 1 by 6. For 5, again we will have here 1 by 6, and for the last one, which is the outcome equal to 6, that would be 6 again, 1 by 6. So what is this? The probability distribution is uniform, and in plotting it, if I want to plot it, so let me have here, these are basically the outcomes, probability of the outcomes, and here we have the outcomes. Okay, so let me write them. If this is 0, we will have here 1, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4, 5, 6. Okay, so let me have here this 1 by 6. Okay, so each and every item here has the same probability, and that is what? That is 1 by 6, 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 and 1 by 6. Okay, which means that all items here are equiprobable, and therefore this type of distribution is also called the uniform distribution. Okay, you can see that the distribution or the probability of all the items here are equal, so therefore this is the uniform distribution. Okay, so that's what we have solved this question for, and that's it for today. If you have any question regarding the events of these type of questions, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is chapter 3, which is related to the random variables and probability distributions, and today we are going to solve question 3.11. Okay, so the statement of this question is a shipment of 7 television sets. Okay, so let me underline the figures here. Okay, so 7 television sets contain 2 defective sets. Okay, so let me write here the given data, and for given data let me choose the color which is blue. So given data here. Okay, so in total of 7 televisions we have 2 defective sets. Okay, a hotel makes a random purchase of 3 of the sets. Okay, so out of these 7 a hotel does what? Out of these 7 a hotel basically select 3 random purchases. Okay, so this is the graphical illustration which I have been telling you. Okay, so if X is the number of defective sets purchased by the hotel, okay, so out of these three there can be X defective items as told by us, and find the probability distribution of X, which is what here this small x is a member of this capital X, which is basically the random variable, and I have to express the results graphically as a probability histogram. Okay, so I have to express this one. So now in order to solve it, let me solve it, and let me use this black color. So let me solve it, and here in order to solve it, I know the basic formula of the finding the probability of the event, and that is basically the probability of, let me have here, probability of X is what? This is the number of elements or choices in event. Okay, dividing it over the total number of choices. Okay, so this is the basic formula, but here in order to find the number of choices in an event, what do I have to do? Let me first underline it, and let me choose the color for it. Let me choose this green for it. Let me call this equation is equation A. Okay, so now in order to do so, we know that the number of elements or choices are how much. So let me see that what is this? This is basically the problem of a combinatorics. Okay, so here first of all let us see that here we have 2 defective items, and out of these 2 defective items how many choices will I have? I have basically the X number of choices which can be available in these 3 random choices. Okay, so this X can be either 0, X can be either 0 or 1 or 2, because it cannot exceed 2, because there are basically 2 defective items, but I have to select 3. So it can either be 0 defective item or 1 defective item or 2 defective item as a whole, but total number of items here we have are 2. Okay, when the X number of items are selected, so these would be the items which we have, so the number of items left will be the 3 minus X. Okay, so I will have 3 minus X of X items left here. Okay, and these choices are made from how many choices which are not defective? So the non-defective items here are 7 minus 2 are 5. Okay, so I hope you have understood that these are basically the number of choices we have here. Let me repeat it again. These are basically the number of defective items, and out of these defective items I have to choose any X. Okay, and the value of X are basically lies from 0 to 2. Okay, similarly when any of the items are defective items are selected, the non-defective items left are basically 5, which are 7 minus 2. So out of those items I have to select 3 minus X. Why 3 minus X? Because the total number of items the hotel has to collect randomly are 3. Okay, so 3 minus X would be the remaining items, so therefore I have to make these choices. Okay, so these would be what? These would be the choices of the event. What are the basic total number of choices out of them? So here I have 7 items, and without any bias that either it will contain the defective items or not, these are basically the 3 items. Okay, so 7 choose
3 are basically the total number of what? These are basically the total number of choices. So therefore, I have to write it here. Okay. So I hope you have understood that what does it mean. So now in order to solve it, what do I have to do? I have to basically open it. So it would be 2 factorial divided by the 2 minus x factorial, okay, and so on. But before doing it, what I have to do, I have to keep here different values of x, because I know that either the defective items would be 0, no defective item out of in these 3 items. Similarly, it can either be 1 or it can either be 2. Okay, so let me take here the probability of x equal to 0. For x equal to 0, I have to put here 2 choose 0, okay, and here 5 choose 3. Okay, and similarly here it would be 7 choice 3. Okay, so these would be here. Similarly, let me move down somehow. Okay, so for the second item, when p x equal to 1, it would be 2 choice 1. Similarly, 5 choice 3 minus x is 2. Okay, and divided by 7 3. So this is what, this is the choice in which I have one defective item and two non-defective items. Okay, I have to solve it as well. And the third case is p x equal to 2, and here it would be what, 2 choice 2. Okay, and here 5 and 3 minus 2 is 1, so here it would be here, and here it would be 7 choice 3. Okay, so these are all the choices which we have. And now here what do we have? Here we have 2 defective items and 1 non-defective item. Okay, so when I solved it and I found it, here I got 2 by 7. Okay, you can try it. Okay, how can you try it? So let me first tell you that how can you do it. Let me do it for you. Okay, so when you will do it, you will do it like 2 factorial divided by 0 factorial and 2 minus 0 factorial. So it would be 2 factorial multiplied by here 5 factorial divided by 3 factorial, and 5 minus 3 is 2 factorial divided by the 7 factorial divided by 3 factorial, and 7 minus 3 is how much? That is 4 factorial. Finding it out, what I will get here, I will get, let me choose color which is green. So for it I will get 2 by 7. Okay, for this I have got 4 by 7, and for it I have got 1 by 7. Okay, so these are different values of the probabilities. Let me draw them graphically, because it is also told us to draw them graphically. So first of all, let me draw them here. Here these are the values of x, and here we have the value of f of x. Let me have them here, and here we would have, here let me draw them. Here we have different values for as 0, 1 and 2. Okay, so let me plot them or draw them here. So here for 0, the value of f of x is 2 by 7. For 1 I have 4 by 7, and here 1 by 7. Okay, and according to the probability distribution, I can also see that by adding 2 by 7 plus 4 by 7 plus 1 by 7, what I will get? Here I will get 1, which is the basic condition for the probability density function. Okay, I can also plot it. Let me plot it here as well. Okay, let me plot it, and this is x, and for x different values are here, and this is f of x. Okay, so we have here different values. Let me choose another color, which is this one. Okay, so for the first one I have, let me have here 2 by 7. So for 0 I have here 2 by 7. For 1 I have 4 by 7, and this is, let me have here 4 by 7. So it would be here. Okay, so this is 4 by 7, and the last one is 1 by 7. So let me have it here 1 by 7, and this is at 2. So here I will have 1 by 7. Okay, so what is this? This is the PDF plot
for our question which we have done here. Okay, so I hope you have understood all the underlying concepts which I have done here and what are basically the choices and how to find them out. So I hope it's enough for today. If you have any question, you can ask me in the comment box. See you soon. Hello guys, I hope all of you will be fine. So this is question 3.12 and the statement of it is an investment firm offers its customers municipal bonds that mature after varying numbers of years. Given that the cumulative distribution function which we have discussed this lecture, what is cumulative distribution? So the number of years to maturity for a randomly selected bond is given by this f of t, are different values, and these values correspond with this. They are given different values of f of t, and on the basis of t, on the basis of this f of t, what we have to find out, we have to find different quantities one in the form of part a, b. So let us solve it. Okay, and in solving it, let me have part a, and in part a I want to find out the probability at t equal to 5. What do we have to do? Previously we have seen that in order to find the probability of the instance between two events, let me have this one as 5 and this is the previous event 4. Okay, so in order to find the probability here, what can I do? I can subtract from this one. So therefore here what we can do here, that we have this function, so therefore I have to find here f of 5 and from it I have to subtract f of. So let me see the value of f of 5. What is the value of f of 5? So from it I can very easily see that at this instant, let me change the color here. So this I can see that this one very clearly said greater or equal to 5. So therefore taking the same instance here and writing here that by 4, and what is the probability at f4? Okay, here I can see that at this function instance, here the range of this 1 by 2 is from t greater or equal to 3 and less than 5. So in this instance 4 is already in it. Okay, therefore I am taking 1 as well, so it by 2 or 3 by 4. This 1 by 2 can also be written as 2 by 4. Subtracting for this one, what I will get here? I will get here 1 by 4 by using the LCM or whatsoever. So I'm not going to details of this. So this is what, this is the solution of part A. Similarly, in order to find the part B, what is part B? I want to find out the probability. So in order to do so, what I can do, I can see that in cumulative distribution function, in order to find the probabilities greater than 3, I have to take all the probabilities less than this and subtract it from 1. What I can do here, I can also write it here 1 minus f for probabilities of all which are is less than or equal. I hope you have got my point that why am I doing it, because in previous lecture you have seen that if different probability which are here, so in order to find the probability which is, if let me have this, so if I want to find the probability which is greater than this one, so for that I have to subtract from it all this area so that I will get. So in order to find the values here, what I can do here, that in CDF the less than or equal to values are almost similar. So therefore in order to find the instance greater than this one is all the values which are equal to what, these are all equal to B. Okay, so therefore I can also write here what, it can also be written as 1 minus f equal to, so let me see the value it has here, and here by seeing it we can very easily see that this is 1 by 2 which lies in the range that t is greater or equal to 3. Okay, so this is the range which I want to find out, because I want to find out the value of f of t where the value of t is equal to 3. So therefore let me write their values. Okay, so it 1 minus 1 by 2, ultimately I will get what, so this is what, this is part B. In order to find the solution of part C, which is P 1.4, T is greater than 1.4 and less than 6. So here this one is very easy, and in order to do so we want to find out the probability that greater than 1.4 and less than 6. Let me write the formula for it, and for it I have to see two ranges in which this lies. So these ranges are 6 and 1.4. So it would be f of 6, the higher range, and from it I have to subtract 1.4. Okay, so let me write their values. What would be their values? So in writing f6, let me search for it, and here I can see that this basically lies in the range which is here. Okay, so this 3 by 4 lies in the range where t is greater or equal to 5 and less than 7. So 6 lies in the range here. So therefore it will be what? 3 by 4, which is here given. And similarly from it I have to subtract this 1.4, and let me see that where does it lie. So it can be very easily seen that it also lie here, because this is the range where t lies between 1 and 3. Okay, so this is 1 by 4. So this way 1 by 4, subtracting for it, I will get 2 by 4, which is basically 1 by 2. So this is the answer of part C. Now in order to find the solution of part B, let me start it here, and that is probability that less than or equal to 5, given that greater or equal to, want to find out. So in order to do so, I have to use the Bayes theorem. What is the Bayes theorem? I have to see these two ranges and divide it over the given range. So therefore it will become probability of t, which is greater or equal to 2 and less than or equal to 5, divided by the probability of this, which is the given value. So therefore the probability of t. So in order to do so, what would I do here in this range? What will I get? This will be the value of f at 5 minus probability or value of f at 2, and subtracting it from the value t is greater than 2, which I have mentioned in this question as well, that how to find it out. So it will be 1 minus f of 2. So let me put all these values here. So in putting all these values, f of 5, it lies in this range. So it will be 3 by 4, f of 2, which is here in this range, similarly dividing it over 1 minus f of 2. So f of 2 basically lies here. So it will be, so here I will get 3 by 4 minus 1 by 4. This will be 2 by 4. Dividing it over 3 by 4 will cancel out, and ultimately in this question, what will I get? 2 by 3. Solution of part. Hello guys, I hope all of you will be fine. So this is question 3.13 of chapter 3, and the statement of it is the probability distribution of x, the number of imperfections per 10 meters of a synthetic fabric in continuous rolls of uniform width, is given by this table. Okay, so here the values of x are given and the corresponding values of the f of x are also written beneath these values. Okay, so what do we have to do? We have to construct the cumulative distribution functions of x. Okay, so in order to do so, let me write the solution of it. This is the solution, and let me choose this color black. In order to do so, let me have this graph. Okay, so this is the CDF graph, and in order to plot it and do it, first of all let me write all the values of x here or this x-axis. So this is 0, this is 1, this is 2, 3 and 4. Okay, these are all the values of x, and this is f of x. In order to find the values here, let me write all these values with this blue color, and for the 0, the value of fx is 0 0.41, and let me write it here. This is 0 0.41. okay, and it will proceed unless and until we will reach this value 1. Okay, so when I will reach 1, what will happen? This value, which is 0 0.41, this will be added with the value at 1, which is 0 0.37. okay, so let me add them together here, and here we will get 8, 7 and 0 0.78. okay, so therefore it will become 0 0.78 here, okay, and from here onwards up to this 2 it will be 0.78. okay, so when it will reach this 2, the value at 2 is 0.16. okay, so let me add with this 0.78 with this 0.16. okay, so adding them together, what I will get, this is 4, this is 9, and here we will get 0.94. so let me have here 0.94. okay, so at this 2, what will happen, it will jump to 0.94. okay, so it is 0.94 and it will be 0.94 until and unless we will reach this this 3. okay, the value of x equal to 3. Now we can also, let me also give them here, this is here, this is here. okay, so when we will reach this 3, what will happen, the value at 3 is 0.05, 0.05. let me add them together and it will become 0.99. okay, so here let me have here 0.99. okay, so after it will be what it will be, let me have here, okay, it will be 0.99 until and unless we will reach this 4, and at 4 we can see that the value is 0.01. so when it will be added with this 0.99, what will we get here, the value of it will become 1. okay, so at the end we will get here this 1, and afterwards it will be here 1 as well. okay, so what is this, this is basically the CDF plot, and basically this one is not small of f of x, but this is basically the capital F of x, because by convention f of x is basically the PDF, while capital of it, which is this one, this is the CDF, okay, or cumulative distribution function. So now in order to write it mathematically, let me write here the value of x, and here we have different values. The first value it has is 0, which is for what, which is for all the values which are less than 0. okay, similarly we have here 0.41, for which values we can see that it ranges from 0 to 1, and all these values will range from x equal greater or equal to 0 and less than 1. okay, unless and until it will reach this 1, the value of it will become 0.78, which I have told you that this is by adding them, and here this x will range from 1 greater or equal to 1 and less than 2, because here we can see that this is the range. okay, now here after it we have got 0.94, and this ranges from 2 to 3. okay, we can very easily see that this is the range. okay, so now after it we have 0.99, because now here these two are added together, so 0.99 for x greater or equal to 3 and less than 4. okay, this is the range, and afterwards when it will reach this point, which is basically 1 here, and this will always be x is greater or equal to 4, and this is what we have. So now in order to write it, what we can do here, we can see that these are all the values which are for x, f of x. okay, so these are all the values for f of x, and this is what, this is the CDF of the question we were asked. okay, so that's enough for today, in which we have seen the cumulative distribution plot, okay, for the PDF which is given in the form of this table. So if you have any question, you can ask me in the comment box. So that's enough for today, and I will see you soon. Welcome back guys, I hope all of you will be fine. So this is question 3.14 of chapter 3, and the statement of it is the waiting time in hours between successive speeders spotted by a radar unit is a continuous random variable with cumulative distribution function. Okay, so CDF for it is given in the form of this, in which this is 0 for all the values less than 0, and it is 1 minus x e to the power of minus 8x for all the values greater or equal to 0. Okay, so here what do we have to do? We have to find the probability of waiting less than 12 minutes between successive speeders. Okay, so this is now the solution, and here it has two parts. We have to find the probability of waiting less than 12 minutes by using the CDF and by using the PDF as well. Okay, so first of all, we have to see that here the data has been given. Here this is x, and x has been given in the form of this 12. Okay, this 12 is basically in the form of minutes, but here we have this distribution in the form of hours. Okay, so what do we have to do? I have to convert from this 12 minutes in the unit of hours. Okay, so therefore what do I have to do? I have to write this 12 and divide it over the total number of minutes in an hour. Okay, so by converting it, what will I get? Here 12 divided by 60 is 0.2 hours. Okay, so this is what we have found out. Now in order to solve it by using A, which is by using the CDF, what do I have to do? I have to write these values. Okay, and for writing them, what do I have to do? I have to find these values by using the f of x. So here we have to write the probability that x is less than 0.2. Okay, so when this is less than 0.2, it will be f of 0.2. Okay, so if this is here, this value which is x is greater than 0, so therefore just I have to pick this instance. Okay, and here I have to write the value of x, which is 0.2, so therefore it will be 1 minus exponential of minus 8 multiplied by 0.2. Okay, so here I will get 1 minus exponential of minus 1.6, and ultimately it will give me 0.7981, which is the solution of part A by using the CDF. Okay, so by using the CDF, what did I find out? I have found out the probability that the waiting time is less than 12 minutes between the successive speeders. Okay, now in order to do similar thing by using the PDF, which is the probability density function, here I have to do what? I have to write here the f of x. Okay, which is what here we are given the CDF, and in order to find the PDF from the CDF, what do I have to do? I have to find the derivative of this f of x, which is d f of x divided by d of x. Okay, so this will only range between these values because all others are zeros. So therefore when I will derive it, or I will find the derivative of this 1 minus e of 8 minus x, which is, let me write it here. So derivative of 1 minus exponential of minus 8x divided by dx. So here what will I get? I will get here minus 8 exponential of minus 8x. Okay, so this is what? This is the probability density function which we have here. Okay, so this is f of x. Now in order to find the values of it, what we have, what do I have to find out here? I have to find these values by integrating it from 0 to the range which is here 0.2 hours. Okay, because my ultimate goal is to find the same quantity by using the PDF in order to show that all these answers are similar but the methods are different. Okay, so therefore here I will have minus 8 exponential of minus 8x and here d of x. So here it will give me what? It will give me, sorry, here I have made a mistake, because here when this will be 1 minus, so here it will be plus. Okay, so this is again plus, and here I will get 8, here it will be minus 8x dx. Okay, so now let me move down somehow. Okay, so now here the range is from 0 to 0.8. Now in order to do so, what do we have to do here? By integrating it and then finding the solution of it, what I will get? I will get here minus 8x divided by minus 8 multiplied by 8, and this range is from 0 to 0.2. Okay, here it is also 0.2, sorry, my bad. So these two will cancel out, and here I will have here minus exponential of minus 8x. It is from 0 to 0.2. Okay, so now finding these ranges by writing the highest range first and then this range, what I will get here? I will get minus exponential of minus 8 into 0.2. Okay, and then subtracting it from minus, and then minus exponential of minus 8 into 0. Okay, so here I will get minus exponential of minus 1.6, and then here this minus minus will become what? Plus. So plus 1, or it is 1 minus exponential of minus 1.6. Okay, we can see that these two quantities, which is here and which is here, these two are similar. Okay, so therefore the answers of it will also be similar, and it will be 0.7981. okay, so the similar answer we have got from this question is what we have obtained from the CDF as well. Okay, so that is basically the solution of part B of our question. Okay, so that's it for today, in which we have seen the probability calculation by using the CDF and PDF as well. If you have any question, you can ask me in the comment box. See you soon. Hello guys, I hope all of you will be fine. So this is the exercise problem for the probability and statistics for engineers and scientists by Walpole, and this is chapter 3, exercise problem 3.15. Previously we have seen the CDF plot of the question 3.11. Today we have some questions, and on the basis of this CDF we have to answer those questions. Okay, so this is question 3.15, and here we have to find the cumulative distribution function of the random variable x representing the number of defective items in exercise 3.11, which is already found out in our previous video, which was related to the question 3.16. okay, also after it we have to find the value of px equal to 1 by using the f of x. okay, so here let me have here the solution. This is basically the solution we have, and in solution we have here part A, and in part A I have probability of x equal to 1. okay, so previously we have seen that in probability of x equal to 1, that is basically the region which lies here. okay, so this is basically the region which is below it, and this is basically the value which I want to find out from it. So that this value minus the value of this one will be the value which is here. okay, so I want to find out this value, which is the probability at x equal to 1. okay, because now this is a CDF plot, and in CDF plot all the things here are basically what? These are basically the cumulative. okay, so now in order to do so we have to do what? Let me have it here. So in order to do so I have to write here the probability of x less than or equal to 1 minus the probability of x less than 0. okay, so we have to find it out. Now in order to find it out, to find the values here, we have the value of probability here, and that is already given, which was the 6 by 7, okay, which is the value at f x is equal to 1, okay, this is 6 by 7. Similarly, the probability that x is less than 0, this is basically the probability of x equal to or 0, okay. Now putting their values, what I will get here, I will get 2 by 7, which is already given here. We can see that this is x is less than or equal to 1, this is given here, and probability x is less than 0, this is already given, and this is here, okay. We can see that this is at x equal to 0, okay. These are the values of f of x which are given. So now finding them out, what I will get here, I will get 4 by 7, and that is the solution of part A. You should keep in your mind the difference between p of x and f of x. These are all the values of f of x. If you have seen it and you have been confusing it with these values, this is not basically the case, because all the values here it are basically capital F of x equal to 0. So this is basically the value which basically lies here in this region, okay. So you have to keep in your mind. Now similarly, the solution of part B, and that is what the part B is here, probability that capital X is greater than 0 and less than or equal to 2, okay. Now we have defined two limits, and here in order to find the probability in these two regions, what do I have to do? I have to write the value of f, and that value is x is less than or equal to 2, which is the higher region, minus the probability of x f x is greater than 0, okay. So we can see here very clearly that the probability that f x is equal to 2 is basically what we can also write it like f of x equal to 2 and subtracting it from minus f of x equal to 0. These are also the t values. Now writing them down, it is very clear that in this region this is 2 by 7, and in this region this is basically the equal region of 2. So here it is 1. So I have to write here 1, and here in this region I have 2 by 7. Okay, so it will be 2 by 7, and calculating it, what I will get here, I will get 5 by 7, which is basically the solution of part B which we have, okay. So that is what, that is basically the solution of part A and part B of question 3.15. If you have any question, you can ask me in the comment box. See you soon. Welcome back guys, I hope all of you will be fine. So this was question 3.11 which we have done previously, and here we have seen that what did we find out, this was the statement, and on the basis of this statement we have found out the probability density function for different values which are plotted here. So these are the values and their plots are given here, okay. So on the basis of it, we are asked to find the construct a graph of the cumulative distribution function of exercise problem 3.15 or 3.11. that is basically the PDF which we wanted to find out the cumulative graph of which, okay. So this is what, this is question 3.16, and let me proceed to the question 3.16 here as well, and I'm going to use the same page here, okay. So let me have it here, and here I am going to draw the CDF of it, okay. This is PDF, the first one is basically the PDF, and now I am going to plot the CDF for it, okay. So let me do it again, this is the PDF, okay, and now I want to find the CDF or plot it, okay. In order to find the CDF, what do I have to do? Let me have it here, and let me draw it here as well. I'm sorry for my drawing, okay. And if the PDF represented by small f of x, CDF is represented by capital F of x, okay. But the domain of it will remain the same. This is x, and all small x are the members of this capital X, which is the random variable, okay. So here I have different values which are 0, 1, and 2. Okay, so let me draw them here. In order to draw it, let me use the color which is blue here, and in order to do so, let me first draw it for 0, and for 0 it is 2 by 7. Okay, let me have it here, and this is here, this is 2 by 7, and it will proceed unless and until I will get here to this 1. Okay, when I will get to this one, what will happen? This 2 by 7 will be added with the value which is at 1, and this is 4 by 7, so it will be 4 by 7 here, and it will be added at this instant which is 1. At 1 it will become 6 by 7. Okay, so this is 4 by 2 by 7, so now it will become, let me have here this 6 by 7. Okay, so it will jump here and it will move unless and until I will get here 2. Okay, when it will reach 2, what will happen here? The value of the PDF at 2 is 1 by 7, so this will be added, this 6 by 7 will be added with 1 by 7 at what? This was at this point, and now we are at 2, so at 2 we have this 6 by 7 plus 1 by 7, so it will be equal to 1. Okay, so it is now 1, and it we will move here, and here it will remain 1 forever. Okay, so this is what, this is the CDF plot of our question. Okay, now in order to write it mathematically, let me write it mathematically, and here in order to write it, let me move down somehow more. Okay, so here this would be f of x. Okay, and this f of x would be what? 0 for all the values of x which are less than 0. Okay, it will be 0. Similarly, at 0, at the instant when it is 0, and in between 0 and 1, it will be 2 by 7. Okay, so let me write it 2 by 7, and here it will be the value of x would be greater or equal to 0 and less than 1. Okay, at instant 1 it will jump and it will become 6 by 7, so here it will remain 2 by 7. Okay, so when it will be 2 by 7, here it will jump to the 6 by 7 here. Okay, and here at 6 by 7 it will be at x is greater or equal to 1, but less than, sorry, but less than 2. Okay, here it will be 6 by 7, and the last instant is here when it will be 1, and it will remain 1 for all the values which are x is greater or equal to 2. Okay, so these are all the values which will remain here, and these are the values of what? These are the values of f of x which we have here. Okay, these are the values of the CDF, and we have written it in the form of this graph and this graph as well. Okay, so if you have any question, you can ask me in the comment box. This is the mathematical equation for it. If you have any ambiguity regarding the equations or the graphical illustration, you can ask me in the comment box. So see you soon. Hello guys, welcome to my YouTube channel. So this is question 3.17 of chapter 3, and the statement of it is a continuous random variable x that can assume values between x equal to 1 and x equal to 3 has a density function given by f of x equal to 1 by 2. Okay, so before going into the detailed discussion of this question, let us first see that what is this and what are these values. So in between 1 and 3 this function lies, which is 1 by 2, and it remains constant in between all these values. Okay, so let us first write the given data. So in given data we have word, let us draw it, and in drawing it you will very clearly see that this is word, this is the PDF plot, this is x, this is f of x. Okay, and it has values from 0, 1, 2 and 3. Okay, so it has some values. Now in order to draw it, we have here this value 1 by 2. Okay, and here according to the statement given here, the values lie between 1 up to 3. Okay, and as all these values are continuous, because the random variable here we have is a continuous random variable, so therefore it will be the constant value, or we can see here that it will be like this one. Okay, so this is the statement of our question. Now in order to solve it, what we have to do, let us see the solution, and in order to solve it, I have chosen this place. Okay, and here I have to find the solution of part A, in which I have to show that the area under the curve is equal to 1. I have to find out the area which is given, and this is here in this range. Now in order to find it out, I know that in a continuous random variable, area is equal to the lower range, which is here the 1, up to the higher range, which is 3. Okay, and taking the integral of it, and then writing the value of f of x, okay, which is what, let me write here the f of x, okay, d of x. Now here the value of f of x remains constant in between these values, so therefore let me write in, and it will become 1 up to 3, and the value of it is 1 by 2 d of x. Okay, or it will also be like 1 3, as this is a constant, it will come out of this and it will become d of x. Okay, or ultimately it will give what, it will give, this will be 1 by 2 multiplied by this x. Okay, this x, let me write it here as well, and the ranges which are from 1 to 3. Okay, so now let me solve it, and solving it, what I will get, this is 1 by 2 multiplied by the value of x, higher value, which is 3, minus the lower value, and 1 by 2 multiplied by 2, which is basically equal to 1, and that is what, that is the solution of part A, which basically says that the area under this graph or this curve is basically 1, okay, which is proved here. Okay. So now going towards part B of our question. So this is part B, and here we have to find the probability in which x is greater than 2 and less than 2.5. okay, I have to find out the probability that x is greater than 2 and less than 2.5. okay, here I have to do what, again taking the integral, because this is now a continuous random variable, writing the lower limit here, the higher one here. Okay, and the f of x, which is again 1 by 2 d of x. Okay, so again integrating it just like this one, what will we get, we will get the same value which is written here. Okay, so now only the values of the ranges will be different, which are here and here. So now writing them out here, what I will get here, I will get 1 by 2 x, and the values of x are 2, 2.5. okay, so it will be 2, writing the higher range, 2.5 minus 2. okay, so it will be 1 by 2 multiplied by 0.5. okay, so which is ultimately 1 by 4, the solution of what, the solution of part B. okay, so now this is the solution of part B. Now going towards the solution of part C, in which I have to find out the value in which x is less than or equal to 1.6. okay, so here I have to find out the probability that this x is less than or equal to, sorry, let me remove it, this one as well. So x is less than or equal to 1.6. okay, as we can see that this basically lies from 1 to 3. so therefore the x less than 1.6 basically corresponds with the values which are in between 1 and 1.6. so therefore I have to take the integral in between 1 and 1.6. okay, and writing the values here, again the function here is a constant, so therefore this will be dx. okay, again the same function, because the x, f of x is not changing, so therefore it will be 1 by 2 x, and here it will be 1 into 1.6. okay, so now let me solve it here. So it will become 1 and lower value minus higher value minus lower value. So here 1 by 2 multiplied by 1.6, and this is 0.6. okay, so it will become how much, it will become 0.3. Okay, so that is the solution of part C. Okay, so in today's video we have seen the solution of question 3.17, which had basically part A, B and C, and we have solved them, which is related to the continuous random variable given here. If you have any question, you can ask me in the comment box. See you soon. Welcome back guys, I hope all of you will be fine. So this is question 3.18 and the statement of it is a continuous random variable x that can assume values between x equal to 2 and x equal to 5 has a density function given by f of x, which is 2 1 plus x divided by 27. Okay, so first of all let me write the given data. Okay, and in writing the given data, what I have to do, let me plot it here. So visualizing it will give you the conceptual overview of this question. Okay, so the values here on the x axis basically starts from 2. Okay, this is 3, this is 4 and this is 5, and all of these values has a value which is f of x equal to 2 1 plus x divided by 27, and as the value of x is available here, we can see that this is a linear function. So most probably it will be like, you can see that it will be like this one. Okay, it will be a linear function. So I have to find it out, and here we have this f of x. Okay, and on the x axis we have this random variable x. Okay, so now here in order to find different values which are here, let me solve it, and solving it I have to do what? Here we have to find in part A the probability that x is less than 4. Okay, so this x less than 4 basically lies in the range which is basically this one. Sorry. Okay, so this is basically this one. I'm not going beyond this one because now the function is already 0, so I'm not going to describe this one as well. So therefore now writing this one probability, I have to integrate all these values from 2 up to 4. Okay, in continuous random variable, less than 4 is around in decimal points. So therefore I'm not discussing it, or I'm not considering it, therefore, because 3.999 something is less than 4, which is almost equal to 4. So I am also considering the value here as well. So now here we will have f of x, d of x. Okay, now putting their values, what I will get here, this will be 2, 4, the value of f of x is 2, 1 plus x divided by 27. Okay, and here we will have this d of x. Now taking this 2 by 27 out of it, okay, and we will have here 2, 4, 1 plus x dx. Okay, and also 2 by 27, and the values here would be applying the linear property here. What we will have here 2, 4, 1 dx plus 2, 4 this x and dx here as well. Okay, now simplifying it, solving it, what we will get here, I will get 2 by 27, and the values here we will have x, and here 2, 4, and here I will have x square divided by 2, and the values are here again 2 and 4. Okay, also this 2 by 27, and here we will have 4 minus 2 plus this is the higher range in this x, while this is the lower range value. Similarly here we will have 1 by 2, and now x square higher minus x square lower value. Okay, now finding it out, what I will get 2 by 27, and here we will have 4 minus 2, which is 2. Okay, here this is 4, 4, 16, 16 minus 4 is 12 divided by 2 is, that is 6. Okay, So ultimately what we will get, this is 6 plus 2 is 8, 8 multiplied by 2 is 16, so 16 divided by 27, and that is what, that is the solution of part A. Okay, so that is what, that is the solution of part A. Similarly, you can also solve part B just like this one, and what to do in it, we can see that the ranges are given here which are from 3 to 4. So let me solve it here as well. So let me move down somehow. Okay, so now this is part B of my question, and here I have to find the probability that x is greater or equal to 3 and less than 4. Okay, now in order to do so, I have to write these limits. So these will start from 3 to 4, because I have told you that I cannot discriminate between the nearest values in continuous random variable. Writing the same values here, what I will get here, it will be 2 1 plus x divided by 27 dx. Okay, so again using the same function which we had done previously, the answer or the solution of it will be like this one, while the limits will change, and by solving it like this one, what will you get, you will get the answer of it which is 1 by 3. Okay, so the answer of it, by solving it and putting all these values, you will get 1 by 3. Okay, so that is what, that is the solution of the question 3.18. If you have any question, you can ask me in the comment box. See you soon.
Hello guys, I hope all of you will be fine. So this is question 3.19 of chapter 3, and here we have to go through exercise problem 3.17 and find the f of x, which is what, which is the CDF. Okay, so previously we have seen that in that question we have a uniform PDF which starts from 1 and ends at 3. Okay, and within this range it has a constant value, okay, which is 1 by 2. Okay, so this is for f of x and this is x. Okay, so it has a constant value which is written here. According to this, we have to find what, we have to find the capital F of x. Okay, so now in order to solve it, let me solve it here. So the solution of it is, okay, in order to find it out, what do we have to do? We have to add all these instances here, and as it is basically the continuous random variable, therefore it will start from 1 and will end at infinity, and therefore what we can do here is that we can write this capital F of x. This capital F of x will start from 1 and will move up till this x, which is at infinity. So we can find out these values at an instant, and therefore I have to add them. So therefore in order to add them in continuous variables or in continuous form, what do? We use the integration. Okay, so therefore in order to do so, here I have to start this integration from 1. Okay, I have to integrate it from 1 up to what, up to the value which is at infinity, and let me take it at x and or any value. Okay, this x can be of any value. It can either be from 1.2 1.3 up till and until any other value. Okay, so this is that x, and here I have to use this f of x, okay, and integrate it with respect to this d of t. Okay, so now let me use these values, and writing these values here, what I will get here, I will get, as the value of it is 1 by 2, so this 1 by 2 will be here, and I will take this 1 x and d of t. Okay, now integrating it, and what I will get, it will be 1 by 2, and here I will get what, this will be t, and the values of it are from 1 to x. Okay, now putting these values, what I will get, this will be 1 by 2, and the values of t will be x minus 1. Okay, so what is this? This is the solution of the part A, in which I have found out the CDF of the function which is given here in this form. Okay, so now here by putting any value here, I can find out the CDF of that value. Now by using the same formula, I have to find out the value of the probability in which x is greater than 2 and less than 2.5. okay, so I have to find out the probability that x is greater than 2 and less than 2.5. okay, so as I have the value here, so let me have this value here, and here in order to find it out I have to write here the value at 2.5 minus the value at 2. okay, now let me put these values, and here I will get 1 by 2, and x minus 1 is 2.5 minus 1, so it will be 1.5. okay, and minus 1 by 2, and here it will be 2 minus 1 is 1. okay, so now taking it out, and now 1.5 minus 1. okay, so ultimately what it will give me, this is 1.5 minus 1, this will be 0.5. so ultimately I will get here 1 by 4, which is the solution of this part. okay, so now we have found out the probability of different items which lies in different ranges by using the CDF which we have found here. okay, so that is what we have to identify and solve in question 3.19. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.20 of chapter 3, and the statement of it is, for the density function of exercise 3.18, okay, find f of x, which is basically the CDF, and use it to evaluate p x is greater or equal to 3 and less than 4. okay, so in exercise 3.18 we had f of x which was equal to the 2 divided by 27 multiplied by 1 plus x. okay, from x equal to 2 to x equal to 5. okay, so this was what the probability function was. So now what I have to do now, I have to find the capital F of x, which is the CDF, and in order to do so, what I will do, I will start integrating it starting from 2 up to any value x that would be here. okay, so let me write here the value of 2 up to any value x, because it is starting from 2 and ending at any value x. so therefore I have to write that value here as well, and also I have to change the domain of it, as I have been writing here the x, which is basically in accordance with the domain of the CDF. so therefore now I have to change it to the value which is basically t. okay, so here I have to write 2 by 27, and here let me write here t. okay, and I have to integrate it up with respect to t. okay, so let me write it here, and it will become 2 by 27, and here again integrating from 2x 1 plus t dt. okay, so now integrating it, what I will get here, I will get 2 by 27. okay, and also inside of it I will get t plus t square by 2. okay, and these values which are here, these will be here, let me write them here from 2 to x. okay, now after putting these values, what I will get, you can simplify it, and at the end what you will get here x minus 2 multiplied by x plus 4 whole divided by 27. okay, this is what, this is basically the capital F of x which I wanted to find out, and this is basically the CDF which we have. okay, so now in order to find the second part of it, which is finding the probability, and here in order to find the probability that x is greater or equal to 3 and less than 4, what I have to do, I have to include these two ranges in such a way that I have to subtract the lower range CDF from the higher range. okay, so I have to write here f, capital F of 4, and from it I have to subtract capital F of 3. okay, so now putting their values and also writing all these values in these equations, because I know the equation for it. So it will become, let me take this 1 by 27 out of both of them because it will be included in both of them. So now for 4 what I will get, x minus 4. So here I will get 4 minus 2, and also here x plus 4, this is 4 plus 4. Okay. Similarly, subtracting it from the lower limit, which would become here 3 minus 2, okay, and also x plus 4, that is 3 plus 4. Okay. So now let me simplify it, and here I will get 4 minus 2 is 2, 2 plus 8 is 16, 2 multiplied by 8 is 16. Okay, here I will get 16, and here I will have 3 minus 2 is 1, so 7 multiplied by 1 is 7. Okay, or 1 by 27, and here 16 minus 7 is how much, that is multiplied by 9. Okay, and ultimately I will get here 1 by 3, which is basically the solution of it. Okay, so that's it for today, in which we have found out the CDF for the exercise problem 3.18, and at the end we have also found out the probability between two ranges from the formula we have derived. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.21 of chapter 3, and the statement of it is, consider the density function which is f of x k square root of x, and that is in the range of 0 to 1, and it is 0 elsewhere. Okay, so what do we have to do? There is part A and part B. In part A we have to evaluate k, okay, or find the value of k, and in part B find fx and use it to evaluate this value. Okay, so now let me start it from part A and let me solve it here. This is the solution. Okay, let me solve it here, and in solving it we have this function in the range of this value, and we can very clearly see that in this range the cumulative function or the cumulative value of this function would be what? That would be 1. That would be 1 in between these ranges. Okay, so what do we have to do here? This is basically capital F of x, and that is the cumulation from 0 to 1, and I have to write the value of f of x, where k x, and I have to integrate it in this range. Okay, I can very clearly see that the value of 8 in this range, the value of 8 in this range would be how much? This would be 1. Okay, so let me write this value here, and this would be 1, and here this k is constant. Let me keep it outside, and here integrating it from 0 to 1. Okay, this is what, and here this square root of x is basically x to the power 1 by 2 d of x. Okay, now calculating it, what I will get here, it will be 1 is equal to what? Integrating it would be 1 plus 1 by 2 divided by 1 plus 1 by 2, so it would be x 3 by 2 divided by 3 by 2. Okay, and here I also have this k because here I have here. Okay, so now let me use it. Okay, and here keep multiplying both sides by this 3 by 2. What I will get? I will get here 3 by 2 is equal to the k x 3 by 2. Okay, and here as these were the ranges in which I have to integrate, so therefore here I also had 0 1, which will also be here 0 and 1. Okay, now putting these values here for x, what I will get here, I will get 3 by 2 is equal to k, and here this would be 1 3 by 2 minus 0 3 by 2. Okay, and ultimately the value of k will be what? The value of k will be 3 by 2. Okay, so that is what, that is the solution of part A of our question. Okay, in which we have found out the value which is 3 by 2. Now proceeding towards the part B of our question, the part B of our question is we have to find f of x. In order to find the f of x, what do I have to do? Now I know the value of k, which is already known. So what do I have to do? I have to integrate my function from the starting point up to any point. Let me take it x, as we have done previously. So this x is any point in between 0 and 1. If I will take the value of x and put it in this function, which I will find now, I will get the CDF of that function. Okay, this f of x, capital F of x, is basically the CDF. Now I have to write the value of k, and after it let me represent this x, which is in the actual equation, with another variable, and let me take as t. Okay, so let me take it t, and this would be t square root, and integrate it with respect to t as well. Okay, so now integrating it and then finding the values, because now the value of k is already known, and that is 3 by 2. So taking this 3 by 2 out of this, and here we will have 0 to x, and this would be t 1 by 2 dt, or integrating it all over, what I will get, I get 3 by 2 multiplied by, here this will be t 3 by 2 divided by 3 by 2. Okay, these two will cancel out, and here I will have the range, which is 0 to x. Okay, so now here what I will get, here this f, for this f of x, what I will have here, this is t 3 by 2, and first putting the higher range, which is x 3 by 2, and then from it 0 3 by 2, what I will get here, I will get x 3 by 2, which is the CDF in the range of 0 to 1. Okay, or mathematically, or I can also write it like, let me write these values. Okay, this of x is what, this f of x is 0 for the value of x less than 0. Okay, it is equal to x 3 by 2 for the range where x is greater or equal to 0 and less than 1, and it is 1 for all the range where x is greater or equal to 1. Okay, so these are all the values which I had to find out. This is 1. Okay, so this is the CDF of the function which I had to find out. Okay, after it, what do we have to find out? We have to find the value that probability of x is greater than 0.3 and less than 0.6, and in finding it out, let me find it out here, and here it will be probability of x is greater than 0.3 and less than what, 0.6. Okay, so here it will be what, here in using the CDF, what I have to write, I have to find the CDF of the higher value, which is 0.6, and from it I have to subtract the lower point, which is 0.3. Okay, now putting their values, I know the values which are here. So this is x 3 by 2 or 0.6 3 by 2, because now the value of x is 0.6, and putting the power of it 3 by 2, and also 0.3, and the power of it is 3 by 2. Okay, then evaluating it, what I will get, the answer of it would be 0.3004, which is the solution of part B of my question. Okay, so that's it for today, in which we have found the solution of question 3.21. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.22, and this is chapter 3 related to the random variables and probability distributions. So the statement of this question is 3 cards are drawn in succession from a deck without replacement. Okay, so find the probability distribution for the number of spades. Okay, so here we have to see that the probability distribution for the 3 spades. Okay, so the given data here is, in given data we have to make some suppositions as well. Here let me take this, and for no spade, okay, and S for the spade. Okay, what we have here, we will have to bring out 3 cards. So 3 cards we will have. Okay, so in these 3 cards we can either have 0 spade, okay, we can either have 1 spade, 2 spades, or at most 3 spades. Okay, so we have to find the probability of each of the spade here. As you know that we have here, these are the number of spades in 3 terms. Okay, so let me solve it first. And in first turn, where we have the probability of spade equal to 0, what can be the options here? We can have here the event where all of the 3 items here are non-spade. So it would be n. Okay, so here if the 3 items are non-spade, what it can be, it will be all the items in the first will be the 39, because the total number of items here are 52, and out of these 52, 13 are spades, okay, while 39 are non-spades. Okay, you can see that here we have, if we don't have any spade in the first turn, therefore the total number of items in the first turn I have to pick are 39 out of the total, which are 52. Okay, so this will be the first turn. If one non-spade item has been selected out of it, how many remaining non-spade will be here? We will have here 38 non-spade, and the total items here are 51, because here we have the without replacement sampling. Okay, so here we will have this one, and in the third item what we will have here, now 2 items have been selected from 39, so here we will have 37, and out of the 50 we have here. Okay, so this is the overall probabilities of what we have to find out. So these have to be multiplied together, and when I will multiply them together, what I will get here, I will get 703 divided by 1700. Okay, so this is what, this is for s equal to 0. Similarly, for the probability of s equal to 1, where we have only one spade, so what are the options I have? So the number of options I will have would be either the first item will be spade while the other two will be non-spade. Okay, this is the first one, sorry, this is the first one. Second one would be the second item is spade, while the first and the third one are non-spade, and the third one is the first 2 items are non-spade while the third one is a spade. So this is what, this is for the probabilities it has. Okay, so now what do we have to do here in order to do so? Again, using the same terms, like here it will be s and n, okay, or we have here the probability of n, s, and, okay, or here I will have probability of the n and s. Okay, so this is what we have. Now in order to find the probability of them, we can see that these 3 are independent of each other, so therefore writing their probabilities. So the probability of getting one spade, or the first one spade, is will be what, it will be the 13 out of the 52. Okay, so it will be what, it would be the 13 out of the 52 are the spades. Okay, now when we will get it, what will we get here multiplying this one? Well, let me identify it, it will be here. Now after it, the other one is n, so this n is from the non-spade. So as one spade has been selected, so the total item remaining are 51, while the non-spade are still the same, because none of the non-spade has been selected, so it will be here. Okay, so this one is for here,
okay, and the last term here is again non-spared. So therefore, as one non-spared has been selected, so 38 are here and 50 are the total one which is remaining here. Okay, so you can see that the other ones will also be like the ones we have got here, but in the multiplicative term these will be somehow in different order, but these will be the same item. So therefore, what I have to do here, I have to multiply with them 3 as well. Okay, you can see that here for the first item you will get this one, for the second you will get this one, and for the third one you will get this one. Okay, for this one the first two will be the 39 and 38 terms, while for the last term you will have this one. Okay, that's why I have added them all together and put it here, this 3. Okay, so now by combining them all, what I will get here, the answer of it will be 741 divided by the 1700. Okay, this is for the probability of s equal to 1. Okay, now similarly let me go down somehow. Okay, and here in order to find the probability that s equal to 2, what will be the options here? Here the options would be the probability that either the first two are spared and the last one is non-spared. Okay, and the second one here is the first one is the non-spared while the last two are spared. Okay, and the last one here is the mid one is the non-spared while the others are spared. Okay, so this is what we have the probabilities. Now in order to do so, what do we have to do here? Again, the probability of SSN, okay, or the probability of NSS, or the probability of SNS. Okay. Now putting their values here, the probability of SSN, so probability of S1, then probability of S2, and then probability of N, and similar will happen for them as well. So therefore I will put here 3 as well. So for the probability of first paid, what I will have here, I will have 13 divided by 52, because the total number of spades here, if one spade has been selected, so the number of spades remain here would be 12, while the total number of items will be decreased to 51, and the last non-spade, as none of them is the non-spared here selected, so therefore the non-spared will remain the same and it will be 39, while the total number of items are reduced to 50. Okay, and similar will happen for them as well, because you can see that the options here we have are the 2 spades and 1 non-spared, so similar is for here, so therefore I have to put here 3, and this is what you can see yourself as well, that when you will do it for the same items here, you will get the same answer, and therefore I am putting here this 3. So after multiplying them together, what will be the answer of it? Here the answer of it will be 234 divided by 1700. Okay, so this is for probability that s equal to 2. Okay, now let me move down somehow more, and for it the 3 spades. Okay, so the probability that we have spades equal to 3, so it would be what? It is only the item where we have spade, spade, spade. Okay, so this is what we have. Now let me put their values here. The probability of spade 1 multiplied by the probability of spade 2 and multiplied by the probability of spade 3 spades. So now when one spade is selected out of the 13, so here the probability of it is 13 divided by 52, multiplying it with the probability of spade 2 when 1 is selected, so it will be 12 divided by 51, and the third spade is out of the same spade, so therefore it will be 11 by 50. Okay, so what will be the answer? The answer of it will be 22 divided by 1700.
Okay, so this is for the spade equal to 3. Okay, so these are all the options we had here, and from it we have found out all the ways from which we can get it. Okay, so now let me plot them here, and in plotting them, what I have to do here, let me write their values. Okay, so in writing their values, let me use it here, and here let me use them with green. So this is x, this is f of x, which is the probability, and let me write their values. So the first value of x or spade is 0, the second one is 1, then 2, then 3. Okay, so these are all the values it has. So this is the values of x. Now putting their values, the probability that spade is 0, that is given here, that is 703 by 1700. Okay, that is already given. For spade equal to 1, that is 741 divided by 1700. For two spades, this is 234 by 1700. Okay, and the last one for three spade was 22 divided by 1700. Okay, so once you will add them all together, you can see that when you will add them all together, like 703 divided by 1700 plus 741 divided by 1700 plus 234 divided by 1700 plus 22 divided by 1700. So it will be what? This would be the 1700, and 703 plus 741, this is 1444. So 1444 plus 22, so that is 1466. 1466 plus 234, that would be 1700, and you will see that these will cancel out, and ultimately you will get 1, which is what? Which is the condition for any probability distribution, that when you add all the probabilities in it, what will be the answer? It will be equal to 1. Okay, so that's it for today, in which we have seen the probability distribution for one of the problem of the probability. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.24 of chapter 3, and here we have to find the probability distribution for the number of jazz CDs when 4 CDs are selected at random from a collection consisting of 5 jazz CDs, 2 classical CDs, and 3 rock CDs. Okay, so the total number of the CDs we have to select are basically how much? So we have to select 4 CDs out of total how much? So the total number of CDs here are how much? So these are basically 5 jazz CDs, 5, 2 classical CDs plus 2, and 3 rock CDs. Okay, so the total number of CDs we have are 10. Okay, so now in order to solve it, we can very clearly see that the selection of them is basically the total number of selections. So total selections are how much? Okay, so the total number of selections are, I have to select 4 CDs from 10, so therefore it will be 10 choose 4, so it will be the combinatorics. Okay, which is basically 10 factorial divided by 4 factorial and then 10 minus 4 factorial, which is the 6 factorial. So these are basically the total number of selections. Now I have to find the probability distribution, and I have to express my answer by means of a formula. So what do I have to do here? In order to solve it, let us find the solution of it here. And here, in order to do so, first of all, what will I have to do here? I have the 5 jazz CDs, and here to find the probability of selecting X number of CDs would be how much. So here first of all, from 5 jazz CDs I have to select any number of CDs which are X. So from the 5 jazz CDs I have to select the X number of CDs. Okay, so when these X are selected, how many are left? The left CDs I have to select would be 4 minus X. Okay, so X are selected, so out of 4 how much are left? I have to select here. Okay, so now here from these I have the CDs which are left behind are 10 minus 5. Okay, so which are those 5? Those are 2 classical and 3 rock CDs. So here again I have 5 number of CDs, or I can also write it like, okay, let me simplify it by writing it the 2 classical CDs and 3 rock CDs, which will ultimately give me how much? Which will ultimately give me 5. Okay, so these are the number of CDs I have to select and divided by the total number of selections which I have already found out, and these are given here. Okay, so now let me write them here, and it will be 10 choose 4. Okay, so now these are basically the probability of different items I have to select. In order to find the number of CDs from the jazz which are 0, what I have to write here? I have to write here X equal to 0, putting X equal to 0 here, and I will get the answer, and so on. So therefore the value of X will range from 0, 1, 2, 3, and most up to 4. Okay, these are the total number of the items which I can select here, and this is the formula I can use to find out the probability distribution for the set question which we were asked to find by means of a formula. Okay, so this thing is already given here. Okay, so that's it for today, in which we have found out the probability distribution formula for the problem at hand. If you have any question, you can ask me in the comment box, and also you can simplify this one to find out different probability distributions and so on. So that's it for today, and see you soon. Hello guys, I hope all of you will be fine. So this is question 3.25 of chapter 3, and the statement of it is, from a box containing 4 dimes and 2 nickels, 3 coins are selected at random without replacement. Okay, so find the probability distribution for the total T of the 3 coins, or the total number of cents in 3 coins. Okay, so express the probability distribution graphically as a probability histogram. Okay, so the amount of the given data which is given here, so let me put it here, and that is, let me have this given data, and let me represent this dimes with D and nickels with N. Okay, from the given data it is said that there are 4 dimes. Okay, and how many nickels? We have 2 nickels. Okay, so from the cost of the dimes we know that 1 dime is equal to the 10 cents. Okay, and 1 nickel is equal to how many cents? These are basically 5 cents. This is already given. Okay, so from them, if we have this total number of coins which are 6, we have to select any 3 coins. Okay, so we have to select how many coins? 3 coins without replacement. What is meant by without replacement? Once a coin has been selected, it will not put back into the original number of coins. Okay, so this is the without replacement. So now what do we have to do? We have to find the distribution for the total of the 3 coins. Okay, so now let me solve it, and in solving it, let me have here the solution. So what are the combinations we can have here? So suppose initially we have the 3 coins which are dimes, so we can have here dime, dime, dime of the 3 coins. Okay, similarly we can also have 1 nickel out of the 3 coins, so it can either be dime, dime, nickel, or dime, nickel, dime, or nickel, dime,
dime. Okay, we can see here that these three are basically lie in the same category in which we have only one nickel. Okay, so therefore we will have a single term for it. Okay, so here this is a separate, this one is separate. Okay, similarly for the two nickels, what can I have here? Either here I will have nickel dime, or nickel dime nickel, or dime nickel nickel. Okay, so here these three are also in the same category where we have two nickels, and we cannot have here more than two nickels because the given number of nickels here are two. Okay, so therefore the cost here would be how much? The cost here of this one, or the total cost here would be for this one will be how much? This will be 10 plus 10 plus 10, this will be 30 cents. Okay, for it will be 10 10 5, or 10 5 10, or 5 10 10. So these three will give me the equal number of cents, it will be 25. And similarly for this one, here I will have 5 5 10, or 5 10 5, or for dime 10, nickel 5, nickel 5, here it will be 20. Okay, so for each of them it will be the same for each category, for the each number of the dimes or the nickels. Okay, so now what do we have to find out here? We have to express the probability distribution graphically as a probability histogram. For what? For the probability distribution of the total t. Okay, so now here in order to find it out, for let me have here the probability that t is equal to 20. Let me start it from 20, and here in this range we can very clearly see that this is the range, and here we can clearly see that we have two nickels and one dime. So these two nickels have been selected out of these two nickels, which are in total in number. So therefore it will be what? It will be the 2 out of 2 choices 2. Okay, similarly we have only one dime here, which is here, and this one dime has been selected from the total number of dimes, which are 4 here. So 4 choose 1. These are the number of choices we will have here, dividing it over the total number of choices. Okay, so the total number of choices here will be the 3 out of this 4 plus 2, which is 6. So therefore it will be the 3 from what? 4 plus 2. Okay, so this 4 plus 2 is basically how much? This 4 plus 2 is 6. Okay, so you got my point that here in the numerator what I have to write? I have to write the choices in event divided by the total number of choices. Okay, so total number of choices. So there, that's what I have done. So now simplifying it, what I will get? 2 choice 2 is 2 factorial divided by 2 factorial, and then 2 minus 2 is 0 factorial. Multiply it with the 4 1. So 4 factorial divided by 4 minus 1, 3 factorial, and this 1 factorial. Okay, and also dividing it over this one, 6 factorial divided by the 3 factorial, and then 6 minus 3 is also 3 factorial. Okay, so solving it out, what I will get here? The answer of it would be how much? That is 1 over 5. Okay, similarly for the probability that t is equal to 25, which is basically this one, and here we can see that we have two dimes, okay, here and one nickel. Okay, so in order to do so, what can I write here? Here I can see that the total number of choices will remain the same, which are 6, choose 3, while here for the nickel I have only one nickel out of the total number of nickels, which are 2. Okay, so 2 choose 1, while the dimes here are 2. Okay, so I have to select these two dimes, any number of dimes from the 4, total 4. Okay, so now solving it by using the same formulation what we have done here, I will get here 3 by 5. Okay, you can try it out. Similarly, let me move down somehow, and here for the probability that t is 30, what I have to do here, I can see that when t is 30, I have 3 dimes, okay, and no nickel. So therefore, for the nickel, I have 2 nickels. For them, I have 0 nickel here, while for the dimes, I have total number of dimes 4. From it, I have to choose 3, while the total number of choices will remain the same, which are 6, 3. Okay, so here from it, what I will get here, it will be 1 by 5. Okay, so these are all the probabilities whatsoever we have found out here. Okay, so here we can also write them out here. So let me write them out here. This is what we have. This is t, and this is the probability of t. Okay, so now writing them out here, the t is 20, 25 and 30. Okay, and the probabilities we have them for here. The probability of t equal to 20 is 1 by 5. For 25 I have 3 by 5. For 30 I have also 1 by 5. Okay, so therefore these are the probability distribution, because by adding 1 by 5, 3 by 5, 1 by 5, what I will get, the summation of them all will be equal to 1. So this is the probability distribution. So let me also draw it here as well. So in order to draw it, let me have this one. This is what we have. So this is what the random variable t, this is what we have the probability of t. Okay, and also we have some values here. Let me have here 0, this is, let me have 20, this is 25, and this is 30. Okay, and let me have different values here. Let me have here, this is 1 by 5, this is 2 by 5, and let me have this one as 3 by 5. Okay, so let me draw them here, and the first one, which is 20, p of t for it is 1 by 5. This will be for it, and this is for p equal to 20, this is 1 by 5. Okay, similarly for the 25, here we have 3 by 5, so this is here, and let me start it from here and have to move here, and it will be like this one. Okay, so this is what, this is the 3 by 5, the histogram for t equal to 25. Okay, similarly for 30, I have here this one, and this is 1 by 5. So for 1 by 5, I have here this one, and this is the distribution for it as well. We can also make it more convenient by reducing the size of the boxes as well. If you reduce the size of the boxes, just like here, let me make it more convenient by reducing the size of the boxes as well, and you can see that the plot here will be more beautifully look like. So it is 20, it is 25, and it is 30. Okay, and here it will be like this is here, and also this is here, and this one here as well. Okay, so here this one is 3 by 5. Okay, this one is 1 by 5. Okay, so these are what, these are the probability distributions. Both are the same, but here the width of the bar is somehow lower as compared to this one. Okay, so that's it for today, in which we have seen that how to calculate the probability distribution function for the random variables which we have been given here. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.26, and the statement of it is, from a box containing 4 black balls and 2 green balls. Okay, so we have a box in which we have 4 black balls and 2 green balls. 3 balls are drawn in succession, each ball being replaced in the box before the next draw is made. So this is basically the sampling with replacement. Okay, find the probability distribution for the number of green balls. Okay, so here we have, let me have here the given data, and in given data let me have here this box. Okay, and in this box we have 4 black balls, which are 1, 2, 3 and 4. 4 black balls and 2 green balls. Okay, so these are 1 and 2. Okay, so these, out of these balls, what do we have to do? We have to select, let me use another color for it, which is this one. We have to select 3 balls, okay, which are selected randomly, and another statement has been given here, and that is the with replacement. Okay, so what is mean by with replacement? Once a ball has been selected, it will be put back into the same bucket, and in next turn the same number of balls will be present in this box. Okay, so this is the with replacement. If I will select a ball out of it and will not put back it into this bucket, that would be the sampling without replacement. Okay, so here I have been doing all the sampling with replacement, and here the probability of the ball equal to black, or probability of black ball, how much is this? We have here the total number of black balls 4 divided by the total number of balls, which are 6. So here the probability of black balls are basically 2 by 3, and similarly the probability of the green balls is how much? That is number of green balls divided by the total number of balls. So here it would be 1 by 3. Okay, so this is what, this is the probability of different balls. Okay, so now we have these balls, and let me remove it and start solving it here. So the solution of it would be here, and in solving it, what do I have to do? I will have different sampling arrangements or combinations for them, and these are the sampling combinations. Let me write them here. So samples. Okay, on the basis of it, what will I have? I have to find the number of green balls and their probability distribution. So it will be the number of green balls, and or ng, or it can also be represented at x, and also the probability of the x of that event. Okay, so let me write them here, and here it will be like this one. Okay, so the first sample here I can have would be the black, black, black. Okay, so for it the number of green balls are 0, so therefore the probability of it, as these are the 3 independent events, so what it will be? It will be 2 by 3 multiplied by 2 by 3 multiplied by 2 by 3, so it will be 2 to 4, 4 to 8, so 8 divided by 27. Okay, so the probability of this is 27. Similarly, for the next, I can also have black, black, and then green. Okay, so for it, the number of green balls are 1, and what will be the probability of it? It will be 2 by 3 multiplied by 2 by 3 for the black, and for the last one, which is green, the probability of it is 1 by 3. So it will be how much? It will be 2 to 4, 4 divided by 27. Okay, so similarly for the green ball here as well, for the third, I can have black, green, and the last one here is black. Okay, so here the number of green balls is again 1, and after you will calculate it, here you will have 2 by 3 multiplied by 1 by 3 multiplied by 2 by 3. It will be the same which is for here as well, so it will be 4 divided by 27. Okay, similarly for the last one here in this combination, I will have here what? I will have here 1 black and 2 greens, green
and green. Okay, so now the number of green balls are 2, and here by finding them out, what I will have here, I will have 2 by 3 multiplied by probability of green, which is 1 by 3, and the last one here is 1 by 3, and here we will have 2 divided by 27. Okay, so these are for these 4. Similarly, for the next turn, I will have green and then 2 black. Okay, so again we can see here that we have 1 green, so here it will remain the same, and the probability of 1 will remain the same here, and that is 4 by 27. Okay, by multiplying them together, the probabilities, you can find it out. Similarly, for the next item, you will have here green and here black, and the last one here would be green as well, and here you can very clearly see that we have 2 greens, and therefore the probability of it is 2 by 27. Okay, and for the here we will have green, and the last one here is black, and the number of greens are 2, and the probability of it is 2 by 27. Okay, so this is what for it we have. If we had the 3 balls here, or in this combination, we can also have the third green ball here as well, because this is the sampling with replacement. So therefore here we can also have here green, green in the 3 turns as well. So here the number of green balls will be 3, and here multiplying them together, the probabilities, which are 1 by 3 multiplied by 1 by 3 multiplied by 1 by 3, so it will be 1 by 27. Okay, so these are all the probabilities whatsoever we have here. Okay, so now writing the different probabilities of the different balls, what we can have here. So let me write here the probability of x equal to 0, or the number of green balls equal to 0. So the probability of it is already given, and that is only a single item which is here. Okay, so this is only the single item, and for it the probability is 8 by 27. Okay, so this is 8 divided by 27. Okay, similarly, for the probability that x is equal to 1. Okay, so let me move down somehow. So here, what will it be? We will have to see that what are the events where x is equal to 1. So here I have this, and this. These are the 3 events in which these are 1. So I have to add them together. So 4 by 27, the first one, plus 4 by 27 for the second, and 4 by 27 for the third one. Okay, or multiplying them with 3 with the single item. So what will I get here? I will have 12 divided by 27. Okay, for the probability that x equal to 2, what I will have here, all the items where the x equal to 2. So here this one, and this, and for them all I have 3 multiplied by 2 by 27. Okay, so what will I have here? It will be 6 divided by 27. Okay, and for the last one where the x equal to 3, okay, or the probability that x equal to 3, what is the probability of it? This is already given, and that is 1 by 27. Okay, so that's it, what we have for different items of the number of the green balls. Or now plotting it out here, what I will have, this is x, this is p of x. Okay, and here we will have these items, like this is 0, 1, 2, 3. Okay, so we will have them here. Okay, let me put them here. It will be 8 by 27 for the 0. For 1 I will have 12 by 27. For 2 I have 6 by 27, and for 3 I have 1 by 27.
Okay, so by adding them all, when you will add them all, you can very clearly see that it will give me output equal to 1, which is the basic condition for the probability distribution, that when you will add all the probabilities, it must give you the answer equal to 1. Okay, so that's it for today, in which we have seen the probability distribution for the question 3.26, in which we have found out the probability distribution for the number of item selection with replacements. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. This is question 3.27. And the statement of it is the time to failure in hours of an important piece of electronic equipment used in a manufactured DVD player has the density function which is given here. Okay, that is f of x, and which is 1 by 2000 exponential of minus x divided by 2000 for x greater or equal to 0, and it is 0 for x less than 0. Okay, so on the basis of it, we are given some parts. So let us start the solution of the part A of it, and in solving it, what we have to do, let us solve it here. Let me first write that what is the density function what we have. So that is f of x equal to 1 over 2000 exponential of what, minus x divided by 2000. Okay, so that is what the density function we have. In order to find the CDF of it, or capital F of x, what do we have to do? We have to integrate this function from 0 to any unknown value, that is, let me call it x. Okay, so let me write it here, and from 0 to x, because it is starting from 0, so let me take it from 0 to x, and here writing the density function in another domain, and let me choose that domain as small t. Okay, so it would be exponential of minus t divided by 2000 and integrated with respect to t. Okay, so now integrating it, what I will get here, it will be 1 over 2000 outside of this integrals, and here 0 to x exponential of minus t divided by 2000. Okay, and d of t. Okay, from the previous section we have seen that the integration of the exponential is what, if I have a exponential of ax. Okay, so the integral of it with respect to x would be how much? So it would be the exponential of ax. Okay, so let me apply the same over here, and what I will get here, this f of x would be what? It would be this negative sign here, so it will become minus exponential of minus t divided by 2000. Okay, and the range it has 8 from 0 to x. Okay, so let me write these ranges here, and in writing these ranges here, it will be minus, and here it will be the higher range, here will be the exponential of x divided by 2000. Okay, and subtracting for it exponential of 0 divided by 2000. Okay, so these are basically the ranges whatsoever we have. Okay, now simplifying it on the basis of these ranges, what I will get here, we will get what, exponential of 0 is 1. Okay, and it will be what, exponential of, sorry, here we have minus x. Okay, so here we have the minus x. Okay, so here what we will have, this minus 1 become plus 1, because this negative will be multiplied with all of them, and it will become what, it will become 1 minus exponential of what, minus x divided by 2000. Okay, and that is what, that is the value of f of x for all x greater or equal to 0. Okay, and similarly it will be 0 for all x less than 0, and this is what, this is the solution what we wanted to find out here. Okay, so that is what the solution of part A. Okay, so similarly, on the basis of it, what I have to find out in part B, we are asked that determine the probability that the component and thus the DVD player lasts more than 1000 hours before the component needs to be replaced. Okay, so here what do I have to find out? I have to find out the probability that the component lasts more than 1000 hours. So if the hours here are capital X, so it should last more than 1000 hours. Okay, so in order to find it out, going beyond 1000 is what we have to subtract all the values lower than 1000 in the CDF. So it will become 1 minus f of 1000. Okay, so I hope you have got this point, and on the let me also explain it here as well. So if I have the CDF plot here, let me have the CDF plot, and it is like this one. Let me have some values here, and if I want to find out the value, if this is, let me call it 1000. Okay, and if I want to find out the values which are here in this range, okay, and I know that here ultimately it will converge to what? It will converge to 1. Okay, so what will happen? I have to subtract this overall, or this area, which, or we can see that all this area which is the overall here is 1. So I have to remove this area from it, so therefore I have to subtract this one from 1. Okay, so this will be this f 1000, which are basically the lower accumulated values. So therefore I have been doing it, and these would be the higher values what has been given here in this blue color, and which is here this one. Okay, so I hope you have got my point. Okay, so now let me remove it and let me solve it here as well. Okay, so let me write these values here, and it will become 1 minus the exponential value here is 1 minus exponential of minus 1000 divided by 2000. Okay, which is the value given here. Okay, now let me find them out, and finding them out I can very easily see that it will become 1 minus 1 plus exponential of, this will be minus 1000 by 2000, this will be minus 0.5. okay, these two will cancel out, and ultimately we will have exponential of minus 0.5, and the answer of it would be 0.6065. okay, that is what, that is the answer of part B, and for it I have used the formula which is given here, and I have also explained it on the basis of the graphical illustration. Okay, the last part of it is determine the probability that the component fails before 2000 hours. Okay, means it will reach, it will not reach the 2000 hours, or it will be malfunctioned before these 2000 hours. So let me move down somehow. Okay, so here let me solve this question here, and it will be, I have to find out the probability that the hours are less than, sorry, yes, 2000. Okay, so in order to find it out, I can very clearly see that in CDF all the previous up to 2000 has been accumulated. So therefore I have to find f of 2000. Okay, so I hope you have got this point, because when this one is like this one, okay, and it is like, let me have here this 2000. So finding the probability here means all the values has been accumulated here, because this is the accumulation. CDF is basically the accumulation which is represented by f of x, and this accumulation is the accumulation of the probability distribution. Okay, so now putting this 2000 here, what I will get? I will get 1 minus exponential of minus 2000 divided by
2000. Okay, so here it will be 1 minus exponential of -1, and ultimately it will give me what? It will give me 0.6321, and that is the solution of part C of my question. Okay, so that's it for today, in which we have seen the three parts related to the CDF and the probability density function. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.28 of chapter 3, and the statement of it is: a cereal manufacturer is aware that the weight of the product in the box varies slightly from box to box. In fact, considerable historical data have allowed the determination of the density function that describes the probability structure for the weight in ounces. Letting x be the random variable weight in ounces, the density function can be described as this function, which is f of x, and this is 2 by 5 in the range which is given here, in which x is greater or equal to 23.75 and less than or equal to 26.25 and 0 elsewhere. Okay, so in given data we can see that this is basically the f of x, this is x, this is f of x, and it only lies between 23.75, let me say this is 23.75 up to 26.25, 26.25, and the value of it is 2 by 5. Okay, so let me have here, this is 2 by 5, and it is constant in between these ranges. Okay, we can see that this is the area under 23.75 and 26.25, which is 2 by 5. Okay, the value of it is 2 by 5, and we have to find different answers given in the form of question A, B, C. Okay, so what is part A? We have to verify that this is a valid density function. Okay, so in order to verify that it is a valid density function, what do we have to do here? The area in between this, or the overall area here, should be equal to 1, which is the cumulation of all the probabilities lies in between these ranges. Okay, so as we can see that this is a continuous random variable, so therefore in order to find the area, what we can do, we can use here this function, which is the integration. Okay, so in order to integrate this of x, what do we have to do? We have to write different ranges, which are from 23.75 up to 26.25, and here we have to integrate our function f of x d of x, and we have to see that what is the area in between here. Okay, if the area is equal to 1, then this would be a valid density function. Okay, so what is f of x here? So let me write the value of f of x here, and that f of x is given, and that is 2 by 5, and here this is d of x. Okay, so now in order to integrate it, what we can see that here we have this 2 by 5, which is a constant, this is 2 by 5, and here it would be these two ranges, 23.75 and 26.25. so 23.75 and 26.25, and this is this, and here from it I will get what? This will be 2 by 5 multiplied by x, and this will be the range from 23.75, and the higher range is 26.25. okay, so now let me write these ranges here, and here we will get 2 by 5, and the ranges of x will be from 26.25 minus 23.75. okay, subtracting for it, what I will get here? I will get 26.25 minus this, so I will get here 2 by 5 multiplied by 2.5. okay, so 2.5 here, So let me calculate it. It will be 2.5 multiplied by 2 will be 5 divided by 5, which is what? Which is equal to 1, which basically shows me that this one, okay, this one is a valid density function, and that is because of this one, which is the area in between these two ranges. Okay, so that is the area which is covered by this curve. Okay, so that is what the answer of part A is. Now in order to solve part B, let me first see that what is it. Determine the probability that the weight is smaller than 24 ounces. So the weight is smaller than 24 ounces. We have to find the probability of it. So we can see that this range, the smaller range is 23.75, and up to the higher range, which is 24, we have to find the probability here, and that probability that x is what? X is less than 24. Okay, so here in order to do so, we have to write the lower range, because below this the probability is 0. So therefore this would be 23.75, and here it will be 26 point, sorry, it will be the higher range here will be 24, because the higher range is this one. So I have to write this one, and here as we have previously seen that it would be 2 by 5, here it would be d of x. Okay, so now writing it, it will be 2 by 5 and here x and 23.75, and here I will have what? 24. Okay, so now then calculating it and then finding all, we will see that here the answer of it will be 0.1, which is the probability that the weight is less than 24. Okay, so that is what the answer of part B. Okay, so let me move down somehow and see that what is the part C. So in part C, we have to see that the company desires that the weight exceeding 26 ounces be an extremely rare occurrence. What is the probability that this rare occurrence does actually occur? Okay, so what we have to do in this case, the lower range is 26 and higher than this would be 26.25, and exceeding from 26 up to 26.25 is a very rare case. Okay, we have to find the probability of it. So it would be what? This is part C, and we have to find the probability that the weight is greater than 26. Okay, so this would be what? This would be the lower range. Let me have it here 2 by 5, again the same function, and the lower range here would be 26 and the higher range here will be 26.25. okay, and here we will have this d of x. Okay, now again calculating it and finding all the probabilities, let me write here, this would be 2 by 5, okay, and multiplying it with the value which we will get here, that would be x. So from it I will get 26.25, so here we will get 0.25, and finding it out we will get 0.1, which is a very rare case because of the probability we have here. Okay, so this is the probability that x will be greater than 26, or the weight will be greater than 26 ounces. Okay, so that's it for today, in which we have seen the solution of question 3.28. If you have any question, you can ask me in the comment box. Welcome back, guys. I hope all of you will be fine. So this is question 3.29 of chapter 3. And the statement of it is, an important factor in solid fuel is the particle size distribution. Significant problems occur if the particle sizes are too large. From production data in the past, it has been determined that the particle size in micrometers distribution is characterized by this f of x, which is 3x raised to the power minus 4 for x greater than 1 and 0 elsewhere. Okay, so what do we have to find out on the basis of all these data? We have three options, A, B and C, and we have to find the answer of each of them. Okay, so in first part of this question, we have to verify that this is a valid density function. Okay, so let me start the solution of it. So in solving it, let me have, this is part A, and in order to verify it, what do we have to do? We have to see that whether in this range, which is x greater than 1, whether this function converges to 1 or not. Okay, if this function which is here in this one, if it converges to 1, then it would be a valid distribution or valid density function. Okay, so let me start it now here, and here in order to do so we have this function and I want to integrate it within this range. So it is starting from 1 because x is greater than 1, so it is starting from 1 because this is a continuous function, and will end at infinity because x is greater than 1, it goes to infinity as well. Okay, now at the end of it I have to write x dx, which is what I have to integrate it. Now let me put their values, and here putting their values, what I will get, it will be 1 infinity, and the value of f of x is 3x minus 4 dx. Okay, so now let me solve it. 3 is the constant, so it will come out of this integration. So now 1 infinity x of minus 4 dx. Okay, so now integrating it, what I will get here, I will get 3 multiplied by x minus 4 plus 1 is minus 3 divided by minus 3, and it is from 1 to infinity. Okay, these two will cancel out, and here we will get minus x minus 3, and here 1 infinity. Okay, let me put their values, the ranges we have here. So putting these ranges here, what I will get here, x of minus 3 or 1 over x of 3, so it will become infinity cube, and similarly from it I have to subtract this 1. So putting the value of 1 here as well, what I will get, 1 over 1 of 3. Okay, why is it? Because here this x of minus 3 can also be written of x cube. Okay, so it can also be written here like this one. So now solving it, what I will get, this 1 over infinity is 0 and this 1 over 1 is 1. So ultimately from here I will get 1, which means that this is a valid density function, and from it we have found out that this one is equal to 1. Okay, so now similarly going to part B of it. So part B here, and we have to evaluate f of x, or what, we have to evaluate the CDF from it. So it will be f of x, and here I have to integrate it from the limit or the lower limit to any other point. Let me take it as x. Okay, and for it I have to change the domain of my function, and here I am changing it from x to t, and what I will get here, I will get t minus 4 and dt. Okay, from here what I will get, going through the same process whatsoever we have done here, I will get here minus t of minus 3, and here I will have 1 and x. Okay, and going through all these processes and putting these ranges here, what I will get here, I will get x minus 3, and then here putting 1, I will get here 1, or ultimately 1 minus x of minus cube. Okay, this is what we have here, and that is what, that is for x greater or equal to 1. Okay, so that is what the solution of part B. Okay, and here we can also see that what about the ranges which are less than 1. So for x less than 1, it will be what, it will be 0. Okay, so that is also another range here we have. So let me also put it here as well, and this is for what, this is for this f of x. Okay, so I have found out the value of CDF from it as well. Okay, so in order to solve part C of it, let me move down somehow, and here I have to find out that what is the probability that a random particle from the manufactured fuel exceeds 4 micrometers. Okay, in order to do so, what I have to find out, I have to find out that the probability that x is greater than 4. Okay, how can I find it out? I can basically find it out from f1 minus f of 4. Okay, and the reason I have told you before it, and that is because of, let me have here this f of x. Okay, and here we have x, and here we can see that here, if these are the densities. Okay, and if I want to find out, let me have here the area. Here we have 4, and all these areas, these are what? These are greater than 4. Okay, and all of these areas which are, let me use here this yellow color. Okay, all of these areas are what? These are all less than 4. Okay, so here we can see that this is the area what we want to find out. So here all these will give me 1. Okay, because this will converge here to 1, and in order to find from it this area, what we can do here, this is the accumulated probability function. So therefore from 1 I can subtract this area and I will get the whole one which is here. Okay, so that's why I have used this one here. Okay, you can see that why I have used here, because this 4 is what? This is the area here, and this one is the total area here, and I want to find out here this one. Okay, so from this function I can easily find it out. So let me put their values. So here it will be 1 minus this f of 4 which is greater than 1 here. So let me put their values here, and it will be 1 minus the value of x is now 4 minus 3. Okay, so now opening it, what I will get? 1 minus 1 plus 4 minus 3. These two will cancel out, and here I will get 4 minus 3, or 1 4 3. So it will be 1 over 64. Okay, so that is what? That is the solution of part C, what we wanted to find out. Okay, so that's it for today, and the essence of these type of question is not to go through all the questions again and again, but to let you know that what is the essence of the questions like this one. How can you use the probability density function, the cumulative distribution function, and all these things to find out the essence of the real world problems. Okay, so I think it's enough for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.30, and today we are going to discuss it in the context of the random variables and probability distributions. Okay, so the statement of it is, measurements of scientific systems are always subject to variation, some more than others. There are many structures for measurement error, and statisticians spend a great deal of time modeling these errors. Suppose the measurement error x of a certain physical quantity is decided by the density function, which is given here as f of x, which lies in between -1 and 1, okay, and 0 otherwise. So what are the options we have here? In part A of it, we have to determine k that renders f of x a valid density function. Okay, so in order to do so, let me solve it here. Okay, and this is part A. So in order to describe any density function and make it as a valid density function, what do we have to do? All these probability densities should be accumulated to give us 1. Okay, so what do we have to do here? I have to take the limits which are from -1 to 1. In this limit, I have to take this f of x dx, and it must be accumulated and give me 1, which is basically the condition for a valid density function. Okay, so let me put values here which are the values of f of x. So here this would be -1 1, and here it would be k 3 minus x square, and it should give me 1. Okay, so now in order to do so, this k is constant. Similarly here, now I will have -1 1 3 dx. Okay,
this should always be equal to dx here as well. Okay, here also we must have minus and minus 1 to 1 x square dx. Okay, and it must give me 1. Okay, now let me simplify it, and simplifying it, what I will get here, I will get 3x and minus 1 1, and also here minus, and here I will get what, x cube divided by 3, because the exponent of it will be summed by 1 and the same will be divided with it over it, and here minus 1 1, and it should be 1. Okay, now putting the values of these limits, what I will get, let me put these values, and here I will get 3 and 1 minus minus 1, so here I will get 3 1 plus 1, and here minus 1 by 3, and here what, here I will get 1 plus 1. Okay, and it must be equal to 1. Let me do it again here, and it will be 3 to 6. Okay, and minus what it will be, it will be 2 by 3. Okay, so it will be 2 by 3, and it must be equal to 1. Let me simplify it further, and it will be 18 18 minus 2 is 16, so 16 divided by 3, and this is equal to 1, and ultimately it will give me the value of k, which is 3 by 16, and that is the answer of part A of my question, that the value of k is 3 by 16. Okay, so we have done part A of our question. In part B of it, we have to find the probability that a random error in measurement is less than 1 by 2. Okay, so to do so, what do we have to do here? In order to find it out, first of all, we have to find the CDF of it. Okay, so in order to do so, in order to find the CDF of it, what I have to do, I have to take this f of x, I have to find it out, and here I have to take the values from the lower up to certain value, which is x. Okay, and I have to change the domain of my function here as well, and in order to do so, I will change it from x to t. Okay, so the value of k is already known, that is 3 by 16. So 3 by 16, and the value, other values are 3 minus t square, and integrated with respect to t. Okay, so here we have it, and integrating it, what I will get, let me try it here as well. So it will be 3 by 16, and here separately integrating each one, here this will be minus 1x 3 dx, sorry, dt, and here minus 1 to x, and here t square dt, and here we have it. Okay, so now let me simplify them. I will get here 3 by 16, and here I will have 3t minus 1 to x, and minus t cube by 3, and here minus 1 x. Okay, so simplifying it, and at the end what I will get here, I will get 3 by 16 3 x plus 1. Okay, because x and minus 1 will be plus 1, and similarly here minus 1 by 3, and here this will be x cube, and minus minus this will be plus 1. Okay, so ultimately what I will get here, ultimately the answer of it will be what, it will be 1 by 16. Okay, and here it will be minus x cube plus 9x and minus 8. Okay, that is what, that is f of x, and that is basically the cumulative function which I had to find out here. Okay, so in order to find the probability that a random error in measurement is less than 1 by 2, what do we have to do here? I have to find the probability that the random error x is less than 1 by 2, and this is what, this is the f 1 by 2. Okay, so let me put their values here in this f of x. What I will get, it will be 1 by 16 and minus 1 by 2 cube, okay, plus 9, 1 by 2 and minus 8. Okay, so here we have it, and ultimately the answer of it, what I will get is 99 divided by 128. This is the answer of part B of my question. Okay, so you have seen that I have found out f of x, and on the basis of it I have found the answer of it. Now part C of my question is, for this particular measurement, it is undesirable if the magnitude of the error x, absolute value of x, exceeds 0.8. What is the probability that this occurs, that x exceeds 0.8? So what do we have to do here? I have to find, this is part C of my question, and here I have to find the probability that x absolute exceeds 0.8. Okay, so this exceed is basically what? This is basically the probability that x is less than minus 0.8, okay, or the probability that x is greater than 0.8. I have to encounter both of these cases, and then accumulating it will give me the answer which is required here. So in order to find it out which is less than this one, I can write here very easily by using the CDF, and it will be minus 0.8. While for this one I have to see that this one is what, this is the greater one, so I can find it out by probability of x less than 0.8. okay, so let me put their values here. So it will be what, 1 plus 1 minus f of 0.8. okay, now putting these values into what, taking it and then putting the value 0 minus 0.8 here, and then taking this one and putting 0.8 here, what I will get ultimately, the answer of it will be 0.164, and that is what, that is the solution of part C of my question. Okay, so that's it for today, in which we have seen the solution of question 3.30. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.31 of chapter 3. Based on extensive testing, it is determined by the manufacturer of a washing machine that the time y in years, okay, so in years the time has been represented as y, before a major repair is required, is characterized by the probability density function, which is given by f of y, and that is 1 by 4 exponential of minus y by 4 for all the values of y which are greater or equal to 0 and 0 elsewhere. Okay, so what do I have to find out? On the basis of this probability density function, I have to find out the answer of two parts, and the first part of it is, a, critics would certainly consider the product a bargain if it is unlikely to require a major repair before the 6th year. Comment on this by determining probability of y greater than 6. Okay, so what do I have to find out? I have to find out the probability that a major repair will also be required after the 6th year, because during this time it will need a major bargaining. Okay, so therefore what I have to do, let me write here the solution. Okay, and in solving it, what do I have to do? I have to find out the probability that y is greater than 6, and now let me find the f of y, which is the CDF for this one, because this is now the PDF and its CDF would be f of y.
Okay, so now in order to do so, let me find it out, and here in order to find it out, we have to find the CDF for it for all the values greater than 0, and for that let me use the same function here. Here I am already writing the constant outside of my integral, and here writing it from the lower value up to some arbitrary value, let me take it y, and changing the domain of my function from y to t, okay, as we have been doing previously. So exponential of minus t by 4 and here d of t. Okay, so now integrating it, what I will get here, I will get 1 by 4 multiplied by exponential of minus t by 4 divided by minus 1 by 4. Okay, so these two will cancel out, and here the ranges of it will be from 0 to y. Okay, so now let me write them here, and here it would be minus exponential of minus t over 4, and it will be from 0 to y. Now writing these ranges, what I will get, first writing the higher range here, what I will get, minus exponential of minus y by 4, okay, and then this range which is 0, so minus exponential of minus 0 by 4. Okay, so now after it I will get what, it will be minus y by 4, and here exponential of 0 is 1, so here I will get minus 1. Okay, or ultimately from it the f of y will be what, rearranging it, this minus will be plus, so I will get here 1 minus exponential of minus y over 4, and that is the CDF of the required function. So now taking it and putting it here, by putting the value of y equal to 6, what I will get here. So in order to find the value of the probability of y greater than 6, what I can write? I can write here 1 minus f of 6, okay, because these will be the higher values, and for them I have to subtract the lower values from 1, so that's what I will get. So I will have here 1 minus, here the value of f of 6 would be 1 minus exponential of minus 6 by 4. Okay, so opening this bracket, these two will cancel out, and ultimately I will get exponential of minus 6 by 4, which will be 0.2231. Okay, so that is what, that is the answer of part A of my question, which is around 22.31%, which is not low. Okay, so here I have to consider this value as well, because this is the 22% and which is not low. Okay, so now going to part B of my question, what is the probability that a major repair occurs in the first year? Okay, so here in order to do so, let me move down somehow, and here in order to solve part B of my question, the probability that the year will be less than or equal to 1, and this is what, this would be the f of 1. Okay, so now in order to do so, taking the same function and writing the value of y equal to 1, what I will get, 1 minus exponential of minus 1 divided by 4. Okay, and from it what I will get here, from it I will get 0.2212, which is basically the solution of part B of my question, and this value is not also lower, and this is also around 22.12%, and this is also a very major constraint in the product, because it will also require the major repair within the first year, and the probability of it is around 22%. Okay, so that's it for today, in which we have seen the usability of CDF in the product lifetime and how can we use it for the product lifespan. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.32, and the statement of it is
the proportion of the budget for a certain type of industrial company that is allotted to environmental and pollution control is coming under scrutiny. A data collection project determines that the distribution of these proportions is given by f of y, which is 5 1 minus y raised to the power 4 for the range of 0 to 1 and 0 elsewhere. Okay, so what do we have to do? We have to verify and answer some parts of it which are given in the form of A, B and C. So let us start part A of it, and this is the solution of it. And in solving it, the part A of it is verify that the above is a valid density function. And in order to verify that this is a valid density function, what do we have to do? We must check that whether this converges to 1 or not. Okay, so what do we have to do? I have to integrate it within this range. Okay, so if the answer of it is 1, so which will show me that it is a valid density function. So let me first write it, and it will be from 0 to 1 due to the ranges which are given here, and the function we have here is 5 1 minus 4 to the power 4, and I have to integrate it with respect to y. Okay, so now integrating it, what I will get here, this will be 5 0 1 1 minus y here 4 dy. Okay, so let me integrate it, and integrating it, what I will get here, I will get it will be 5, and here we will get minus 1 minus y, and here this exponent will be 5 divided by 5, and here the range will be 0 to 1, and here it is. We have why this negative, because we can very easily see that here this y has a negative sign, so integrating it over this one will give me output as minus y as well. So now here these two will cancel out, and integrating it and now putting these values here, what I will get here, I will get minus, so 1 minus y. So now writing the higher range first, so higher range is 1 1 minus 1 5, and then here minus, and this lower range is 1 minus 0. Okay, and this 5. So what will happen? This will become 0. Okay, and this will become 1. So ultimately what I will get here, I will get minus, and this is 0 minus 1. Okay, so which will ultimately give me 1, which shows the validity that this one is basically a valid density function. Okay, so that's what we have, and here we have seen that this is the density function which we had, and integrating it in the range where I had minus 1 minus y whole 5, and it was from 0 to 1. Why I had written it here now again? Because I will use it in more cases in our upcoming parts. Okay, so now this is part A. In order to proceed to part B of it, what is the probability that a company chosen at random expends less than 10% of its budget on environmental and pollution controls? Okay, so now this 10% is basically how much? This is basically 0.1. Okay, this 10% is basically 0.1. So I will have a range which is less than the 0.1. So therefore integrating this f of y from 0 to 0.1, which is the higher range, and here writing this f of y dy, this will be what? This will be the probability that the expenditure will be less than what? 0.1. Okay, so now I have to find it out, and previously we have seen that in order to integrate it in the range from 0 to 1, what I have got? I have got this formula, and writing the same formula in the range of 0 and 1, what I can write here? I can write here minus 1 minus y 5, and the ranges here are 0 and 0.1. Okay, so now putting these values here, what I will get here, this minus remains the same, and now writing the higher range, this is 1 minus 0.15, okay, and also here this minus and 1 minus 0.5, okay. Now simplifying it, what I will get here, it will be minus, and here we will have what? Here we will have 0.9 to the power 5, and here we will have minus 1, okay, or I can also write it like 1 minus 0.9 raised to the power 5, okay. Now finding it out and finding the answer of it, what I will get here, the answer of it will be 0.4095, and that is basically the solution of part B of my question. Okay, so that is the solution of part B. Now moving to the part C of my question, what is the probability that a company selected at random spends more than 50% of its budget on environmental and pollution control? So here the case is slightly different, and here the case is in which I have to select the budget which is 50% or more than it. So here in order to write it, this 50% is the lower range, which is 0.5, okay. So now taking this as a lower range and the maximum range here is 1, and now again taking the same f of y dy, and it will be what? It will be the probability that expenditure is greater than 0.5, okay. So this is what we have to find it out. Now putting the same equation here by using the different ranges which are here now. So now here I will have minus 1 minus y, okay, and this is 5, and the lower range here is 0.5, the higher range is 1, okay. Let me simplify it more, and simplifying it some more, what I will get here, it will be minus, and here the higher range is 1 minus 1 5 minus 1 minus 0.55, okay. So that is what we have. Now simplifying it, what I will have, this will be 0, and this will be 1 minus 0.5 is 0.5 raised to the power 5, okay, and here the answer of it will be 0.03125, which is around 3%, which is slightly smaller than all the previous probabilities, okay. So this is what we have found out, and that is the solution of part C of my question. So today we have solved the question 3.32 of our book. So if you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.35 of chapter 3, and the statement of it is, suppose it is known from large amounts of historical data that X, the number of cars that arrive at a specific intersection during a 20-second time period, is characterized by the following discrete probability function, which is given by f of x, okay, and this formula, which is a very well known probability distribution function, which we will discuss in our upcoming videos, okay. So that is basically characterized by this formula, and on the basis of it we have to solve two parts of this questions, which are A and B, okay. So in part A of it, find the probability that in a specific 20-second time period more than 8 cars arrive at the intersection, okay. So this is very interesting part of this question, in which we have to see that what is the probability that more than 8 cars arrive at the intersection. So what is meant by more than 8 cars? It can be 9, 10, 11, 12, 100 and so on as well. So what do I have to find out? I want to find out the probability that the number of cars are greater than 8, okay. So this is what, this is part A, and how can we do it? This can, you can very easily see that it can be a data which cannot be counted, okay, innumerable
data counts we will have, because more than 8 means all the data points which are greater than 8 are more than 8. So in order to limit ourselves within this range, I can use another trick here, and that is a trick which is there. We have 1 minus probability that x is less than or equal to 8. Okay. So how can I find it out? In the context of the probability, we have known that the total or the overall probability that x is less than or equal to 8 plus the probability that x is greater than 8, this is the overall probabilities, and according to the probability theorems it must be equal to 1. Okay. So the summation of all the probabilities must give us 1, and from it we can very clearly get this formula. Okay. Now solving the same probability function and the same part of our question, what we can do here, the probability that x is less than or equal to 8, we can find it out by 1 minus the probability that the number of cars are 0, okay, plus the probability that the number of cars we have are equal to 1, plus the probability that the number of cars we have equal to 2, and we will add them together until and unless we have the probability that x is equal to 8. Okay. So that is what we will have here. In order to counter it in the context of the mathematics, what I can do here is that if the probability that x is greater than 8, I can use the summation or the sigma function in which this summation in which x is equal to 0 up to 8. Okay. And here we will have this probability that x is equal to the smaller x. Okay. So we can use this formula. Now we have this formula for this p of x, and that is given here in this form. So now writing it here, what I will get, I will have here 1 minus x equal to 0 up to 8. Okay. And writing this formula, because here luckily we have the same variable which we have here, so we will have here exponential of minus 6, and here 6 raised power x divided by x factorial. Okay. So now let me open the braces here and let me do it here as well. So here doing it, what I will get, 1 minus this exponential minus 6 is a constant value, so leaving it outside this, and here let me have it here from 0, 6 raised power 0 divided by 0 factorial plus 6 1 divided by 1 factorial, okay, plus 6 square divided by 2 factorial plus 6 cube divided by 3 factorial, okay, unless and until we will add them together up to 8, because this is x is equal to 8 and these are values from 0 to 8. So here I will have 8 factorial. Okay. So this is what we have. So now finding them all together and then subtracting it from 1, what I will get? So I will get here 0.1528. Okay. And that is basically the answer of part A of my question. Okay. So that is the solution of part A. Now in order to proceed, we have to see that find the probability that only 2 cars arrive. Okay. So that is part B, and we have to find the probability that x is equal to 2. Okay. Only 2 cars arrive, and we can very clearly see that, let me move upward somehow, we can very clearly see here that this is the single occasion here where x is equal to 2, and this is a single case. In order to counter it out, what we can do, we can use the same formula here in which the value of x is now 2. Okay. So now putting values here, this would be minus 6 and 6 with the power of this x which is 2. So this is 6 square divided by x factorial which is 2 factorial. Okay. So now finding it out, what I will get here, we will get 0.0446. Okay. And that is what, that is basically the answer of part B of my question. Okay, so that's it for today, in which we have seen the solution of the questions like the number of cars following through a certain point in a certain limit of time. Okay, so these type of problems are usually solved by the Poisson probability distribution, which we will discuss in our upcoming videos. So till then, take care of yourself. If you have any question, you can ask me in the comment box. See you soon.
Hello guys, I hope all of you will be fine. So this is question 3.36 of chapter 3, and the statement of this question is, on a laboratory assignment, if the equipment is working, the density function of the observed outcome x is f of x, which is 2 1 minus x for the range of x greater than 0 and less than 1, and it is 0 otherwise. Okay, so what do we have to do? On the basis of it, we have to answer certain parts of it. So let me look at the first part of this question, and this is calculation of the probability that x is less than or equal to 1 by 3. Okay, so by looking at it, I can very easily see that if I will find the CDF for my function here or for my density function here, I can very easily find out this thing. Okay, so let me first find the CDF for my function here, and in order to find the CDF of it, I know that what I have to do, this would be f of x. Okay, that is capital F of x, and what I have to do, I have to take the lowest limit of my function and taking any arbitrary variable here and taking that arbitrary variable as x, because here this x should correspond with this one as well. Okay, so now taking it and now putting my function here by changing the domain of it. Okay, so let me change the domain of it from x to t. So what I will get here, it will be 2 1 minus t, and now integrating it with respect to t. Okay, so now doing the same procedure as well. So 2 will be outside, and here we will have 0 x, okay, 1 minus t and dt. Okay, so now doing again 2, and here it will be 0 x 1 dt. Okay, and also minus 0 x here t and dt. Okay, now integrating them separately and then putting the limits here, what I will get here, I will have here it will be t and 0 x, and while here I will have t square divided by 2 and 0 to x. Okay, putting these limits here, what I will get here, I will get 2, okay, and x minus 0 is x. Similarly here minus 1 by 2, and here I will have x square minus 0 square, so here I will have x square. Okay, so ultimately I will get this one. Okay, so now moving somehow downwards, what I will get, multiplying this 2 inside of it, what I will get, I will have here 2x minus x square. Okay, so this is what, this is the CDF of my function which I have here. Okay, so this is the CDF. In order to simplify it somehow more, what I can do here is that let me add and subtract 1 here. So adding and subtracting 1 here, what I will have, this is f of x, and here I will have minus x square plus 2x. Okay, and here let me subtract 1 and add 1 with it as well. Okay, so now here I will have this function. Now here I can very easily see that this is a function which is the factorization of x minus 1. If I will take this negative sign common here, so here I will have this minus, and here x square minus 2x plus 1. Okay, and here the remaining thing will be plus 1. Okay, so now combining it, and here I will get x minus 1 whole square, and here minus, and here plus 1, or the value of f of x is what, that is 1 minus x minus 1 whole square, and that is what, that is the CDF of my function as well. Okay, so you can use both of them. that is basically the simplified form, because in many books the answer has been written in this form. So in order to do them all is not to confuse them with anything, so that's why I have solved it as well. Okay, so now looking at part A of my question, I have to find the probability that x is less than or equal to 1 by 3, and that is very easily found out by putting f 1 by 3. Okay, so now putting the values here, this is f of x, so putting values here, 1 minus x value is 1 by 3 minus 1. Okay, so here it would be 1 minus, this would be minus 2 by 3 whole square. Okay, or 1 minus 4 by 9, or the answer of it will be 5 by 9, and that is what, that is the answer of part A of my question. Okay, you have seen that how easy it is to find the probabilities if I know the CDF of my function. Now similarly, what is the probability that x will exceed 0.5? Okay, so that is the probability that x will be greater than 0.5, and this can be found out very easily if I will make it like probability that x is less than or equal to 0.5. Okay, so this is basically the CDF. I can find it out by using the CDF, which would be what, f of 0.5. Okay, putting all the values here, this is f of x, so it will be 1 minus, here the value is 1 minus 0.5 minus 1 whole square. Okay, so here you can see that, let me move down somehow. Here you can see that by opening the braces, what I will get here, it will be plus 0.5 minus 1 is minus 0.5 whole square. Okay, these two will cancel out, and here the answer of it will be 0.25. Okay, because the square of it will remove this minus sign, and that is basically 1 by 4. So the answer of part B is 1 by 4. Okay, so that is the solution of part B of my question. Now in order to solve part C of my question, here I can see that given that x is greater or equal to 0.5, what is the probability that x will be less than 0.5? Okay, so for it, let me move down again. Okay, so here that is basically the conditional probability, in which I have to find out the probability that x is less than 0.75 given that x is greater or equal to 0.5. Okay, so that is what I have to find out. This is the conditional probability in which this thing has been given, and I have also find it out by using this function here, because previously I have already seen that what was this one. This was basically the probability that x is less than or equal to 0.5, and subtracting it from 1, I have got probability that x is greater than 0.5. So equivalent is also covered by this one, because this is the continuous probability function, and therefore this is the same thing. Okay, so now proceeding towards this one, what I can use here, I can use here the conditional probability, and here in order to do so, I will have these two function, and here I will have x is less than 0.75. Okay, and the union of probability that x is greater or equal to 0.5. Okay, and dividing it over what, here dividing it over the given probability, which is probability that x is greater or equal to 0.5. Okay, so I hope this point is now clear. If you have put them together, and that is basically the union. So what is mean by union? Union means it has been combining these two ranges. Okay, so this range and this range, these two ranges has been combined, and therefore these ranges are from 0.5 to 0.75. So therefore in combining them, what I can write here, I can write here the probability that x is greater or equal to 0.5 and less than 0.75. Okay, that is what, that is basically the limit or the limits of this probability, and dividing it over the probability that x is greater or equal to 0.5. Okay, I know I have already known the value of this one, so let me solve the other one as well. So now finding the limits here, I can very easily find this limit by using the CDF, and it would be what? It would be the f 0.75 minus f of 0.5, okay, and dividing it over the probability that x is greater or equal to 0.5. okay. So now here we can very easily see that these are the limits. And why did I do it? Because if I have a function here, okay, let me see that this is the CDF and this is a x, and in order to plot them here, what I can see, if I have here this one 0.5 and this one is 0.75. so in order to find this area here, what I can do, I can subtract this area from this one. Okay, so this is what, this is 0.75 and this is f of 0.5. so subtracting from this one, this I will get this area, okay, which let me identify in this blue color. Okay, so this blue color is basically showing me these ranges. Okay, so I hope you have found out my point. Okay, so now putting values here in the formula for f of x, what I had here, this is the formula which I had, so 1 minus x minus 1 whole square. So let me put these values here, and what I will get here, I will have 1 minus x minus 1, so 0.75 minus 1 whole square. Okay, so this is for this one, and now for the other one I will have, this is minus, and I will have 1 minus 0.5 minus 1 whole square. Okay, so I will have this one, and dividing it over what here, I will have, this was already found out, and that is 1 by 4. Okay, so now let me solve them together. 1 minus 0.75 minus 1 is minus 0.25 whole square, and also here minus 1 and plus here 0.5 minus 1 is minus 0.5 whole square. Okay, and dividing it over 1 by 4. Okay, so these two will cancel out, and at the end I will have here, this minus minus will be plus, this minus minus will be plus, 0.5 whole square minus 0.25 whole square divided by 1 by 4, and that is 0.25. Okay, solving it out, what I will get here, ultimately I will get 0.75. okay, so which is basically 3 by 4. Okay, so the answer of part C of my question is 3 by 4, but the only thing here you have to remember is this formula, that how we found out this formula, and that is due to the conventional formula of the conditional probability. Okay, so that's it for today, in which we have seen some important points related to the conditional probability and the usage of the CDF. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.37 of chapter 3, and the statement of this question is, determine the values of C so that the following function represent joint probability distribution. Okay, so you have to keep in your mind that joint probability distribution basically takes two variables, and that is basically the joint probability distribution of the two variables. Okay, so of the random variables x and y. So you can see here that here we have been mentioning two variables which are capital X and capital Y. Okay, so on the basis of it, we have to solve two parts of our question, and the part A of our question is fxy is equal to cxy for x equal to 1 2 3 and y equal to 1 2 3 as well. Okay, so let me solve the part A first. Okay, this is the solution, and part A is what? That is fxy is equal to cxy for x equal to 1 2 3 and y equal to 1 2 3. And if this is a valid joint probability distribution, we have to keep in our mind that all the values here, when summed together, it will give me what? It will give me 1. Okay, so what will happen here? This will be summed with respect to x and also will be summed with respect to y, and when this function will be summed together, it will give me 1. Okay, you have to keep in your mind if this is a valid joint distribution function, and it as it is given, so that is basically the joint distribution function which is valid. Okay, so we have to use this condition here, and all the values given for x and y are here. These are 1 2 3 and 1 2 3 as well. So we have to take each value of x and multiply it with the other value of y similarly, then add them together because of the additions here, and similarly for the other values of y as well. So let me do it here as well, and here taking this c out of here, what will we get? Because c is a constant, what will we get? So taking all values of x which are here 1, so let me use this 1, multiply it with the all values of y which are also here, so 1 multiplied by 1. Okay, similarly plus 1 multiplied by 2, this is the value of x multiplied by the value of y, plus because these are summed together here, and also 1 multiplied by 3, this is for the first value which is 1 for x and all the values of y. Similarly, now taking the second value of x which is 2 and multiplying it with all the values of y which are 2 multiplied by 1, and then the second value 2 multiplied by 2. Okay, and the third, that is 2 multiplied by 3. Okay, and now the last one here is 3, so taking this 3 multiplied by 1 plus 3 multiplied by 2 plus 3 multiplied by 3. Okay, so here it is, and it is here as well, and that is equal to 1. Okay, now taking all these values, as these have been added together, so let me take them and multiply and add them. So 1 is 1, this is 2, this is 3. Okay, now here this is plus 2, this is plus 4. Okay, this is plus 6. Okay, this is now 3, this is 6, and this is 9, and that is equal to 1. Okay, so now in order to find the value of c, let me add them together. So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 2 is 8, 8 plus 10 is 18, 18 plus 3 is 21, 6 27, 21 27, and 9 is 36. Okay, so now we have here this equal to 36, so 36 multiplied by c equal to 1, and taking this c equal to what? This would be 1 over 36, and that is the value of the c here which we wanted to find out. Okay, so that is the solution of part A of our question, in which we have determined the value of c here. Okay, so now moving towards part B of our question, here we can see that this is basically a joint probability distribution function for all the values of x and y which are here, and taking the same steps here, this is for x, this is for y, and the function we have here is x minus y, that must be equal to 1 in case of the joint probability distribution function. We can see here that all the values of x or y are given here. Now taking this first value of x and making it the combination with all the values of y and so on so forth, because we have here all these values and then also adding them together as well. Okay, so let us start here. So c will be moved out of these operations because this is a constant, and here if x is 1, so it will be, sorry, if x is -2, so it will be what, -2, and the other one is minus, so -2 will be what, this will be +2. Okay, so here we will have it plus, the second one is -2 and this one is 3, so -2, and here we will have it -3. Okay, similarly now we have the second value here of x, that is 0, so 0 plus 2 here we will have. Okay, because minus minus is plus, and also the 0 0 minus 3. Okay, similarly, sorry, that is also the addition. Similarly, the last one here is 2 minus 2 is 2 plus 2. Okay, and also here we will have 2 minus 3, we will have it. Okay, so these are all the values which are we have, and these are equal to 1. Let them all together and get the values which we have. So -2 plus 2 is 0, and the absolute value of it is also 0, because this absolute is basically giving me the positive values of all or whatever we have inside of these absolute signs. Okay, so now here -2 -3, this is -5, which is basically 5. Okay, and this is now 2. Okay, this will be +3. Okay, this will be +4, and the last one here is will be +1, that is equal to 1. Okay, so now then adding them together, 5 plus 5 is 10, and this 5 is 15, so 15 multiplied by c, that is equal to 1, which will ultimately give me what, the value of c will be equal to 1 over 15. Okay, so that is what, that is the solution of part B of our question. Okay, so that's it for today, in which we have seen the progression of the joint probability distributions. What are the joint probability distributions, and how can we find out different values out of them if the condition of the joint probability distribution has to be satisfied. So that's it for today. See you soon. Welcome guys, I hope all of you will be fine. So this is question 3.38 of chapter 3, and the statement of it is, if the joint probability distribution of x and y is given by f of xy is equal to x plus y divided by 30 for the values of x which ranges from 0 to 3 and for y which ranges from 0 to 2. Okay, so on the basis of it we have to find some probabilities which are basically the joint probabilities. So before going into each part of this question, let us first draw a table for the values which are given here. So in order to do so, let me write here different values for x and y. Okay, let me have here, this is, let me call it x, and here we have y. Okay, so writing all values of x and y, what we will have, let me use this color. For x I have 0 1 2 and 3, so it is 0 1 2 and 3. Okay, these are the values for x, and for y we have what, 0 1 2, so we have here 0 1 and 2. Okay, so these are different values of x and y. Now on the basis of the formula, which is x plus y divided by 30, what we can find out, we can write these values of x and y in this, and we can write their values. Okay, so here the value of f00 will be what, writing the value of x 0 y 0, what I will get, 0 plus 0 divided by 30, so it will be what, it will be, let me use another color for it, and this is this one. Okay, so 0 0, this will be 0. Okay, similarly 0 plus 1 divided by 30, this will be 1 by 30. Okay, and here 0 plus 2 divided by 30, this would be 2 divided by 30. Okay, so these are all the values for x equal to 0, while all the values for y, which are 0, 1, 2. Similarly, for x equal to 1 and y equal to 0, this would be 1 plus 0 divided by 30. So this would be 1 by 30. Similarly, here it will be 2 by 30. Okay, and here we will have 3 by 30. Okay, you know why? Because putting value of x here, okay, which are on the vertical axis and on the horizontal, we have the values of y. Putting it here and using this formula, we can find out these probabilities. Okay, similarly, here we will have 2 by 30, okay, 3 by 30, and here we will have 4 by 30 for this x equal to 2, and for x equal to 3 we will have 3 by 30, 4 by 30, okay, and here we will have 5 by 30. Okay, so these are different values of the formula f, x and y for all the values of x and y. Okay, so now on the basis of it, we are asked to find out some probabilities, which are probability of x is less than or equal to 2, such that y is equal to 1. So this is part A, and in part A we have to find out the value of x is less than or equal to 2 and y is equal to 1. Okay, so here let me see that where is it that y is equal to 1. So this is here, this is the overall column where y is equal to 1. Okay, similarly on the basis of it, we have to see another condition here, and that is x is less than or equal to 2. So it will start from where? These will be from here. Okay, you can see that it will be from here to here. So these would all be the values where x is less than or equal to 2. Okay, we can see that this is the range. So 1 by 30, 2 by 30, 3 by 30. Okay, so these are all the values. So let me write them here. Okay, so here I will have 1 by 30 plus 2 by 30 plus 3 by 30, and these are the values where we have f is where x is 0, okay, and y is 1. This value is f is x is 1 and y is 1, and for this value we can see that here x is what? X is 2 while y is 1. Okay, so we can see that these conditions has been fulfilled here. So using it here, the LCM, this would be 30, and here it would be 1 plus 2 plus 3. Okay, so 6 by 30 or 1 by 5. Okay, so that is what? That is the answer of part A of our question. Okay, so this is the answer of part A. Now moving towards part B of our question, which is what? Probability that x is greater than 2, okay, and y is less than or equal to 1. Okay, so this is another condition. Now let me see that where this condition occurs. So y is less than or equal to 1. So these are basically all these values which we have here. These are for the values that y is less than or equal to 1. So now looking at another condition here, and that is x is greater than 2. So x is greater than 2 is 3. So therefore only this condition will satisfy, because here y is less than or equal to 1, and here we have x is greater than 2, which is 3. So now these condition will be satisfied. Okay, so writing these values here, now let me write these values here. So I will get here 3 by 30 plus 4 by 30, because these are the values we have here, and here ultimately we will get 7 by 30, which is basically the answer of part B of my question. Okay, so this is part B. Now moving to part C of my question, let me solve it here, and that is probability that x is greater than y. Okay, so now let me write all the combinations where the value of x is greater than y. So it will be f
1 0. Okay, similarly we can have here f 2 0, okay, and f 2 1. This is again the condition where the value of x is greater than y. Similarly the other one is f 3 1, okay, sorry, f 3 0 plus f 3 1 plus f 3 2. Okay, so now looking at all these values which are here, so f10 is how much? That is 1 by 30. Okay, it would be 1 by 30. Similarly f20 is how much? F20 is 2 by 30. It would be 2 by 30. f21 is 3 by 30. Okay, f30 is again 3 by 30. Okay, f31 is 4 by 30, and the last one is f32, which is 5 by 30. Okay, adding them all together, and ultimately we will get what it would be 18 by 30. Okay, we can see that 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 8 is 18. So here we will get 3 by 5, which is the answer of part C of my question. Okay, so this is the answer of part C of my question. Now moving somehow downwards and looking at the solution of part D of my question. And what is part D? We have to find out the probability that x plus y is equal to 4. Okay, so here in order to see that where does this x and y is equal to 4, let me again write the function where x and y are equal to 4, and here we can have here this 2 2, okay, and also this plus is for or, and also we can have here 3 1. Okay, so these are the only two possibilities here where x and y when added together will give me 4. Okay, so now writing their values, I will get here this is 4 by 30, f22 is, okay, you can see that this is 4 by 30, and also f31, which is here, sorry, which is here, and that is again 4 by 30. Okay, so it will be 8 by 30, which will ultimately give me 4 by 15, and that is basically the solution of part D of my question. Okay, so that's it for today, in which we have seen the solution of question 3.38 and all the parts of this question. If you have any question, you can ask me in the comment box, because all of these things are related to the two variables, and that is the joint probability distribution function. So if you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.39, and the statement of it is, from a sack of fruit containing 3 oranges, 2 apples and 3 bananas, a random sample of 4 pieces of fruit is selected. Okay, so in the given data we can write here that we have here 3 oranges. Okay, the number of oranges are 3, 2 apples, okay, and also 3 bananas. Okay, so from them I have to select what? I have to select 4 pieces of fruit randomly. If x is the number of oranges, so oranges are represented with x, and y is the number of apple, so this is y, this is x. Okay, so what do we have to do? We have to find the joint probability distribution of x and y, which is part A of our question. Okay, so this is what from them I have to select 4 pieces of fruit randomly. Okay, so the part A of our question is here. Okay, and we can see very clearly here that we have the total number of fruits here. The total number of items of fruits are 8, which are 3 plus 2 plus 3, which are 8, and from 8 I have to select 4. So the total selections are basically from 8 I have to select 4. Okay, when I will do it like 8 factorial divided by 8 minus 4, that is 4 factorial, and then 4 factorial, this would be 70. Okay, so I have to select 70 item, and these are the total 70 selections which can be carried out in total. Okay, so in order to find the joint probability distribution of x and y, initially we have the 3 oranges, and out of 3 oranges I have to select, let me have here small x, and I have to select x items. Okay, similarly, if I have the apples which are basically 2 in number, and I have to select y number of items from them. Okay, and the remaining items are banana. Okay, so the number of banana here are 3, and from them I have to select how much those would be the remaining one from the 4, because the total number of items here would be 4. So therefore I have to see that how many x and y are, and the remaining items which are out of 4 I have to select them. Okay, so these would be the selected items which will comply with the condition of our question. Okay, so I hope you have understood, and dividing it over the total number of selections which have been already calculated, and these are 70. Okay, so these are what? These would be f of x y. Okay, and this is what, this is the joint probability distribution for part A of our question. Okay, so here also what can be the values of x and y? So the values of x can be, small x can be, these are the total number of oranges, so it can be no orange, or 1 orange, 2 orange, or 3 oranges. Okay, similarly y is how much? That can be 0, 1, or 2. Okay, and also the total number of items here can be greater or equal to 1 and less than or equal to 4. So this is basically the condition for the formula which we have derived here, and that is what we have found out here for the joint probability distribution of our part A. Okay, similarly in part B we are asked that if P of x y is a member of A, where A is the region that is given by x y such that x plus y is less than or equal to 2. Okay, so here in part B we have to see that what are the items for which we have to find the probability of x y such that x plus y is less than or equal to 2. Okay, so which items can it be? So those can be found out from this formula, and these can be here, either it can be 0, 1, and we can see that 0 plus 1 is 1, which is less than 2. Okay, also it can be plus f 0, 2, so 0 plus 2 is also less than or equal to 2, which lies in between this range. Okay, similarly f of 1 0, okay, plus f of 2 0, okay, and also f of 1 1. Okay, so these are some items which are the values of x and y which I have to put here, and after finding the values I can add them together. Here you should also note that I am not using here f of 0 0. Why? Because if I will add here f 0 0, so these two items will be 0 0, while this one only be selected, which cannot fulfill our requirement that the total items here should be 4. Okay, because the total number of items which are 3, and these are the 3 bananas, which will not satisfy the condition in part A. So that's why I'm not selecting this f of 0 0. Okay, so now finding the values of these items and then adding them together, what are those values? So let me first find out f of 0 1. So for f of 0 1, the formula here is this one. So let me move upward somehow. So this is the formula, and putting the values of x and y. So x is 0 here, okay, y is 1 here, and also it would be 3, x plus y is 1 and 4 minus 1 is 3. Okay, so it would be this one, and it will be what? It will be 70. Okay, so now finding them out, what I will get from here? I will get 1, from here I will get 2, and from here again I will get 1, and so ultimately it will be 70. So it will be 2 by 70. Okay, also if I will do it for f of 1 0, what it will be? It will be 3 1. Okay, it will be 2 0, and here it will be what? It will again be 3 3 divided by 70. Okay, so now finding them out, what I will get? It will be 3 factorial divided by 2 factorial into 1 factorial. So these two will cancel out, and at the end what I will get here? I will get 3. Okay, so 3 will be left here. From it I will get 1, and from it I will again get 1. So it will be 70. So I will have 3 by 70. Okay, also the other values are, let me find the other values, which are f11, f20, and f02. Okay, you can find them out just by putting these values into this formula. Okay, you can see by putting these values in this formula, and then ultimately you will use this formula for adding them all together, which are the values, just like f01 is here, f02 is here, and also this one is here as well. Adding them all together, and ultimately what you will get here, the answer of part B will be 1 by 2, and that is the solution of part B of our question. Okay, so that's it for today, in which we have seen that how to find the joint probability distribution of any items which are given to us. If you have any question regarding this exercise problem, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.41, and the statement of it is: a candy company distributes boxes of chocolate with a mixture of creams, toffees, and cordials. Suppose that the weight of each box is 1 kilogram, but the individual weights of the creams, toffees, and cordials vary from box to box. For a randomly selected box, let X and Y represent the weights of the creams and toffees respectively. Okay, so let me first write the given data, and in the given data we can write here that the weight of each box is 1 kilogram, that is understood, and also the creams and toffees have been represented with X and Y. Okay, so let me write here: creams weights are represented with X, and weights of toffees are represented with Y. Okay, so these are the two given things, and also the total weight, which includes creams, toffees, and cordials, are composed of a one box which is of 1 kg. Okay, so suppose that the joint density function of these variables is given by fxy, where 224xy is the density function which lies in between the ranges of x greater or equal to 0 and less than or equal to 1. The range of y is greater or equal to 0 and less than or equal to 1, and the combined weight of x and y can be less than or equal to 1. Okay, and it is 0 elsewhere. So on the basis of it, what do we have to do? We have to find the probability that in a given box the cordials account for more than half of the weight. Okay, so in solving the part A of our question, we have to find the probability that cordials are what? Their weight is more than 1 by 2 or half of the weight, so that is greater than 1 by 2. Okay. But here we can very easily see that the joint distribution or joint density function doesn't encounter the cordials. It is only including the weights of the creams and toffees. So therefore, if the weight of the cordials is greater than 1 by 2, so it means the combined weight of x and y will be
less than 1 by 2. So what I can do here is that I can here very clearly see that it will be x plus y will be less than or equal to 1 by 2. Okay, so it must be understood in this way. Okay, so it will be like this one. So now in order to find this probability, what do we have to do? We have to find the probability that x plus y will less than or equal to 1 by 2. So we can use here for this addition, we can very clearly see that this is a continuous function. So for it we can use the integration. Okay, so for integrating it we have to use different ranges of x and y. So if the y range is from 0 to 1 by 2, so the range of x would be from 0 to 1 by 2 minus the weight of a y. Okay, so this will be subtracted from 1 by 2. Okay, so now writing the function here, and that is 24 x y. Okay, and also integrating it with respect to x and integrating it with respect to y as well. Okay, because now we have been adding the two functions, so therefore I have to add them together by using the integration, which is for the continuous functions. Now here 0 to 1 by 2 and integrating it first with respect to x. Okay, this part. So what will we get here? We will get 24, and here this is with respect to x, so x square divided by 2, and here we will have y. Okay, and also it will be from 0 to 1 by 2 minus y, and integrating with y is left. Okay, so now it will be 12. Okay, and also putting these values, what I will get here, I will get 12 will be outside, and here it will be 0, 1 by 2, and putting these ranges here, I will get 1 by 2 minus y whole square. Okay, and also this y here, and then dy. Okay, so this is for this one. Okay, this is the function we have got. Now after it, using the integration by parts. Okay, so integration by parts for this one, for dy, at the end putting all the limits and all the values, what I will get at the end, the answer of it will be 1 over 16. You can use here integration by parts by yourself and see that the answer of it will be 1 by 16, and that is what, that is the solution of part A of my question. Okay, so I hope you have understood it. Now moving somehow downwards. Okay, and now seeing part B of my question. Okay, so what is part B? Find the marginal density for the weight of the creams. Okay, so weight of the creams are represented with x. Okay, we have seen that, and for it, let me find the marginal density for it, and let me represent it with g of x. Okay, so let me find it out, and finding it out, I have to define the limits for the function which is here. So it will be from 0 toward for any value which will be less than 1 kg, because if it will be composed of the cream, the other items will also be included. So those would, the weight of the cream will be subtracted from 1, which is the 1 kg. So therefore it will be from 0 to 1 minus x, the quantity of the creams subtracted from the 1 kg. Okay, so now writing here the values 24 x y, and now again integrating it with respect to dy. Okay, so now using it, and what I will get here, I will get 24x, and here this will become what, y square divided by 2, and here 0, 1 minus x. Okay, so now it will become 24, and this will become 12 here, so I will get here 12. Okay, and here 12x, and putting 1 minus x and 0 here, so ultimately I will get 1 minus x square, and that is for the marginal density for x, or weight of the cream. So that is what we have found out. This is the answer of part B of my question. So also the range of x will be here, what we have to define the range of x as well. So the range of x will be greater or equal to 0, and it will be restricted
less than 1 because all other items will also be included. So, I am not making it equal to 1. So, that is the solution of part B. Now, moving to the part C of my question, find the probability that the weight of the toffees in a box is less than 1 by 8 kg. Okay. So, let me first write the given data here. We have to find the probability that the weight of the toffees in a box is less than 1 by 8, and we have seen that the weight of the toffees were represented with what, that those were represented with y and creams were with x. So therefore the weight of y is less than 1 by 8 kgs. Okay, if it is known that creams constitute 3 by 4 of the weights, and given here is that creams which are x, these are of 3 by 4, we have to find it out. Okay, and we can very clearly see that this is the case of a conditional probability. Okay, because one probability has been given and on the basis of it we have to find the probability of another item, which is the case of the conditional probability. Now using it and finding it out, the formula we have already known for the conditional probability is the p x and y divided by the probability of x. Okay, y x, because here you can see that this probability is given, so this will be written here, and those two items has been included here as well. Okay, so we can see it here as well. Now writing their values, do we know the probability of x, y? Yes, this is the same thing which is already given in the question. We can see that this is what this is already given here in the question, which is 24xy. Okay, let me write it here, 24xy. Okay, and the probability of x, do we know it? Yes, that is also the marginal density which we have here, and that is 12x 1 minus x. So 12x 1 minus x square. Okay, so these two will cancel out, this will be 2, and ultimately I will get what? I will get 2y divided by 1 minus x whole square. Okay, so that is what, that is the formula for the conditional probability which is given here, and here we have to consider the ranges of x and y as well. So putting those values here. Okay, so putting the values of x and y here, because the value of x is already given, so putting this 3 by 4 here, what I will get here, the probability that y is less than 1 by 8 such that x is equal to 3 by 4. Okay, so here now putting the value of x, which is 3 by 4, so I will get 2y divided by 1 minus 3 by 4. Okay, so this will be squared. Okay, so I will get here 2y divided by 1 minus 3 by 4 is 1 by 4. So this will become 1 over 16, which will be 32y. Okay, so this is what, this is for the marginal density of this one. Okay, so this is for 32y, and now in order to find the value for that instance, what we have to do, we have to integrate our value from 0 to 1 by 8. Okay, so now integrating it from 0 to 1 by 8, because we are going to find the marginal density, so here it will become 32y dy. Okay, so now it will be 32 into y square divided by 2, and it will be from 0 to 1 by 8, and ultimately solving it, what I will get, I will get here 1 by 4. Okay, so the answer of this is 1 by 4, which we have already found out. Okay, so that is basically the solution of part C of my question, in which we have seen that how can we find out the conditional probabilities or conditional density function from any given data. Okay, so you have understood that after finding the conditional probability
formula from it, I have to integrate it in this range because no any restricted range has been defined, but this is the cumulative range, and for that I have to integrate it as well. Okay, therefore I had integrated in, and the formula given me the answer, which is 1 by 4. Okay, so that's it for today, in which we have seen the solution of question 3.41. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.42, and the statement of it is, let x and y denote the lengths of life in years of two components in an electronic system. Okay, if the joint density function of these variables is given by fxy, exponential of minus x plus y, for x greater than 0, 1 greater than 0, and 0 elsewhere, find the probability that the lifespan of x is greater than 0 and less than 1, given that the lifespan of the component y is equal to 2. Okay, so again this is another problem which corresponds with the conditional probability. Okay, so let me solve it, and in solving it, if you want to solve this one, what do I have to do here? The given function is here. So if I want to find out the probability of x given that y is equal to 2, what do we have to do here? We have this thing, and here in order to find it, we have to use the conditional probability. So in conditional probability, what do we have to do? We have to find the probability of x and y divided by the probability of y. Okay, we want to find these quantities here, and then putting it here, we will get the answer which is here. Okay, but here we have one thing, and that is this one. This is given and it is here. Okay, but we don't know about probability of y. Okay, so now in order to find this one, let me find it out here, and the probability of y would be equal to what? As we have previously found out, finding it out, we know the range of y. So in order to do so, integrating it and then finding the probability of y, we have to write here f x y, and integrating it with respect to what? With respect to x. Okay, also putting the limits here will give us the answer. Now let me write the value of xy. So integration, the value of xy is exponential of minus x plus y and dx. Okay, also putting the limit here, and the limit we already know is y is greater than 0, so 0 up to infinity. Okay, so let me integrate this one and find it out, and here also we can see that this is from 0 to infinity. Okay, and here it will also be minus x multiplied by minus y and d of x. Okay, so as we have been integrating it with respect to x, so this exponential of my will be treated as a constant. So putting it outside of this integral and then integrating this exponential of minus x, what I will get, it will be minus x divided by minus 1, and here we will have 0 to infinity. Okay, so here exponential minus exponential of minus y because of this negative sign, and here putting these limits, what I will get here, I will have exponential of minus infinity minus exponential of 0. So ultimately the answer of it I will get is exponential of minus y, and this is what this is for the probability of y. Okay, so as I have found it out, let me put these values here in this formula. Do I know the value of probability of x y? Yes, it is already known, and it is here exponential of minus x plus y, which can also be written as exponential of x plus y divided by this value. This is exponential of minus y. Okay, or exponential of minus x into exponential of minus y divided by exponential of minus y. Okay, these two will cancel out, and ultimately what I will get here, I will get exponential of minus x. Okay, so that is what, that is the answer of this question in which I want to find out the probability of x given that y is equal to 2, as y is already cancelled out here. Therefore, I am not going to write the value of y, so the answer of it will remain the same. Okay, so that is the answer of this one. But now you can see that I don't want to find out the value of x, but I want to find out the probability that it lies within this range. Okay, so now in order to find this value, what do I have to do? I have to take the same value, okay, which is this one, and to find out it within this range, what do I have to do? I have to integrate it within this range 0 to 1, okay, and then writing the value which is minus x and integrating it with respect to x, and it will give me what? It will give me the probability that x is greater than 0, less than 1, given that y is equal to 2. Okay, so let me integrate it, and finding the answer of it, what I will get here exponential of minus x, okay, this will be minus as well, and here 0 to 1. Okay, ultimately what I will get here, I will get 1 minus exponential of minus 1, which is 0.6321. Okay, so that is the answer of the question which we had here. Okay, so that is the probability that x is greater than 0 and less than 1, given that y is equal to 0, and that is already found out here. So that's it for today, in which we have seen the solution of question 3.42. If you have any question, you can ask me in the comment box. See you soon. Hello guys, I hope all of you will be fine. So this is question 3.43, and it is saying that let x denote the reaction time in seconds to a certain stimulus and y denote the temperature in Fahrenheit at which a certain reaction starts to take place. Suppose that two random variables x and y have the joint density function which is represented with fxy, which is 4xy for the x which ranges from 0 to 1, and for y which ranges from 0 to 1 as well. Okay, and it is 0 elsewhere. So on the basis of this data, what do I have to find out? I have to find out two parts of it. So let me start solving it, and in solving part A of our question, what is this? I have to find out the probability that x is greater or equal to 0 and less than or equal to 1 by 2, and y is greater or equal to 1 by 4 and less than or equal to 1 by 2. Okay, so how can we find it out? Let us find out. So probability of x greater or equal to 0 and less than or equal to 1 by 2, and also y greater or equal to 1 by 4. On the instead of and, I can also put here this comma. So therefore this will be y greater or equal to 1 by 4 and less than or equal to 1 by 2. How can we find out? So for each of them I can use certain integration. So for it I have to use the integration from 0 to 1 by 2, and for it I have to integrate the function from 1 by 4 to 1 by 2. Okay, so using these two integrations, what will happen here? I will have here, let me first write here the integral for y. So it is 1 by 4 to 1 by 2 and then x, okay, which is 0 to 1 by 2. Why did I write here y first and x second? Let me explain it to you as well. So the function here is 4xy. So 4xy is here, and after it I have to write which function. As you can see here very clearly that here I have written this x, so therefore I have to use here the integral with respect to first, and after it what is the integral? You can see that here this is 1 by 4, so therefore I have to put here d of y. Okay, so I have put here d of x second because I can very easily use this function. Okay, this will be easier for me to calculate, and then finding the limits here, it will give me the answer very easily, and after it I can use the integration for y. Okay, so let me solve it, and first finding the integration for x.
For that function, this 4 and y will become the constant. So here I will have 1 by 4, 1 by 2, and this 4 and y will be outside, and here I will have 0 to 1 by 2 x dx and dy. Okay, so let me move down somehow. Okay, so moving somehow downwards and writing here 1 by 4 to 1 by 2. Okay, and here we have 4y, and here this will become x square by 2 multiplied by x square divided by 2, and the limits of it are 0 to 1 by 2 and d of y. This will be here, and here I will have 1 by 4, 1 by 2, okay, and here 2x square, which is from 0 to 1 by 2, and here this y, okay, and dy. Putting these values here and then finding it out, what I will get here, it will become 1 by 4 minus 0. So it will become 1 by 4, 1 by 2, and here it will be 1 by 4 multiplied by 2. It will become what? It will become 1 by 2, and here we will have y. Okay, so this is what? This is the function I have to integrate later on. So now integrating this y with respect to y, what I will get here, this 1 by 2 is a constant, and integrating it with respect to this, what I will get here, I will have y square divided by 2, and limits are from 1 by 4 to 1 by 2. Okay, so this is what we have. Okay, so these two will become 1 by 4. So let me move down somehow as well. Okay, so it will become 1 by 4. Okay, and putting these limits here, what I will get, the higher limit is 1 by 2. So 1 by 2 square is 1 by 4 minus this 1 by 4 square, this is 1 by 16. Okay, so solving it, this will become 1 by 4, and here this is 16, and here it will be 4 minus 1. Okay, so ultimately I will get 3 over 64, which is the answer of part A of my question. Okay, this is the solution of part A of my question. You have seen that how to find it out, and the essence of this basically lies in this formula which we had here. Okay, we had used it and we have found it out. Now on the basis of it, the part B is to find the probability that x is less than y. Okay, so the probability that x is less than y. So in using formula for this one, what do I have to do? We can see that y can have any value, while the value of x will be dependent upon this y. Okay, so let me first write the integration for y, and that can have any values from 0 to 1, because this is the range of y. Okay, this can have any value, and this is for this one, and here it will be dy. Let me have this value. Now after it, when it will get any value out of this one, the y should be dependent upon it, and it will get all the values which has the limit from 0 until and up till this y. Okay, I hope you have got my point, that it will not be larger than this y. Okay, so that's why I have used it. So now here 4xy, and here d of x. Okay, so this is what the concept of this question is. So let me solve it. This will become 0, 1. First solving this integral, which is here. Okay, let me use this color for it. This is this one. First solving this one, and solving it, what I will get, this will become 4y x square divided by 2, and this is from 0 to y, and here dy. Okay, so these two will cancel out. Here it will be 2, and here I will have here 0, 1, and this will become 2y, and putting this limit here, I will get y square, and it will become
dy. Okay, so I hope you have got the concept of this solving it. Okay, so now it will be 2 0 1, here it will be y cube dy, which will be 2 into y4 divided by 4, 0 to 1, this will be here, and here I will have 1 by 2, which is now 1 raised to power 4 minus 0 raised to power 4, okay, which will ultimately give me 1 by 2. Okay, so the solution of part B is 1 by 2, so which is the probability that x will be less than y, and this is 1 by 2. Okay, so that is basically the solution of part C of part B of my question. This is the overall solution of question 3.43. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.45, and the statement of it is, let x denote the diameter of an armored electric cable and y denote the diameter of the ceramic mold that makes the cable. Both x and y are scaled so that they range between 0 and 1. Okay, suppose that x and y have the joint density, which is given by fxy, and that is 1 by y for the values of x which is greater than 0 and less than y, and y is greater than x and less than 1. Okay, and that is 0 elsewhere. So what do we have to do? We have to find the probability that x plus y is greater than 1 by 2. Okay, so now solving it, let me solve it here. So here I want to find out the probability that x plus y that is greater than 1 by 2. Okay, so now in order to find it, we can very clearly see that in terms of CDF, it can also be found out by using the 1 minus probability of x plus y is less than 1 by 2. Okay, so let me find it out, and here we can see that both the values of x and y and the summation of them should be less than 1 by 2. So in order to make this happen, what do we have to do? Let me take the value of x from 0 to 1 by 4 such that the summation of x and y will be less than 1 by 2. Okay, so now let me take the integral so that the first integral will range from 0 to 1 by 4, which is for x. Okay, so this is d of x, and also another integral which is for y. We can see the range of y which starts from x and will end at less than 1 by 2, where the summation of both of them will be 1 by 2. Okay, so it will start at x and will end at what? It will be 1 by 2 minus x. Okay, I hope you have understood that the summation of both of them will be less than 1 by 2. Okay, so this will be what? This will be d of y. Now writing the value of the function which is 1 by y, and that is here. Let me solve it, and here solving it, we can very easily see that this is 0 to 1 by 4, and solving it, we can see that this will be what? This will be natural log of y. Okay, this will be natural log of y, and range of it will be x to 1 by 2 minus x. Okay, and that would be d of x. Now putting values here, what I will get? 1 minus 0 to 1 by 4, and putting values here, I will get natural log of 1 by 2 minus x, okay, minus natural log of x d of x. Okay, at the end, integrating it and solving it all, what we will get, the answer of it will be 0.6534. Okay, and that is what, that is the solution of question 3.45. The only thing you have to understand here is this formula. We have used the range of x from 0 to 1 by 4 because x plus y will be less than 1, and here you can see that the y range will be from x to 1 by 2 minus x. Okay, so this formula is very important for you to understand that how we integrated it and how did we find out the value which we have here. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.46 of chapter 3, which states that referring to exercise 3.38, find A, the marginal distribution of X, and B, the marginal distribution of Y. Okay, so this question is basically most relevant to the marginal distribution of the exercise problem of 3.38. So let us see that what was basically the exercise problem 3.38. I will also put the link of it here, okay, in this corner, so that you can watch it for your revision as well. Also, the link of it will be available in the description as well. Okay, so let us see that what was that problem related to. So here you can see that this is problem 3.38, which is if the joint probability distribution of X and Y is given by this one, okay, for the values of X which are 0, 1, 2, 3 and Y 0, 1, 2. Okay, so on the basis of it, what did we found out for the values of X 0, Y 0, the value of the function is 0, the value of X when 0, the value of Y is 1, the value of the joint probability distribution as 130 and so on. Okay, so this was a table we had generated in this question, and let us take this table and put it in our current problem. Okay, so let us copy it and paste it there. So pasting it here, we can see that this is basically the table which we had. So let me take it and put it here. Okay, so this is the table we had. So now let me see that here we have the value of X 0, so then the values of Y's are given here. For the values of X1, the values of Y are also given here as well. So in part A, what do we have to find out? We have to find the marginal distribution of X. Okay, so for X, when the value of X is 0, we have to do what? We have to add them all. Okay, so here adding them all, what will I get? Here I will have to add 0 plus 1 by 30 plus 2 by 30. Okay, because this is for X, so I have to take the value of X constant and Y values are changing. Okay, so adding them together, it will be 3 by 30 or it will be 1 by 10. Okay, so for X equal to 0, the marginal distribution of X is 1 by 10. Okay, similarly for X equal to 1, I have to add them together now. So let me add them, and here it would be 1 by 30 plus 2 by 30 plus 3 by 30. Okay, so adding them all together, the LCM of it will be 30, and 1 plus 2 plus 3 is 6. Okay, so ultimately it will give me 1 by 5. Okay, similarly here X is 2, so here adding the values of Y here, so I will have here 2 by 30, 3 by 30 and 4 by 30. Adding them all together, what I will get, the LCM of it will be 30, and 2 plus 3 plus 4 is, how much is this? This is 9 by 30. Okay, so it will become 3 by 10. Okay, similarly this one. Okay, now adding them together, LCM is again 30, and it will be 3 plus 4 plus 5, so 5 plus 4 is 9, 9 plus 3 is 12. Okay, so it will be 2 divided by 5. So these are all the values for the marginal distribution of X. So now after taking all these values, which are for different values of X, I have to tabulate it here in the form of the, let me call it X, value of X, and let me represent the marginal distribution of X as G of X. Okay, so now the values of X are 0, 1, 2 and 3. Okay, let me put the corresponding values here. So it will be 1 by 10, here this is 1 by 5, this is 3 by 10, and the last one is 2 by 5. Okay, so this is the solution of part A of our question, in which we can see that this is the marginal distribution of X. Now let me move towards part B of our question, and let me remove these values. Now for the marginal distribution of Y, what do we have to do? We have to take the constant value of Y and add them together, all the values of X which represent that value. Okay, so here the constant value of Y is 0, while the values of X are 0, 1, 2, 3, and for the corresponding values of the joint density, what do we have to do? I have to add them together. Okay, so adding these values, I will have 0 plus 1 by 30 plus 2 by 30 and plus 3 by 30. Okay, so adding them together, what I will get here, it will be 30, and 1 plus 2 is 3, 3 plus 3 is 6, so it will be 1 by 5. Okay, so this is what this is for y is equal to 0. Similarly, for y equal to 1, what do we have to do here? I have to take these values and I have to add them together. This is for y equal to 1, so I will have here 1 by 30 plus 2 by 30 plus 3 by 30 and plus 4 by 30. Okay, so taking the LCM, which is 30, adding all these values, so 1 plus 2 is 3, 3 plus is 6, 6 plus 4 is 10. Okay, so it will be what? It will be 1 by 3. Okay, so this is for y equal to 1. Now for the value of y equal to 2, what would I get? Let me do it here. Here the LCM again is 30. Okay, and values here would be 2 plus 3 plus 4 plus 5, so 2 plus is 5, 5 plus 5 is 10, 10 plus 4 is 14 divided by 30, so ultimately it will be 7 by 10. Okay, so these are the values for y equal to 2. Okay, now taking it and plotting it as we had previously done for x, so here we have y, and let me represent the marginal distribution for y as h of y. Okay, so let me put these values here, and here putting these values for the values of y, which are 0, 1, 2, and putting their values here, it will be 1 by 5 as found out here. For 1, this is 1 by 3 as here, and for 2 we have 7 by 10 as we have done here. Okay, so this is 7 by 10. Okay, so the answer of our questions are, okay, which we had found out by using the tabular form here, from which we have found the marginal distribution for x and y from the density functions. Okay, so that's it for today. If you have any question, you can ask me in the comment box. We will try to solve more questions relevant to this type of problems as well. So thank you so much, and I will see you soon. Welcome back, guys. I hope all of you will be fine. So this is question 3.47, and the statement of it is the amount of kerosene in thousands of liters in a tank at the beginning of any day is a random amount y, okay, from which a random amount x is sold during that day. Suppose that the tank is not resupplied during the day, so that x is less than or equal to y, and assume that the joint density function for these variables is given by fx of y, which is 2, for the ranges of x which is greater than 0 and less than or equal to y, and y greater or equal to x and less than 1 and 0 elsewhere. Okay, so on the basis of this statement, what do we have to find out? We have to determine that if x and y are independent or not, and b, probability of x is greater than 1 by 4, less than 1 by 2, given that y is equal to 3 by 4. Okay, so in order to solve it, let me first solve part A of my question. Okay, and here in order to see that when would these two random variables be independent of each other, we have to see that whether g of x is equal to h of y or not. Okay, so what is this? These are basically the CDFs. So let us first find g of x. So in order to find the g of x, we have to integrate the fx of y, which is 2, with respect to what? With respect to y. Okay, so when I will integrate it with respect to y, I have to put here the limits of y as well, which are from x to 1. So therefore here it will be x1. Okay, or ultimately I will get here, from here I will get what? You can solve it and you will see that here I will get x minus 1 for the range of x greater than 0 and less than 1. Okay, this is for g of x. For h of y, I have to perform the similar operation
for the same fx of y, fxy, which is 2, but here I have to integrate it with respect to x. Okay, therefore I will put the limits of x which are from 0 to y. Okay, so here I will have 0 to y. Okay, and ultimately I will get here what it will be 2y for the y which is greater than 0 and less than 1. Okay, so these are the two required quantities I have found out, and putting them here I will see that g of x is not equal to h of y. Okay, what it says that the two variables x and y are dependent upon each other and are not independent of each other, which is also prominent from the statement of this question as well. Here we can see that, and this basically says that the two random variables are basically dependent of each other. Okay, so that is for part A. For part B, I have to find out the probability of x is greater than 1 by 4, less than 1 by 2, and for the given that y is equal to 3 by 4. So for it I have to first find out the probability of x given that the probability of y. Okay, so it can be very easily found out here, and that would be from the conditional probability, and it would be probability of xy divided by the probability of y, which is basically h of y. Okay, putting it here I will get here. Now putting their values here, the probability of xy is 2. Okay, and the value of it is 2y. So ultimately I will get here 1 by y. Similarly, now putting values here which are from for the values of x is greater than 1 by 4, less than 1 by 2, and y is equal to 3 by 4. So let me first put this value here. So putting this value here, what I will get, it will be probability of x given that y is equal to 3 by 4. Okay, and it is 1 by y. So putting values here, I will get here 4 by 3. Okay, which is the value of y here. Now in order to find our required quantity, which is probability of x greater than 1 by 4, less than 1 by 2, so here it will be the ranges of x which are 1 by 4, 1 by 2, okay, given that y is equal to 3 by 4. Okay, so we have this value here, so just I have to put the limits here which are from 1 by 4 to 1 by 2. Okay, and here we have what, here we have the values which are 4 by 3 and d of x. Okay, so now integrating it and finding the values here, what I will get, I can very easily see that it will be 4 by 3 multiplied by 1 by 2 minus 1 by 4. I will again get here 1 by 4. These two will cancel out, and ultimately the answer of it will be 1 by 3, which is the required quantity or required probability of the question 3.47 part B. Okay, so that's it for today, in which I have solved two parts of the question 3.47. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. I hope all of you will be fine. So this is question 3.48, and it states that referring to exercise 3.39, find part A, f of y given 2 for all values of y, and b, probability of y equal to 0 given that x is equal to 2. Okay, so first of all, let me see that what is problem 3.39, and this is the exercise problem 3.39, and the statement of it is given here, and from it we can very clearly see that the oranges here are basically corresponds with x, and apples here are basically what, y. Okay, these are also given here. If x is the number of oranges and y is the number of apples, so in the sample find the joint probability distribution of x and y. And previously we have found out that the joint probability distribution of x and y is given as what, that was 3 choose x, okay, 2 choice y, okay, and also 3 4 minus x minus y, okay, divided by the 8
choice 4. Okay, this was basically what? This was basically the equation for the joint probability distribution of x and y. So on the basis of it, let me solve this one, and in solving it, let me have it here, and to find the probability of y given 2 or y given x, that would be what? By using the conditional probability, we can have here f of 2 and y divided by the probability of x equal to 2. Okay, so on the basis of it, we can find it here, and then we can find the f y given to for different values of y, and the values of y are basically what? These are 2. Okay, so all values for it would be 0, 1, 2, which means 0 apples, 1 apple, and 2 apples. Okay, so let me find out different values here, and the first value, which is g of 2, how can we find it out here? It can be found out by f of 2 0, okay, or f of 2 1, or f of 2 2. Okay, we can very easily find it out by putting these values over here. Okay, we can see that this is basically the value of x, y, this is the value of y. Okay, similarly this is x, this is y, and so on. So let me put all these values here, and putting them here, I can find out here for the f of 2 0, what would we get here? It would be 3 2, okay, 2 0, and also here 3, and 4 minus x is 2 minus 0, so here 2 divided by what? Divided by 8, choice 4. Okay, so here finding it out, what will we get? It will be 9 by 70. Okay, so let me put it here, it will be 9 by 70. Similarly, f21, putting values here in this formula as well, what will I get? I will get 18 by 70, and also putting 2 2 here, what will be the answer? Here it would be 3 by 70. Okay, you can try it, and ultimately you will get what? It would be 30 by 70, which is 3 by 7. So the value of g of 2 is 3 by 7. Here using this equation, let me call it equation A, and using equation A, what I will get here, putting this 3 by 7 over here, I will get f y2 is equal to f of 2y multiplied by 7 by 3. Okay, so these are all the values which we had to find out. Now I have told you previously that the values of y basically ranges from 0 to 2. So let me put here the value of y equal to 0 given 2. So putting it here, I will get f 2 0 multiplied by 7 by 3, and it would be what? This is basically given here, and putting 9 by 70 here, which I have already found out by putting values here. So it will be 9 by 70 multiplied by 7 by 3. So it will be 7 10 3 3. Okay, so it would be 3 by 10. Okay, so f of 0 2 is 3 by 10. This is what we had to find out. Let me move down somehow. Okay, similarly here f of 1 given 2, that would be the value of y is equal to 1 when given that the value of x is equal to 2. So it would be 2 1 multiplied by 7 by 3. So it would be 1. It would be what? As we have seen that it is here. So 18 divided by 70 multiplied by 7 by 3. Okay, 3 6 and 7 10. Okay, so I will get here 3 by 5, and that is for f1 2, and also f2 2 is f2 2 multiplied by 7 by 3, so its value is also given, that is 3 by 70. So 3 by 70 multiplied by 7 by 3, these two will cancel out, while here I will get 1 by 10. Okay, so these are different values which are given. Okay, so in tabular form, which can also be tabulated here. So here if I have different values of y, and here we have f of y given to, so what I can do here is that let me have here the table in which the different values of y are 0, 1, 2. Okay, and also let me have here this table, and putting values here, what I will get for 0 I got 3 by 10, it was 3 by 10, for 1 it was 3 by 5, and for 2 it was 1 by 10. Okay, so this was what? This was the solution of part A of our question. Now moving towards the part B of our question, find the probability of y equal to 0 given x equal to 2. This is also similar to f of 0 given 2. Okay, so f of 0 given 2, let me see that whether I had found it out or not. Okay, this is already given here and this is here, so the probability that y is equal to 0 given that x is equal to 2, this is also the joint density such that y is equal to 0 given that x is equal to 2. Okay, that is already known, and this is here we had already found it out, and this was 3 by 10, which is what? Which is the solution of part B of our question. So that's it for today, and we can see that this was part B of our question, and we have seen the solution of part A and part B of our question 3.48. If you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. So this is question 3.49 of chapter 3, and the statement of it is, let x denote the number of times a certain numerical control machine will malfunction 1, 2 or 3 times on any given day. Let y denote the number of times a technician is called on an emergency call. Their joint probability distribution is given as a table which is given here. Okay, so you can see here that here the vertical lines basically shows the values of x, while here the horizontal lines basically shows the values of y. Okay, and their combined joint probability distribution has been shown as tabulated here. So on the basis of this table, part A of it, evaluate the marginal distribution of x, B, evaluate the marginal distribution of y. Okay, so let us first find the marginal distributions of x and y, and I have previously told you that in order to find the marginal distribution of x, what I have to do is to make the values of that variable constant. Okay, just like here, if I want to find the marginal distribution of x, what do you have to do? You have to make the value of x equal to 1 and then add them all together. If you want to find the marginal distribution of x at equal to 2, what do you have to do? You have to add all this column and here as well. Okay, so let me have here this one, and here in order to find the marginal distribution, let me have here x. Okay, and its marginal distribution, let me have here, this is g of x. Okay, so now the values of x are 1, 2 and 3. Okay, so these are basically the values, and what are their corresponding marginal distribution? I have to add them together. So here I will have to add 0 0.05, 0 0.05 and 0.00. So adding them all, which corresponds with x equal to 1, I will get 0.10. Okay, similarly for x equal to 2, what I will get? I have to add 0 0.05, 0 0.10 and 0 0.20. Adding them together, I will get 0 0.35. And for x equal to 3, I have to add 0 0.10, 0 0.35 and 0 0.10. Adding them together, I will get 0.55. Okay,
this is basically the marginal distribution of x, and adding them all together, if you will add all these values, you can very easily see that these will be added to 1, which is the prime condition for any probability distribution. Okay, so that is for what? That is for x. Okay, so let me remove it and move to part B of our question. Okay, in part B, it is asking us to evaluate the marginal distribution of y. Okay, so this was A. Now let me move to B. So again, let me have here the different values of y, and let me have here h of y, which is for the marginal distribution of y, and let me put different values of y, which are 1, 3 and 5. Okay, so let me find them out, and here I have told you that in order to find the marginal distribution of that variable at any corresponding value, what do I have to do? I have to add them together. So here for y equal to 1, what do I have to do? I have to add these values, because you can see that here y is equal to 1. So adding them together, what will happen here? Adding 0 0.05, 0 0.05, 0 0.10, here we will get 0.20. Okay, similarly here, adding the values at y equal to 3, I have to add all these values in this. Okay, because now value of y is equal to 3, so 0 0.05, 0 0.10, 0 0.15 and 0 0.35. so what I will get here, let me have here this, so 0.50, and the last one here is at 5, y equal to 5, here 0 0.00, 0 0.20, 0 0.10, so here 0.30. Okay, so this is what, this is the marginal distribution for y, and again adding them 0 0.20, 0 0.50, 0 0.30, what I will get here, adding them together, I will get 1, which is the condition for the probability distribution. So this is, that's it for the marginal distribution of x and y. Now let us move to part C of our question, and here we have to find the probability of y equal to 3 given that x equal to 2, and this is C. So here I have to find out the probability that y is equal to 3 given that x is equal to 2. Okay, so in order to find it out, I have to use the conditional probability, and in conditional probability finding it out, I will have here the joint probability of x equal to 2 and y equal to 3, okay, divided by the marginal distribution of x equal to 2. So here I will have g is equal to x equal to 2. Okay, so let me put these values. From where will I get this value? Okay, this value, so this value can be very easily found out. For x equal to 2, this is x equal to 2, and for y equal to 3, this is y equal to 3. So 0 0.10 is the value I have to put here. So 0 0.10 is the value I have to put here. And did I find out the value that g x equal to 2? Yes, this is already known, and this is 0 0.35. Okay, so 0.35 has been obtained from the values that 0 0.05, 0 0.10, 0 0.20. So adding them together, what I will get, I will have here 10 divided by 35, or 2 by 7. Okay, so that is what, that is basically the solution of part C of our question, in which we have seen the usability of marginal distribution, which is here, and also the joint probability distribution, which is here. Okay, and the ratio of them has been given me the conditional probability, which has been obtained here. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.
Hello guys, this is question 3.50 of chapter 3, and the statement of it is, suppose that x and y have the following joint probability distribution, which is given as a table here. Okay, so on the basis of this table, what do we have to find out? We have to find the answers of part A and part B of our question. So in part A, find the marginal distribution of x, and in part B we have to find the marginal distribution of y. Okay, so previously I have told you how to find it out. This is basically the solution, and in solving it, what we did previously is that if you want to find out the marginal distribution of x, okay, so let me have here, this is part A, and if you want to find the marginal distribution of x, here I have to write x, and let me represent the marginal distribution of x as g of x. Okay, so we have different values of x. Okay, so here we have a table, and in this table we have 2 and 4 as the values of x. This is 2, this is 4, and here we have on to find the marginal distribution of them. Here I have to do what? These are the values, and on the basis of this table we have to find the marginal distribution of x at 2. So I have to add this value, and this value, because this is at 2, and therefore I have to add all the values which are in this column. So 0.10 plus 0.20 plus 0.10, this is 0.4. Okay, so let me write it here. This is 0.40. Okay, and similarly for 4, this is the column which corresponds with x equal to 2. So here let me add them. So 0.15 plus 0.30 plus 0.15, so this is 0.60. Okay, so this is what? This is the marginal distribution of x. Similarly, to find the marginal distribution of y in part B, again let me have here y, and to represent the marginal distribution of y, I have here h of y. Okay, so this is basically the table, and what are the values of y? Here we have 1, 3 and 5. So let me write them: 1, 3 and 5. Okay, so these are the values. Now in order to find them out, let me remove them. Okay, and here in order to find their values, for y equal to 1, to find the marginal distribution of y, I have to add these two values. So it would be 0.10 and 0.15. This is 0.25. Okay, similarly for 3, 0.20, 0.30, so it would be 0.50, and for 5, these are the values, and adding them together I will get 0.25 as well. Again, you can very easily see that by adding it you will get 1, and similarly by adding them all you will again get 1, which is the proof that this is a probability distribution. So that's it for today, in which we have found the solution for the marginal distribution of x and y for a given table of the joint probability distributions. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is question 3.51 of chapter 3, and the statement of it is 3 cards are drawn without replacement from the 12 face cards, which are jacks, queens and kings, of an ordinary deck of 52 playing cards. Let x be the number of kings, okay, and y be the number of jacks. So on the basis of this data we have two parts. So let me first write the given data here, and in given data we have here the total number of cards, which are 12, and from these 12 I have to select 3 cards. Okay, so these 3 cards can be composed of x, y or queens. So here I will have the representation of kings, okay, or the number of kings is x, and the number of jacks is y. Okay, while the remaining are the queens, which are basically x minus y. Okay, so we have x, y and x minus y cards, and from 12 cards I have to select 3, and here the part A of this question is we have to find the joint probability distribution of x and y. Okay, so let me have a solution of this question. So solving it, this is
part A of my question. And in part A, the total number of combinations by selecting 3 cards from 12 which we will have here would be, this is basically the total, and it will be 12 choice 3. Okay, so finding the solution of it, I will get 12 factorial divided by 3 factorial multiplied by 12 minus 3 is 9 factorial, which is basically 220. So the total number of combinations which we can have here are 220. But in order to find the joint probability distribution of x and y, let me have here this f. So let me represent them with x and y. Here what we can do here is the combinations of three cards from x, y and x minus y, which are coins, divided by the total number of combinations. Okay, so we know the total number of combinations, which are 220, but we don't know the combination of three cards. So let me have here, so initially the 4 cards we have are the kings. So king has 4 cards. Similarly, jacks has 4 cards as well, and the remaining queens are also composed of 4 cards. Okay, so dividing it over 220. But what should be here the choices? From 4 I can have x number of kings. Okay, from these 4s which are jacks, I will have y number of jacks, and from this which are the queens, and we know that here we don't encounter the queens, so therefore the 3 cards here we will have the total, while from it I have to subtract the number of cards I have here. Okay, so let me correct it as well here. Okay, so here we will have these number of cards. So this is what, this is the formula for the joint distribution of x and y, and this is basically the essence of the question which we are going to solve today. Okay, so this is what we have. Now on the basis of this formula, let me draw the table in which I will write the joint distribution, okay, or joint probability distribution of x and y. So let me have here different values of x and y. So here we have x and here we have y. So y values are 0. Let me use another color for it, and yes, let me use this green one. So here 0, 1, 2, 3. Okay, why the 0, 1 and 3? Because here we can see that either x can have 0, 1, 2 or 3 values. Okay, here all the cards selected would be king, or I can have here y where I will have here 0, 1, 2, 3, where this is the lowest value and this is the highest. It means 0 means no jack, while 3 means all here are jacks. So on the basis of this one, we can also write the condition for this as well, which is the x plus y will be greater or equal to 0, and it can also be less than or equal to 3, which is the lowest possible condition for this one, and this is basically condition for the formula which I have previously derived. Okay, so these are the quantities we have. Similarly for x, I can write here 0, 1, 2, 3. Okay, so on the basis of it, I have to make these selections and I have to write the formula, and in this formula this 0, 0 is for f 0, 0, this 0, 1 would be for f 0, 1, this would be for f 0, 2, and so on until and unless we will have here f33. Okay, but remember that here I have to encounter all these values in which x plus y is at most equal to 3, while all the values which are greater than 3 are neglected here. Okay, you have to keep in your mind, like here I will have 3, 0. Okay, it will be included because 3 plus 0 or x plus y is within this range, while here if I will write 3, 1, so here x plus 1 x plus y, which is 3 plus 1 is 4, which is not in this range, so therefore we will neglect this one. Okay, so now let me remove them and let me write the values, actual values which we will have here. Okay, so let me remove it and let me draw this table again with this color. Okay, so this is what, this is the table. So now in order to write here the value 0 0, let me write here 0 0, putting this x equal to 0, y equal to 0 here in this formula. What I will get here, it would be 4 0 4 0 again, and here x plus y is 0, so 4 choice 3 and dividing it over 220. Okay, now solving them here, 4 0 is 1, this 4 choice 1 is also 1, while this 4 choice 3 is 4. Okay, dividing it over 220, what I will get here, it will be 1 over 55. So let me write this value here, 155. Similarly for 0 1, let me remove this 0 from here and write 1 here. Similarly here it will become 1 and it will become 2. Okay, so now this 4 0 is 1, this 4 1 is 4 here, while this 4 2 is now 6. Okay, so now it will become 6 by 55. Okay, similarly putting now this for this, this is 0 2, so this is 0 2, this is 2, this is, it will become 1, and similarly changing these values, what I will get here, again here I will get 6 by 55. Okay, so you know that how to fill this table. Let me fill it out with the values I previously had found out. So it will be 1 over 55, similarly it will be 6 over 55, here 16 over 55. Okay, and this is again 6 over 55. This value will be neglected because 1 plus 3 x and y values are greater than this 3, which are 4, so I am neglecting it. Similarly here it will be 6 over 55. Okay, it will be 6 over 55 as well, while neglecting these two because 2 plus 2 and 2 plus 3 are greater than 3, and this is the last one where this is 1 over 55. Okay, so now this is what, this is the joint probability distribution of x and y, which is the solution of part A of our question. You have seen that how I have found out by using the formula which I have previously derived here. Okay, so similarly on the basis of all these things, I have to solve part B of my question, in which the probability of x and y, where this is the member of A and where A is the region given by x y, such that x plus y is greater than 2. Okay, so this is part B, and I have to write or find the probability that such that x plus y is greater or equal to 2. Okay, which can be found out by subtracting the other range of it, which is x plus y is less than 2 from 1. Okay, so let me see that what are the values here in which x and y and summation of them is less than 2. So this is 0 0, and 0 plus 0 is 0, which is less than 2. Similarly here 0 plus 1, this is 1, which is less than 2 as well. Okay, and this is 0 plus 2, this is not less than 2, while the equality condition is not given here, so this is not included. Similarly 1 0, this is 1 plus 0 is less than 2, and this is also included. So let me include these three values here and add them together. I will get 1 minus 1 over 55 plus 6 over 55 plus 6 over 55 as well. Okay, so it will be 1 minus, adding them all together, what I will get, 6 plus 6 plus 1 is 13, 13 divided by 55. So ultimately subtracting it from 1, I will get 42 over 55, which is the solution of part B of my question. Okay, so that's it for today, in which we have seen the solution of part A and part B of our question 3.51. If you have any question, you can ask me in the comment box. See you soon.
Hello guys, this is question 3.52 and the statement of it is a coin is tossed twice. Let Z denote the number of heads on the first toss and W the total number of heads on the two tosses. Okay, so with the passage of this question, let me write the given data as well. Okay, so we have two tosses, the total number of tosses are 2. Okay, and Z denote the number of heads on the first toss. So Z denotes the number of heads in the first toss, which can be 0 or 1. Okay, and similarly W the total number of heads on the two tosses. So W is, it can be 0, no toss, no heads, 1 and 2, and 2 is the maximum value in which two tosses has the heads as well. So now in order to see that if the coin is unbalanced and a head has a 40% chance of occurring, which means the probability of heads is 0.4, which ultimately says that the probability of tails is 1 minus 0.4, and that is 0.6. okay, find the joint probability distribution of W and Z. Okay, so that is part A. Let me solve part A of our question first. This is solution. Okay, and in part A of our question, let us denote the joint probability distribution of it as F, W and Z. Okay, where what is W? That is the total number of heads in the two choices, while Z is the head in the first toss. Okay, so values of Z can be 0 and 1, while it can be 0, 1 and 2. Okay, so now in order to find the probability of any event here, what can we do? We have to multiply the probability of heads in the two events. So for this also, let us have a table in which let us denote the, okay, this is a table, and here let us have Z and here W. So now the values of them are, the Z values are from 0 to 1, while W's are 0, 1 and 2. Okay, also let me draw it here as well. Okay, it is like this one. Now in order to find the probability or F 0, 0, what does it mean? That the number of heads in the first toss is 0 and the total number of heads are also 0. So therefore the two tails has occurred. So therefore I have to multiply probability of tail multiplied by probability of tails, and that would be 0.6 multiplied by 0.6, which is 0.36. Okay, so the value here, let me represent it with this one. This is 0.36. Okay, similarly now F, the total number of heads here are 1, while the number of occurrence of the heads in the first toss is 0. Okay, so this is what we have, in which we can see that the second one will have the heads. Okay, so therefore I will have here probability of heads multiplied by the probability of tail. Okay, so it would be 0.4 multiplied by 0.6, so it would be 0.24. let me write it here as well. So this would be 0.24. okay, now this one is not possible. Why is it not possible? Because it is saying us that, let me write it with this color, that we have the total number of heads equal to 2, while in the first event or in first toss we have got 0 heads. So it is not possible, because in the second trial we cannot get a cumulative 2 heads. Okay, so therefore this one is not possible, so therefore we will leave it as it is, and it is not possible in this experiment. Now similarly, let me have here this one, and here it is saying that the cumulative is, let me write here as well this one, that it is saying us that the summation is 0, while in the first
trial we have got 1 head, so it is again wrong. So it is again not possible here as well. So therefore we will leave this one as well. Now this one here we have F1 1, in which it is saying that in the first trial we have 1 head, and the total number of heads after the 2 trials we have the total number of heads equal to 1. So therefore it is saying that in the first trial we have 1 heads, while in the second one we have tail. Okay, so let me write their probabilities. So it would be 0.4 and 0.6, so it would be 0.24. okay, so let me write it here, the value. So it is 0.24 here as well. This last one, which is the value which saying that the total number of heads we have got are 2, in which the first trial has given me 1 heads. Okay, so what does it mean? It means that the 2 tosses has ended up with 2 heads. So therefore we will have here the probability of heads multiplied by the probability of heads. Okay, so here we will get 0.4 multiplied by 0.4, and it is 0.16. okay, let me write it here as well. So 0.16. okay, so that's what that is basically the joint probability distribution for the event which is given here. Okay, so that is the solution of part A. Now let us proceed to part B of our question, and it is saying that to find the marginal distribution of W. Okay, let me solve it here. To find the marginal distribution of W, let me have here W and all the values of W. So we can see that the values of W are 0, 1, 2, and its marginal distribution, let me represent it with G of W. So here it is. Now in order to find the marginal distribution of it, we know that what do we have to do here? We will add all the values for 0 here. Okay, then all the values for 1 here and all the values for 2 here. So adding them together, 0.36 plus 0, here we will get what? Here we will have 0.36, because 0.36 plus 0. W for column 1, here we have 0.24 and plus 0.24. this is a single column, so adding them together we will get 0.48. okay, and the last one here we have for 2, we have here 0 and this is 0.16. so here let me move it somehow here as well. So it is 2, so adding them together I will get 0.16. okay, so it is here, this is for 2, this is for 1, and that's it. And adding them together I will also get that we will have here 1, which is basically the condition from the probability distribution, and that is what, that is the marginal distribution for W. Now for part C, we have to find the marginal distribution of Z, which is here the row wise items. So here we have Z. okay, and let me represent the values of it as H of Z, which is the marginal distribution for Z, and the two values of Z are 0 and 1. okay, now looking at it, we can see here that for this 0 we have to add these values together. So this is 0.36 plus 0.24 plus 0, so we will get here 0.60. okay, now similarly for 1 here we can see that we have to add all the elements in this row. So here adding them together, this is 0, 0.24 and 0.16. so ultimately we will get here what? The value of it will be 0.40. so that is what, that is the solution of part C of our question. Now the last part of our question is the probability that at least 1 heads occur. So this is part D, and we have to find the probability that the number of heads are greater or equal to 1. okay, so here we can also find it out by 1 minus probability of heads which are less than 1, which is that the probability that heads is equal to 0, and this is only the value which is here. So let me put it here, and it would be 0.36. okay, subtracting it from this one we will get 0.64, and that is what, that is the solution of part D of our question. okay, so here we can see that we have solved our problem in which we had, this is part A of our question, this was part B, part C, and this is part D of our question. So you have seen that how to find the joint probability distribution from a given statement, and then marginal distribution, and then conventional probabilities of certain events from that table. So if you have any question, you can ask me in the comment box. See you soon.
Welcome back, guys. This is question 3.53, and the statement of it is, given the joint density function which is fx of y, and that is 6 minus x minus y divided by 8, which is for the x greater than 0 and less than 2 and y greater than 2 and less than 4 and 0 elsewhere. We have to find the probability that y is greater than 1 and it is less than 3 given that x is equal to 1. Okay, so that is what we have been given. In order to solve it, let me solve it first. Okay, in order to find the probability of y given x, we have to use the conditional probability, because here we have a condition that x is given. So in order to find it out, we have to use the conditional probability in which the joint density function is given as fxy and dividing it over the g of x. Okay, so this is equation A, and in this equation let me first find g of x. Okay, so g of x is what we have to integrate the function which is here, which is 6 minus x minus y whole divided by 8 and integrated with respect to y. Therefore I have to write the limits for y, which are 2 to 4. Okay, so let me integrate it, and it would be the constant outside, and here we will have 2 to 4, and the function here would be 6 minus x minus y. Okay, and dy. Okay, this is also the bracket. Now in order to solve it linearly, let me put it here, and it will be like 6 will be outside, 2 to 4 dy, also minus x will be constant for y, so therefore it will be y 2 to 4 dy, while for this y I will have 2 to 4 y dy, and here it is. Okay, so let me solve it, and it would be 1 by 8. Here we will get 4 minus 2, because here we will get y, so let me do it first. Here we will have y 2 to 4 and minus x, and here again y 2 4, and here we will have y square divided by 2 and 2 4. Okay, let me put these values, and here we will get 1 by 8, and here 4 minus 2, 4 minus 2 is 2, and 2 multiplied by 6 is 12. Okay, here again 4 minus 2, so I will get here 2x. Okay, here what will I get? It will be the 1 by 2 constant. Okay, and 4 for 16, 16 minus 4 is 12. Okay, so it will be what? It will be 6 here. Okay, so 12 minus 6 would be what? This will be 1 by 8, and here 12 minus 6 is 6, 6 minus 2x. Okay, or ultimately what will I get? Here we will get 1 by 4, and here 3 minus x. Okay, this is what? This is the g of x what we have here. Okay, so let me take it and put it in equation A. So in putting it in equation A, we will have y given x, and here we will have fx of y is 6 minus x minus y whole divided by what? 8. Okay, and dividing it to a what? 3 minus x. Okay, whole divided by 4. So ultimately what I will get? It will be 6 minus x minus y dividing it over 3 minus x. Okay, and also this 8 4, so I will get here 2. So this is what? This is for the probability of y given x. This is the equation. Now in order to find these values here, let me put the value of x equal to 1 here.
Okay, so putting x equal to 1, what will I get here? It will become y given x equal to 1. Okay, this is step 2 in which I have been putting the value of x here. So putting value of x here, I will get 6 minus 1 minus y, dividing it over 2, 3 minus 1. Okay, so here I will get 5 minus y whole divided by 3 minus 1 is 2, 2, 2, 4. So this is what 5 minus y divided by 4. This is for the probability of y given x equal to 1. Okay, let me move down somehow, and the last step here is to find the probability within this range. Okay, so what will I have to do here? I have to find the probability that y is greater than 1 and less than 3, given that x equal to 1 and the value of it is already given here. But in order to find this value here, in order to find it out, what do I have to do? I have to integrate this function from these values. Okay, so I have to do what here? I have to integrate the values from 1 to 3, but as we can see here very clearly, let me see the limits of y within this density function. We can see that it starts from 2 up to 4, so therefore this one will not be available here. So I have to start it from 2, and as the ending point here is 3, so therefore it will be 3, and therefore I have to put the values which are here. So it will be 5 minus y divided by 4 and integrating it with respect to y. Okay, so here putting the values here, it will be 1 by 4, and also it will be 5 2 3 dy, and also here minus 2 to 3 y dy. Okay, so this is what we have. Let me move down somehow, and here solving it, I will get 1 by 4 and 3 minus 2 is 1. Okay, because here I will get y, so 3 minus 2 is 1, this is 5. Also here this is y square divided by 2, so 3 minus 2 would be what? Let me put this value here, y square divided by 2, this is 3 to 2. Okay, this was y here, that's why I have solved it very easily. So 1 by 4, okay, 5 minus this is 1 by 2. Okay, so 3 3 9, 9 minus 4 is 5. Okay, so it will be here, so 5 minus 2.5 would be 2.5 divided by 4, or it in your book the answer is 5 by 8, so it can also be written as multiplying the numerator denominator by 2, I will get 5 by 8. So that is the solution of the question 3.53. Okay, so what was the essence here? First we have found out the probability of y given x, then putting the value of x equal to 1, we have found the value for x, and then at the end we have found out the values for the ranges of y, and that is basically found out by integrating the given values or the values we have found out from the given ranges. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 3.54, in which we have to determine whether the two random variables of exercise 3.49 are dependent or independent. Okay, in order to see that what is meant by dependent or independent, so the two random variables are independent if and only if f(x) of y, which is the joint probability distribution, is equal to g of x multiplied by h of y. If this condition holds for all values of x and y, then those random variables are basically independent of each other. So here we have to check the same property for the random variable which we have seen. So let us move to question 3.49 and see what was given there. So this was basically question 3.49, where we had this table, and let me remove it. Okay, In this table, we can see that those were all the values of f of x, while g of x values were calculated. So this is question 3.49, and here we can easily see that this is for fx of y, while these are for g of x and h of y. In order to see that whether the two random variables x and y are independent or dependent of each other, what we have to see? We have to see that whether fxy is equal to g of x multiplied by h of y, whether this condition holds for all the value of x and y or not. Okay, so if any one of the value doesn't satisfy this one, so it means the two variables are dependent of each other. So okay, so let me first find it out for x equal to 1 and y equal to 1. Okay, so which means we will have here f11 will be equal to what? It will be equal to g1 and h1. Okay, so f11 is equal to what? You can see that f11 is 0.05. Okay, so f11 is, let me put 0.05. The value of g1 is equal to what? Let me see here that what is the value of g1? That is 0.10. So here it is 0.10, and multiplying it with h1. So what is the value of h1? h1 is 0.20. Okay, so multiplying them together, these two will be multiplied together, and multiplying them together, you will see that these two values are not equivalent of each other. Okay, so f11 is not equal to g11, which says that the two random variables x and y are dependent of each other and these are not independent. So that is basically the solution of the question 3.55, which we have previously seen. So let me move to that question, and this is the question 3.54, in which we have seen that two random variables x and y are not independent and these are basically dependent of each other. Okay, similarly you can apply the same concept for question 3.55 as well, where checking this formula for all values of x and y will show you that whether the two random variables x and y are dependent or independent. Okay, so let us also see question 3.50 as well. So this was basically the question 3.50. Here, in order to check that whether x and y are independent or dependent of each other, we have to check that here the value of x is 2 while the value of y is 1. So we have to check that whether f21 is equal to g of 2 multiplied by h of 1 or not. Okay, so what is f21? That is 0.10. So let me put it here, 0.10, and the value of g of 2, that is, let me see that this is 0.40, multiplying it with h of 1, 0.25. Okay, 0.25. So when these two will be multiplied together, we will see that it will also be equal to 0.10. Okay, so it says that the first two values are equal, so it shows that the one pair of values are equal. Similarly, for the second value, you can also check it for let me check it for this one. So here 1 should be equal to g of 4 multiplied by h of 1. Okay, so f41 is equal to what? That is 0.15. Okay, and what is g4? This is 0.60, and h1 is what? This is 0.25. Okay, so when you will multiply it, you will also see that this will also be equal to 0.15, and that is basically the proof that at these values these two when multiplied together will give me the answer which is equal to fx of y. So you can also check it for all the values of x and y, and you will see that all these values will satisfy the equation fxy is equal to g of x h of y. Okay, so which is the proof that the two random variables x and y are independent of each other. Okay, so let me move to the main page, and here question 3.55, the two random variables are independent of each other. Okay, so in question 3.54 the two random variables were dependent of each other, while in 3.55 the two random variables were independent of each other. Okay, so that's it for today, in which I have illustrated the concept of dependence and independence of the two random variables. If you have any question, you can ask me in the comment box. See you soon. Hello guys, this is question 3.56, and the statement of it is the joint density function of the random variable x and y is fxy 6 for x greater than 0 and less than 1, and y greater than 0 and less than 1 minus x, and this is 0 elsewhere. So on the basis of this given data, part A show that x and y are not independent. Okay, so let me solve it, and the solution of part A is, first we have to see that what is the condition for the independence. Okay, so the two variables or two random variables will be independent if x y will be equal to g of x multiplied by h of y. Okay, if this condition is satisfied for each value of x and y, then those random variables will be independent of each other. Just like here x and y, we have to check that whether this condition lies or not. So for this, first we have to find out g of x and h of y here. So in order to find g of x here, what do we have to do? We have the random variable 6x, so we have to integrate it, and integrate it with respect to y. Okay, so the y range basically starts from 0 and ends at 1 minus x. So let me take this and ends at 1 minus x. Okay, so let me take it, and here integrating with respect to y, this 6x will be treated as the constant, so it will be out of this integral. Okay, and 0 1 minus x, and here dy. Okay, also here 6x, and here we will have y 0 1 minus x. So ultimately the g of x will be what? G of x will be 6x 1 minus x. Okay, this is for g of x, and here we have it. Okay, this is for g of x. Now let me take it for h of y. So for h of y, we have to integrate the same function, which is 6x, but we have to integrate it with respect to x. Okay, so here we can see that the limits of x are given, but in order to put the variables here, we can see here that y is less than 1 minus x. Y is less than 1 minus x. Okay, or let me use another color for it. Let me take this color. So y is less than 1 minus x, so therefore x is also less than 1 minus y. Okay, treating them as it is, we can see that the range of x is also from 0 to 1 minus y. So let me put them here as well. So I will get here 0 to 1 minus y. Okay, I hope you have got my point, that here this is greater than 0, and similarly here this is, so therefore this condition lie here as well. Okay, so let me integrate it, and integrating it, this will be 6 multiplied by x square divided by 2, and here it would be 0 1 minus y. Okay, so here we will get 2 3. Okay, and also 1 minus y square, and this is what? This is h of y, which we have just found out. Okay, so these are the two variables we have found out. Now in order to see whether condition A lies or not, so for fx fy we have 6x. Okay, we can see that this is fxy is 6x. Okay, let me multiply g of x and h of y. Okay, let me put their values. 6x 1 minus x multiplied by 3 1 minus y square. We can see here very clearly that fx of y is not equal to g of x h of y. Okay, you can see that here this one and this one, these two quantities are not equal, so therefore the two variables x and y are not independent. Okay, basically these are dependent of each other, and you can also see it from this equation as well, that the value of y basically dependent upon the value of x as well, so therefore these two are dependent of each other. Okay, let me move to part B of my question, and here in part B we are asked to find x is greater than 0.3 given that y is equal to 0.5. Okay, so again we have to find the probability that x is greater than 0.3 such that y is equal to 0.5. Okay, let me put their values, and as you can see that this is the conditional probability, so therefore I have to put here fxy and also dividing it over this h of y. Okay, we have the values of both of them. This is 6x, okay, as given in the statement of this question, and hy is already calculated, and this is where it is. Let me see, here it is. Okay, this is 3 1 minus y whole square, or we can also see that this is 2x divided by 1 minus y whole square. Okay, as the value of y is already given and that is 0.5, so we can also see that putting it here we will have 2x divided by 1 minus 0.5 whole square. Okay, so finding it out we will have 2x divided by 1 minus 0.5 is what, that is 0.5. 0.5 square is 0.25. Okay, now in order to find different values for x here, we can see that when x is greater than 0.3 and the value of y is also 0 is equal to 0.5, we have previously seen that x basically ranges from 0 up to 1 minus y, which was given. Okay, as the value of y is now given, you can see that this is now here 0.5 and that is greater than 0, means now the value here is replaced by here because x must be greater than 0.3, so the new value of x will be from 0.3 up to 1 minus y, so 1 minus 0.5 here because the value of y is already given. So taking it, the range of x will be from 0.3 up to 0.5, because here we can see that the lowest value here is 0.3 and the highest value of it will be 0.5. So therefore we have to find out the probability of x greater than 0.3 and less than 0.5 given that y is equal to 0.5. Okay, so in order to find this value here, okay, in order to find out this value here, what do I have to do? I have to perform integration within this limit, so it will be from 0.3 to 0.5 and the value here it is 2x divided by 0.25 d of x. Okay, so now let me take it out. This is 2 by 0.25. Okay, and integrating it, what I will get here x square divided by 2 and here 0.3 0.5. Okay, so these two will cancel out
Okay, so now solving it, what I will get here, it would be 1 over 0.25 and multiplying it with the value 0.5 square minus 0.3 square. Okay, so calculating it, what you will get here, you will get 0.64, which is basically the answer of my question. Okay, so that's the answer of part B of my question, in which I have basically found out the probability that x is greater than 0.3 given the value of y 0.5, and I have also find it out by using the conditional probability theorem. Okay, so that's it for today, in which we have solved question 3.56. If you have any question, you can ask me in the comment box. See you soon.